Learn JavaScript essentials with this course that covers everything from object-oriented programming fundamentals to advanced asynchronous techniques. Steven Garcia will teach you critical concepts, including objects, prototypes, ES6 classes, modules, and the Node ecosystem, while building practical skills through hands-on examples.
Welcome to JavaScript Pro, the comprehensive course designed to take you from intermediate to advanced level JavaScript. JavaScript is everywhere. From dynamic websites to mobile apps, mastering it is the key to unlocking opportunities as a developer. This isn't just another JavaScript course, it's a step-by-step guide into the features of the JavaScript language. This course is for developers looking to level up their skills. What truly sets this course apart is our teaching style. I use the active recall technique popularized by Cal Newport, the author of Deep Work and a computer science professor. This technique engages your brain in a way that helps you truly internalize concepts by actively practicing how to retrieve them from memory. In every section, you'll encounter carefully crafted study questions, designed not just to teach, but also to challenge you. We'll go over a possible answer for every single question, helping you fill in any gaps of your understanding. Plus, there's an accompanying ebook and PDF that includes all the questions and answers, so you can review and reinforce your knowledge anytime. This course is designed to actively engage all learning styles, visual, auditory, reading, and kinesthetic, so that no matter how you learn best, you'll find an approach that works for you. Every lesson is structured to utilize multiple senses and areas of the brain to maximize retention and understanding. We start with the fundamentals of advanced JavaScript, covering object-oriented programming, prototypes, ES6 classes, and modules. You'll dive into practical tools like Babel, Webpack, and Node.js to build projects that mirror real-world scenarios. My goal is to teach you how to think like a professional developer. By the end of this course, you'll have the skills, confidence, and mindset needed to tackle complex JavaScript problems, ace job interviews, and have the fundamental programming skills needed to build apps. So let's go over what you'll learn in the 9 sections of JavaScript Pro. Intro to Advanced Topics. We start with the essentials, an introduction to advanced JavaScript concepts, and how this course is structured to maximize your learning. You'll set up a professional development environment and gain an overview of the key skills you'll develop throughout the course. This section lays the foundation for a smooth, productive learning experience. Objects. Master the core principles of object-oriented programming, also referred to as OOP, including the 4 pillars, which are encapsulation, inheritance, abstraction, and polymorphism. You'll learn how to create and manipulate objects using different approaches like object literals, factories, and constructors. By the end of the section, you'll understand how to manage properties, use getters and setters, and handle concepts like abstraction and private properties, which are all critical for building scalable and maintainable code. Prototypes. Discover how JavaScript's prototypical inheritance works under the hood. Explore key concepts like inheritance, property descriptors, and the difference between prototype and instance members. You'll also learn when and why to avoid extending built-in objects and how to iterate through prototype members effectively. Prototypical inheritance. Build on the previous section with a deep dive into creating and managing your own prototypical inheritance hierarchies. You'll learn how to reset constructors, call superconstructors, override methods, and even implement polymorphism. By the end of this section, you'll know how and when to use inheritance in real-world projects and how to enhance functionality with Mixins. ES6 Classes. Transition from traditional prototypes to modern ES6 classes. This section covers class syntax, inheritance, and static methods. You'll also dive into advanced topics like using symbols and WeakMaps for private members, hoisting, and method overriding. These are the tools that will make your JavaScript cleaner, more maintainable, and align with modern best practices. ES6 Tooling. Master the tools that power modern JavaScript development. You'll learn how to use modules, both CommonJS and ES6, as well as how to optimize your workflow with Babel and Webpack. These tools will allow you to write cleaner, more efficient code and ensure compatibility across different environments, which is a must-have for professional developers. Node Module System. Get started with Node.js and understand how it enables JavaScript to run on servers. You'll explore Node.js architecture, the module system, and key built-in modules like path, OS, file system, and events. By the end of this section, you'll know the fundamentals of Node.js required to create powerful, scalable backend systems and understand how the module wrapper function and event-driven architecture work. Node Package Manager. Learn how to manage project dependencies like a pro. This section covers everything from creating and managing package.json files to installing, updating, and publishing packages. You'll also explore semantic versioning and best practices for working with global and local packages. These skills are crucial for maintaining efficient, collaborative development workflows. Asynchronous JavaScript. In this section, we will cover one of the most important aspects of JavaScript, asynchronous programming. Learn the difference between synchronous and asynchronous code and how to manage async operations using callbacks, promises, and async await. You'll also explore patterns for handling callback hell, running promises in parallel, and creating subtle promises. This section will give you the confidence to write efficient, non-blocking code for real-world applications. So how can this structure work for you? Each section is designed to build in the laughs, creating a seamless learning journey that connects theoretical knowledge with practical applications. Whether you're preparing for a job interview, building your own mobile app, or simply aiming to master JavaScript, this course will help you with the tools, confidence, and expertise to achieve your goals. Level up your career with JavaScript Pro. Enroll today on stevencodecraft.com and let's take your skills to the next level. In this video, I will guide you through the resources and materials that will help you get the most out of your learning experience on stevencodecraft.com. And then we will set up your development environment. So after you create an account, go to the My Courses page and click on the JavaScript Pro course. So if I scroll down here and click Start Learning, this will navigate to the course dashboard. So here on the course dashboard, you can see a button that says to start the video course. And if we scroll down, we can also see links for the course materials. So let's first click into the video course so we can see that interface. So on the left, we see the videos. So here, if I select this particular video, if I scroll down, we can see the different sections. Now, I'll press play to start the video course. So I'll pause it for now and let's look at the different options that we have. So we have an option to show the subtitles. We also have a settings icon where we can adjust the speed. So if the video is going too fast, you can always adjust it. So let's scroll ahead up here. So for each video lesson, I have an active recall study section. So this helps mimic a technical phone screen interview and also helps you understand where you have gaps in your knowledge. So let me play this. So here I will ask an open-ended question. Main focus of object-oriented programming, and how does it organize software design? After I ask it, you'll see this text that says to pause the video and answer. So manually pause the video and try to answer it in your own words. I'll press play again. And then I will provide a sample answer for this question. The main focus of object-oriented programming. So after you hear the answer, don't worry about memorizing it verbatim. It's just to help you understand it in case you struggled with putting in your own words. So after you watch the video, click on the button that says complete and continue. So after you do that, you will see a check mark next to this video lesson, and then we'll move on to the next video in the course. So let's go back to My Courses now that you're more familiar with the video section of the course. Let's go back to the dashboard for JavaScript Pro. And now let's discuss the course materials. So scroll down and you see these different links. So for the first link is the code for the course. So this section contains the completed code for the course in a GitHub repository. So this includes the finished projects and examples that we'll be building together. These resources are designed to help you see the end goal and provide a reference for what your own code should look like as you progress. You can use this code as a guide to troubleshoot and refine your own projects. But remember, the real learning happens when you write the code yourself. There's also another link for the starter files. So these files are neatly organized into folders with clear naming conventions to match each video in the course. So we'll click into one of these folders, in this case, the object section. And here you can see different files corresponding to each video lesson. So you can click on this green button. You could either clone the project from your terminal, or click on Download Zip. And you can open that in VS Code. There's also an ebook in the course section, and this is a 600-page comprehensive ebook, and it covers all the topics that we'll discuss in the video lessons. So I strongly encourage you to read the relevant section of the ebook before watching the associated video. I'll scroll down here so you're more familiar with what the ebook looks like. So here we have the introduction and a discussion of object-oriented programming. So reading the material ahead of time primes your brain for what's coming in the video, making it easier to follow along and retain the information. There's one more ebook in the course materials, which is the Active Recall Study Questions. So this is to ensure that you solidify your knowledge and prepare for real-world applications and technical phone screen interviews. So this PDF contains all of the Active Recall Study questions that we will go over in the videos. And this is to test your understanding of key concepts and build a solid foundation in JavaScript programming. Let's scroll here so you're more familiar with what it looks like. So these are all the questions for section 2. So you go through each of these and try to answer it in your own words. And don't worry about memorizing it verbatim of the answer that I provide. Then you can scroll down. So if you struggle with answering that, I provide a sample answer. So I highly recommend that you take the time to answer these questions. Even if you're unsure about an answer, the process of thinking about it and putting in your own words will strengthen your understanding. And of course, you can always refer back to the ebook or the video for clarification. These course materials are here to support you every step of the way. By engaging with them, which includes the finished code, the starter files, the ebook, and the study questions, you'll set yourself up for success and gain a deep, lasting understanding of JavaScript. To start programming JavaScript, there are two essential tools you'll need to install, Node.js and Visual Studio Code. So what is Node.js? This is a powerful runtime environment that lets you run JavaScript outside the confines of a web browser. It's what enables you to build and run JavaScript applications on your computer, including server-side projects. While you could just run JavaScript in your browser, for this course we will be using Node.js to execute our programs. The second tool is Visual Studio Code, otherwise known as VS Code. Developed by Microsoft, this is an integrated development environment, or IDE for short, and this is where you'll spend most of your time writing, testing, debugging, and running your code. It's a versatile desktop application used by developers worldwide, and we'll be using it throughout this course. Both Node.js and Visual Studio are free and easy to install. Installing Node.js. Begin by opening your browser and heading to nodejs.org. Once you're on the site, click to download Node.js. LTS stands for long-term support. Downloading this version is recommended for most users because it's the most stable and well-supported version of Node.js. Once downloaded, open the installer and follow the on-screen instructions. The default settings are suitable for most users, so you can proceed with them unless you have specific preferences. Installing Visual Studio Code. Next, we'll install our IDE. Navigate to code.visualstudio.com in your web browser. Click the download button for your operating system. VS Code is available for Windows, Mac, and Linux. After downloading, run the installer. Like with Node.js, the default installation options will work perfectly for our purposes. So now once you have installed both Node.js and Visual Studio Code, click to open up VS Code. After you click it, you will see the welcome page. Then open up Finder or File Explorer for your Windows and create a new folder. Now this will be the folder where we place our code. So I'll just name it Project. Now, the name of the folder doesn't matter. Then I can click and drag it into VS Code. This will open up the project. Now to add a new file to our project, I can click on this icon, and I can name it code.js. So the name of this file doesn't matter, but the file extension does. So now we can write our first line of code, and I'll say console.log, then in single quotes, I'll say hello world, and then I'll end it with a semicolon. Notice as I'm typing, this file has not been saved yet, and so I see a circle indicating that I have unsaved changes. So to save it, I can do Command-S, or on Windows it would be Control-S. So now if I want to actually execute this file, I can do File, Appearance, and then Panel to open up the integrated terminal in VS Code. Now there's also a shortcut. I can do Control and backtick. So if you don't use the backtick character often, it's located on the left-hand side of your keyboard above the Tab key. So I can do Control and backtick to toggle this open. So I'll be using Node to execute this program. So I'll type Node, and then the name of our file, which is code.js. So here we see this value, hello world, is logged to the console. So I'll close this. Now VS Code offers a lot of features and a lot of ways to customize it. Before this course, we'll just be covering the basics that you need to get started. So on the left-hand side is the activity bar, where we see a list of icons. The topmost icon is the folder icon, and we can use it to toggle our project to see the folders and files within it. Next is the search icon, and we can use this to search, find, and replace text. So for example, let's say if I do hello, and enter, we see that this text is found in our code.js file. So I'll close that. The next one is our source code icon, and this is used to keep track of the changes in our project, as well as collaborate with other developers using Git version control. Next is the run and debug icon. You would use this when setting breakpoints in your code and debugging it if there are errors. Next is the extensions icon. This gives you access to the extensions marketplace. So this enables you to install additional features to VS Code to improve your productivity and help you customize VS Code to your needs. Now the icons on the bottom is for your account and to adjust your settings. Now on the bottom of the screen is the status bar here in blue. On the left side, you will see any errors or warnings in your code. And on the right side, I see the line number that I'm on for my current file. And I also see the programming language being used. So let's say if I wanted to add another file to my project, rather than always having to click on this icon, I can use the keyboard shortcut of Command and N or Control and N on Windows, open up a new file. And on the bottom right, we see that this is identified as plain text. So now if I want to save this file as a JavaScript file, I can do Command S and I can name it as second program.js. And now on the bottom right, we see that VS Code can identify that this is a JavaScript file. The next thing I want to cover is the command palette. You can access the command palette by going to View and then Command Palette. Now another way to do that is with the keyboard shortcut of Command, Shift, and P, or it will be Control, Shift, and P on Windows. Now the command palette is very important as it is the control center for all commands in VS Code. From here, we can also adjust the color theme that we use. So I click on Color Theme. And as I scroll up and down, we can see different color themes for my code editor. You can also access additional themes by going to the very top and clicking on Browse Additional Color Themes, allowing you to search through different options. Now for this course, I'll just stick to the standard Visual Studio one. Now to make the text larger, you can do Command and plus or Control and plus on Windows, and also Command and minus or Control and minus in order to make the text smaller. So this is a quick overview of VS Code, teaching you the basics that you need for this course. So for this course, there are 2 VS Code extensions that I suggest and that we will be using throughout this course. So click on the icon for extensions and type in Live Server. Then you can install this extension and we'll utilize it later in the course. Now this extension, Live Server, essentially makes it easy for us to have hot reloading. So when we write our code, we can actually see those changes reflected in a web browser. Then another extension that we'll be using for the early part of this course is Quokka. So type in Quokka. So select this one and then install it. Essentially this allows us to see the output of our JavaScript without having to constantly run it in our terminal. Before we get started, if you're interested in supporting my courses and projects, you can follow me on my new YouTube channel and Instagram at StevenCodecraft. You can also explore my courses at StevenCodecraft.com. And if you're looking to enhance your health and fitness routine, check out my workout and meal planning app at FitFuelPlanner.com. The app offers over 100 recipes, workout plans, meal plans, and a grocery list feature. It's designed to make tracking your calories and macronutrients straightforward and stress-free. I appreciate your support, and I'll see you in the next section. Object-Oriented Programming, or OOP, is a programming paradigm built around the concept of objects. At its core, OOP organizes software design around data, or objects, rather than focusing solely on functions and logic. Objects are instances of classes, which serve as blueprints for creating and managing data and behavior. A class can encapsulate both the data, often referred to as attributes, and the functions, known as methods, that operate on that data. This combination makes it easier to group related functionality and data into a single modular structure. One of the key benefits of OOP is how it promotes modularity and code reusability. By designing software in a way that mirrors real-world objects and their interactions, OOP helps developers create systems that are easier to understand, maintain, and extend. Languages like JavaScript, Python, Java, and C# are just a few examples of programming languages that support OOP, providing the tools to create and manipulate objects effectively. OOP is especially useful for managing the complexity of large software projects, making it a preferred approach for many modern applications. What does object-oriented programming focus on, and how is it different from just using functions? Object-oriented programming, also referred to as OOP, focuses on organizing code around objects, which represent data and the actions that can be performed on that data. This is different from just using functions, where the focus is primarily on writing step-by-step instructions or logic to solve problems without grouping data and behavior together. Object-Oriented Programming, or OOP, is a programming paradigm that focuses on objects rather than functions. This approach organizes software design by grouping related data and behavior into self-contained units called objects. At the heart of OOP are its four foundational principles. I'll explain each of these principles up front so you're familiar with them as we begin. Throughout the course, you'll see examples that clarify these abstract ideas. So these four principles include abstraction, polymorphism, inheritance, and encapsulation. First, let's discuss abstraction. Abstraction involves hiding the complex implementation details of an object and exposing only what's necessary. This simplifies how we work with objects, allowing us to focus on their functionality without needing to understand all the intricate details behind the scenes. Polymorphism. Polymorphism means many forms, and this allows objects to be treated as instances of their parent class rather than their specific class. This enables methods to behave differently depending on the object that's calling them, making your code more flexible and adaptive. Inheritance. Inheritance allows new objects or classes to take on properties and behaviors of existing ones. This reduces code duplication and promotes reusability and makes it easier to maintain consistent design across your application. Encapsulation. Encapsulation combines data and the methods that manipulate it into a single, self-contained unit, referred to as an object. By restricting direct access to this data, encapsulation ensures better control, security, and reduces the risk of unintended interference. These four principles, abstraction, polymorphism, inheritance, and encapsulation, can be remembered using the acronym API. Transitioning from procedural programming. Before OOP became widely adopted, many programs were written using procedural programming. This approach divides the program into functions that operate on variables. While simple, procedural programming can create significant challenges as projects grow, such as code duplication and interdependencies. So code duplication refers to repeatedly copying and pasting similar code across functions, leading to redundancy. Interdependencies refers to changes in one function can inadvertently break others, creating a web of interconnected issues, often referred to as spaghetti code. Object-oriented programming addresses these issues by bundling related data and behavior into objects. Within an object, variables are known as properties, and functions are called methods. Why OOP matters. By adopting OOP principles, you can write more modular, maintainable, and scalable code. OOP simplifies interactions between different parts of your application, reduces the risk of errors, and makes your code easier to extend and adapt to future requirements. Whether you're managing a small script or a complex system, OOP provides the structure and clarity needed for professional software development. This lesson provided a high-level overview of the four core principles of OOP, which can be remembered using the acronym API, standing for Abstraction, Polymorphism, Inheritance, and Encapsulation. Throughout this course, we'll explore more practical examples of each of these foundational principles in detail. What is the main focus of object-oriented programming, and how does it organize software design? The main focus of object-oriented programming, also referred to as OOP, is on objects, which group related data and behavior into a single unit. This helps organize software design by bundling properties and methods together, making code easier to manage, understand, and reuse. What is abstraction in OOP, and how does it simplify working with objects? Abstraction in OOP means hiding the complex details of how something works and only showing what is necessary. It simplifies working with objects by letting you use their functionality without needing to understand all the behind-the-scenes implementation. How does polymorphism make code more flexible and adaptable in OOP? Polymorphism makes code more flexible and adaptable by allowing the same method or function to work in different ways depending on the object it is used with. This reduces the need for repetitive code and makes it easier to handle different types of objects in a consistent way. What is inheritance in OOP, and how does it help reduce code duplication? Inheritance in OOP is a way for one class to use the properties and methods of another class. This helps reduce code duplication by allowing you to reuse existing code in new classes instead of writing it again. What does encapsulation do in OOP, and why is it important for control and security? Encapsulation in OOP bundles data and the methods that work on it into a single unit called an object, and it restricts direct access to the data. This is important for control and security because it ensures that data is only modified in controlled ways, reducing errors and preventing unintended interference. How does OOP address the challenges of procedural programming, such as code duplication and interdependencies? OOP addresses challenges like code duplication and interdependencies by organizing code into objects that combine data and behavior. This reduces redundancy by reusing code through inheritance and makes programs easier to manage by keeping related functionality within self-contained objects, reducing the risk of unintended interactions between parts of the program. In JavaScript, an object can be defined using curly braces, which signify an object literal. An object literal is a way to organize data using key-value pairs. So here's you can declare an empty object. So we can use the let keyword, and I'll name the object programmer. Let's assign this to an object literal. I'll give it a key of name and the value of my name. I'll add another key for preferred language, and I'll set that to JavaScript. Now I'll define a method which will utilize these two properties. So I'll name this writeCode and set that to an anonymous function. So this will console.log, use a template string, this.name, writes, this.preferred language, code. And I'll end it with a semicolon. Now I'll define another method, and I'll use syntactic sugar for cleaner syntax. So I'll say drink coffee, then open and closing parentheses. Then I will console log, this.name, drinks coffee. So this shows different syntaxes that you can use to define methods within an object literal. And I will end this with a semicolon. Now I can call programmer.writeCode. Control and backtick to bring up the terminal. Let's navigate to where this file is. So it is in objects. And here I'll do node, and I'll name this file 3objectliterals.js. And here I see it logged these property values. So in this instance, the programmer object literal has 4 members. So it has 2 properties, the name and the preferred language, and it has 2 methods, writeCode and drink coffee. So this structure allows us to encapsulate related properties and functions within a single organized entity, making our code cleaner and more intuitive to work with. By leveraging object literals, you can create versatile and reusable code structures that represent real-world entities or complex data models effectively. What is an object literal, and how would you create one? An object literal is a data structure in JavaScript that allows you to define key-value pairs. It essentially enables you to group together variables and functions. In the context of an object, it will be referred to as properties and methods, and you would create one by using curly braces. To help reinforce this concept, your exercise is to create a simple JavaScript object literal representing a grocery list item. This object should have the properties of quantity and name, along with a method, display, that logs the quantity and the name to the console in this format. So to demonstrate how you can implement this, I can use the const keyword, and I'll name it grocery item. I could assign that to an object literal with the key of name. I'll just set that to apples. And the key of quantity, I'll set that to 4. And our method, so that will be display console.log backticks. So I'll say this.quantity times this.name. End it with a semicolon, and we'll close our object literal with a semicolon. Then I can call grocery item.display. I can just log this out, and I see the expected output. So suppose you need to add another programmer to your team. Using the object literal syntax repeatedly can lead to duplicated code, which makes your application harder to maintain. This is especially true for objects that include methods, indicating that the object has behavior which may be repeated across multiple instances. So let's consider this object literal that we created in the previous lesson. If we need to create multiple programmer objects, it will be inefficient and error-prone to copy and duplicate all this. So a more scalable solution is to use a factory function. So a factory function is a function that returns a new object each time it is called, ensuring that each object has its unique properties but shares the same methods. So here's how you can implement it. If I name it function, and I will name it createProgrammer. So now we'll specify 2 parameter variables. The first will be name, and the second will be preferred language. Then we'll return an object literal. We'll do name, preferred language. We'll do write code for the method. And we can just copy this. Then the other method is drink coffee. And once again, we'll just copy this console log statement. And since it's a function, we don't have to end it with a semicolon. So we can now create a new programmer simply by calling this function. So I'll scroll down so we can see it. I'll say const new programmer is equal to createProgrammer, pass in the name Alice, and JavaScript as the preferred language. So now, when I call new programmer dot write code, let's pull up the panel, and I'll scroll down. I will list it out. And so I'll do node. I'll just copy the name of this file, and I'll output it. And here we see Alice writes JavaScript code. So using factory functions in this way helps avoid code duplication and simplifies maintenance, making your code base cleaner and more manageable. What are factory functions, and why would you use them? Factory functions provide an efficient way for us to create a new object. So the name of the function will be in camel case notation, and it can accept parameter variables. These parameter variables can help customize the values of the object being returned. The benefit is that it reduces code duplication and the need to copy and paste. Create a factory function which returns a new grocery list item. The parameters should be name and quantity. So this is the grocery list item, which we created in the previous lesson. So rather than having to duplicate this, we'll create our factory function. So I'll say create grocery item, and this accepts name and quantity as parameter variables. This returns a new object literal. It will be name, quantity, and for the method, we can just copy this and paste it here. We can end this with a semicolon. And so now if we wanted to create a new item, we can say const new item is equal to create grocery item. we'll say bananas, end it with the S, and we'll just say 5. So I'll scroll down. We can call new item dot display. So let's bring up the terminal, and I'll run it again. And here we see the quantity of 5 bananas. In traditional JavaScript, there are no native classes as found in languages like Java or C#. Instead, JavaScript uses functions and the new keyword to mimic class-like behavior, which is a technique known as constructor functions. This approach was the standard before ES6 introduced class syntax as syntactic sugar to simplify object creation and inheritance. We will cover ES6 and that syntax later in the course, but for now, here's an example of a constructor function for creating programmer objects. So here I'll just write a comment to say the lesson, and we'll start up Quokka. So we'll bring up the command palette with Command Shift and P or Control Shift and P, and I will say Quokka start on current file. So if you don't see this, just type in Quokka, select that. So now we can see it in our output without having to run node in the terminal. So use the function keyword, and we'll use Pascal case for naming our constructor function. And it accepts 2 parameters, which is the name and the preferred language of the programmer. Language. Then I'll use the this keyword, which means this current object. Set it to the name, then the preferred language. Now let's implement our methods. So this dot write code is set to the anonymous function, console.log, backticks for our template string, and I'll say this dot name writes this dot preferred language code. We'll end this with a semicolon and the anonymous function. Then I'll say this dot drinks coffee, set that to anonymous function, console.log. I'll say this dot name drinks coffee. Just to demonstrate the syntax. Now, to create an instance of this object and to call this constructor function, we use the new keyword. So I'll say const new programmer equal to new programmer. Then we pass in our arguments. I'll pass in Alice for the name and on JavaScript as the preferred language. Now I can call new programmer dot write code. Save that. And here we see the output. Alice writes JavaScript code. What is a constructor function? A constructor function is used to instantiate a new object in JavaScript. So for the naming convention, you would name the function using Pascal case, and for assigning the properties and for the methods, you would use the this keyword, which references this object or the current object. So now for the exercise, create a constructor function for the grocery item. So to implement that, once again, we use our function keyword and we use Pascal case. So the first character of each word is capitalized. This takes in 2 parameters, the name and the quantity. This keyword for this object, just assign this to the quantity. Now for our display method, this.display, set that to an anonymous function, console.log, backticks, this.quantity times this.name. End that with a semicolon. So now we'll create an instance of the grocery item, and we call this constructor function with the new keyword. So I'll say const new item is equal to new grocery item. For the name, we'll say bananas and the quantity of 5. So now let's call this display method. So that'll be new item dot display. Save that. And here we see the output, which is 5 bananas. Every object in JavaScript includes a special property known as constructor. This property references the function that was used to create the object via the new keyword. For instance, we consider our constructor function for a programmer object. Here we use the new keyword to call this function. So if we wanted to find out which constructor function created this object, we can access that via its constructor property. So let's console log that. So I'll say new programmer.constructor. Now, when we log that in the console, so this file is named Constructor Property.js. So this will output the programmer function, confirming that new programmer is an instance of this programmer constructor function. So this property is particularly useful for confirming the type of object you're working with, especially when dealing with complex code bases that involve multiple constructors and prototypes. In JavaScript, functions are treated as objects. This means that like any object, a function can have properties and methods, and it can be assigned to variables or passed as arguments to other functions. So let's consider a simple function. I just name it add, and it takes in two numbers, num1 and num2, and it simply returns the sum of these values. So you can assign this function to another variable, effectively creating a reference to the original function. So if I were to do const, if I just name this n, and assign that to add, now n will reference this function, as functions are objects in JavaScript. So now I can actually call that function console.log with this reference, n. So I can say n, I can pass in 2 and 2. So I'll expect the output of 4. So starting up Quokka, I see that the output is 4. So as an object, the function add has properties and methods. For example, the length property of a function returns a number of its expected arguments. So if I were to do console.log of add.length, we get the value 2, as there are two parameter variables. So to further illustrate how functions are objects, consider creating a function using the function constructor. So I can name that with const programmer func equal to new function, taking in the name, and I'll use backticks. So this.name is assigned to name, and I'll define a method, write code, assigned to an anonymous function, console.log, code in JavaScript. So let's instantiate an instance. So I can say const, and I'll just call this programmer, is assigned to new programmer func, and I'll pass in my name as the argument. So now let's call this method, write code, programmer, write code, and here we see our expected output. So this lesson shows the unique nature of functions in JavaScript. By understanding that functions are indeed objects, you gain a deeper understanding into the flexibility and capabilities of JavaScript as a programming language. So for your exercise, create a function named calculatePrice. So this function will accept two parameters, a grocery item object and a price, which is just a number. So in that function, simply return the price times the quantity of the grocery item. So based on our previous lesson, we created this constructor function to create a grocery item, and we instantiated a new item. So we want to create the function calculatePrice, which accepts a grocery item and a price, and we simply return the price times grocery item quantity. So we want to assign this function name to a variable to demonstrate that functions are objects in JavaScript. So we can do const perform calculation is assigned to calculatePrice. So now we can invoke it with this reference. So let's do console.log perform calculation. So for the first argument, we'll pass our grocery item, and we'll pass 25 cents. So here we see the output and quokka is 125. JavaScript supports 8 different data types, which include 7 primitive types and 1 complex type. The primitive types are number, string, boolean, big int, undefined, null, and symbol. The 8th data type is object, which also encompasses arrays and functions. Understanding the distinction between these types is crucial due to how they are allocated and managed in memory. So to demonstrate primitive types, these are passed by value. So when you work with primitive values, these are passed by copy. So this means if you assign a variable to another containing a primitive value, the new variable gets a copy of that value. So altering one will not affect the other because each variable holds its own unique value in a separate memory location. So I instantiate, let A, initialize that to the value of 10, and I initialize B, and I assign that to A, B will get a copy. So they are not referencing the same data in memory. So if I do A and I reassign that to 20, let's start quokka. Console log this, console log the value of A, and we'll console log the value of B. Here we see they are different values. So now, let's consider reference types, which are passed by reference. So on the other hand, reference types, like objects, are handled differently. So they are passed by reference, meaning both variables point to the same object in memory. Thus, changes made in one variable are reflected in the other. So, say if I assign A and assign it to an object with the value of 20, then if I assign B to A, they now reference the same object in memory. So if I update A.value to be 100, this will be reflected in both of the references. So let me just copy these console log statements and output them. Here we see they are referencing the same object. So in JavaScript, primitive values are copied by value, meaning they do not affect one another when changed. Now objects, which include arrays and functions, are copied by reference, meaning changes to one affect any other variable referencing the same object. This fundamental understanding helps in managing how data is passed around in your programs, ensuring fewer surprises and more predictable code behavior. What are primitive values and what do they pass by? Primitive values refer to simple values, such as string, number, booleans, and they are passed by copy. What are object values and what do they pass by? Object values refers to key-value pairs. This also includes arrays, and they are passed by reference. So objects in JavaScript are inherently dynamic, which means that you can add or modify their properties and methods at any time after their creation. Using the const keyword with an object declaration ensures that the variable cannot be reassigned to a different value. However, the contents of the object it points to, such as its properties and methods, can still be altered or extended. So consider the following example. If I instantiate a person object, and I give it the key of name and the value of my name, let's end it with the semicolon. Now if I console log this, console.log of person. Now let's start up quokka. So bring up our command palette, start on current file. Here we see it just outputs our object. Now, if we want to add properties, we can do so using either dot notation or square bracket notation. So if I use dot notation first, I can say person dot favorite food. To assign that to tacos. And I'll just copy this console log and we'll output it just to demonstrate that I have dynamically added this property. Favorite food. And here we see this contains the two properties for the name and favorite food. Now, let's use the other syntax, which is the square bracket syntax. And I'll call this favorite ice cream. And let's just assign that to chocolate. Now let's paste our console log statement. And here we see our object has been updated. Now we can also use the delete keyword, which will delete a property. So if I do delete person.favorite ice cream, and let's paste this again. And here we see our object has been updated dynamically again, deleting the property of favorite ice cream. Now let's add a method. So I can say person.eat. Let's assign this to an anonymous function. And here, I'll say console.log with backticks, and I can say this.name eats this.favorite food. And then with the semicolon. So now let's invoke this method that we've added dynamically. So I'll say person.eat, save that. And if I look here, let me expand this. We see Steven eats tacos is the output. So this ability to modify objects is both powerful and flexible, allowing us to adapt objects to changing requirements or conditions dynamically. However, it also means that you need to manage objects carefully to avoid unintended side effects from these changes. Explain in your own words, how are objects dynamic? Objects in JavaScript are dynamic because you can change and mutate the properties and methods of the object after it has been initialized. So for your exercise, create an object with the grocery item constructor function. Then dynamically add the property of grocery aisle. So here we have this grocery item constructor function. Let's instantiate an instance of it. So we can do that with const new item. We'll call the new keyword grocery item. We'll name this bananas with a quantity of 5. Now we want to dynamically add a new property. So I can say new item dot grocery aisle, and I'll set this to the produce section. Now let's just console log this, console.log of a new item. And here we see we have dynamically added the property of grocery aisle. In JavaScript, different loops offer various ways to iterate over collections like arrays and objects. For arrays, we can use the for-of loop. So the for-of loop is ideal for iterating over array elements. So if we do let numbers, and I assign this to an array of 1, 2, 3, 4, and 5, then if I just do for const element of numbers, then console.log of element, here we see the output is just each of these elements. Now for objects, we can use the for-in loop. So the for-in loop allows you to iterate over the keys of an object. And this is useful for accessing values when you know the structure of the object. So I can do const dog and instantiate this object with the name of Max, the age of 5, and so the eye color of blue. We'll end this with a semicolon. Now we can use our for-in loop. So for, and I can say const key in the dog object. Now I can do console.log of dog and access the key with square bracket notation. And here I see this will output the associated values for each of the keys. So besides these two traditional loops, JavaScript provides methods to retrieve the keys, values, and key value pairs directly from objects, which can be iterated over with the for-of loop. So let's say if I want to get the keys, I can do const keys equal to object.keys of the dog object. So now, if I do const key of keys, I can do console.log of key. And here this will output all the keys of this object. Likewise, I can do the same with the values. So const values equal to object.values of the dog object. Now for const value of values, console.log each of the values. So now this outputs the associated values. Now we can also enumerate over the key value pairs with object.entries. So I can do const entries of object.entries, pass this object in. Now I can do for const entry of entries. Now here I can do console.log. And I'll use backticks because I'm going to use interpolation. The key, if I can access at the first index, so that'll be index of 0, and the associated value, which would be entry, at the index of 1. So here we can save this. And instead of object, it's supposed to be dog as our object. So here are the outputs, the associated key value pairs for each of the properties in the doc object. So these methods provide a powerful and flexible way to handle objects in JavaScript. They simplify the process of working with object properties and makes your code cleaner and more efficient. How can you enumerate over the properties of an object? There are different ways to enumerate over the properties of an object. One way is you can use the for-in loop to iterate over the keys of an object. We can also use the built-in object class. For example, iterating over the keys with object.keys, enumerating over the values with object.values, and enumerating over the properties with object.entries. So for your exercise, write 3 for loops enumerating over the object's keys, the object's values, and the object's key value entries. So to complete that, let's enumerate over the object's keys. We can do that with for, I can say const key of object.keys. And for the argument, I'll pass in this object that we created. Then we can console log the key. So here we get all the keys for the object that we enumerate over. Now we can loop over all the values. So I can say const value of object.values, passing a new item. And here we'll just console log the value. So here we get the associated values that we passed in as arguments when we first instantiated this object. So now let's enumerate over the key value entries. So I can say for const entry of object.entries, new item. But now we can do console.log. We'll just log out entry. So here we see each entry is an array where the value at the 0th index is the key and the value at the first index is the associated value. Abstraction is a core concept in object-oriented programming that involves hiding complex details while exposing only the necessary parts of a class or object to the user. This makes the objects in our applications easier to interact with and reduces the impact of changes. So let's consider the programmer constructor function that we've been using, and I'll illustrate the concept of abstraction. So we use the function keyword, and I use Pascal naming convention to name our constructor function. The parameters are name and preferred language. So now we use the this keyword to assign our properties, and we will assign our preferred language. So now that we've assigned those properties, let's create a public method. Just create a comment just to illustrate that. So we use the this keyword to create our public method, and I'll name it writeCode. We assign this to an anonymous function. Now I'll use a keyboard shortcut, so I can just type out log. And so here VS Code says log to the console, so I can press tab for auto completion. So now I'll use backticks because I want to use string interpolation. So $, and then curly braces, this.name. So I'm utilizing this property in our string, writes this.preferred language code. So this public method is accessible through dot notation when we create an instance of this programmer. So now, to demonstrate a private method, so the concept of abstraction refers to using private methods such that the public methods are only those that are absolutely necessary, and we want to abstract away the details. So I can use the const keyword. I can also use the let keyword. So if you recall, both the let keyword and the const keyword are only available within the block that they are defined in. Right? So you can only call it within the block that it's implemented in. So I assign this to an anonymous function. So we'll use our keyboard shortcut again with log, and then down arrow, and then tab. And once again, I'll use backticks and use interpolation. So this.name drinks coffee. So now let's define another public method. And now we will utilize this private method that we defined. So I'll use the this keyword, and I'll assign this to an anonymous function. And here I will just call our private method. So here we see with abstraction, we are abstracting away the implementation details, which is hidden from the user. So to better illustrate this, I can create an instance of this programmer. So I can say const programmer. I'll use the new keyword, which calls this constructor function, and we named it programmer. So I'll say name, Steven, and preferred language is JavaScript. So now if I do programmer dot, here I can see what is accessible through dot notation, or what its public interface is. So here I see the name property, I see the preferred language, and I see the public methods of start day and write code. So let's call write code, and I'll just do shift option and down arrow to create a copy, and I'll try to call drink coffee. So here I'm attempting to call this private method. Let's see what happens. I'll save it with Command S. Now I'm going to bring up the terminal. So I'm going to do Command and J for that. So here I've already navigated to the directory where this file is located. And I named this file 11-abstraction.js, but your file could be named differently. And here I'll just run it in the terminal rather than using Quokka to better illustrate this. So 11-abstraction.js. So here when we run it, if I scroll up, when I called write code, this outputs this .name writes preferred language code. And so here we see the output is Steven writes JavaScript code. So that worked as expected. However, here we see we try to call this private method, and we get a type error that programmer.drinkcoffee is not a function. So we know it's not accessible, and this is what will occur if we try to call a private method. So it will throw an exception. So now, we want to instead use the public method. Right, so only public methods are accessible through dot notation. So I'll clear this with Command K, and then up arrow, and we'll run it again. So now I see I get the expected output when I ran write code. However, when I called start day, this called the private method I defined, where we have this .name drinks coffee. And here we saw the output of undefined drinks coffee. So this means that this .name is currently undefined within this context. So if you remember in JavaScript, functions are objects and they have their own this context. So in this instance, or this example rather, this is referring to the function that is defined in. However, we want the this keyword to instead reference its enclosing scope. So the enclosing programmer, such that we can access this .name. So in order to do that, we can use the bind method. So I can say .bind, and I'll say this, which references the current context that it's being implemented in. So that constructor function. So now if I run it again, let me clear this with Command K, up arrow, and then run. And here I see the expected result for this private method, call in start day, which is Steven drinks coffee. So that is the result of calling this method. So to recap, in this example, we saw that, let me close the terminal so you can actually see it. Write code is a public method that is accessible to any instances of this programmer constructor function. And on the other hand, drink coffee is defined as a private method inside the constructor function. And here we use the const keyword. So this method is not accessible from outside this code block. So outside the programmer function. Instead, it is meant to be used internally by other methods within the programmer object, like start day, here, which exposes a controlled interaction with drink coffee. So this illustrates the concept of abstraction, which is utilizing private methods and hiding away the implementation details. So some key points on abstraction that I want to discuss. Two main points. One is you just want to show what is necessary in the public interface. So in our example, here we see that start day, that method abstracts away the details of what starting the day entails for a programmer. So in this case, drinking coffee. Now, the consumer of this programmer constructor function does not need to know the implementation details. They just need to know that they can start the day and call that public method. The second point of abstraction is hiding the complexity. So methods like drink coffee do not need to be exposed outside of this object as they handle specific functionalities and implementation details that are not relevant to the programmer that is utilizing this constructor function. So this approach helps in maintaining a cleaner interface for the objects, making them easier to use, and reducing dependencies on the internal implementation details. So we can always change those implementation details in the future and minimize the impact of those changes. So this leads to better modularity and easier maintenance of our code. So in this exercise, we will build upon the grocery item constructor function that we've been using in previous exercises, and we will create a grocery list constructor function. So this will help us understand the concept of abstraction, which involves hiding the implementation details and exposing only the necessary parts. So here is the initial grocery item constructor function. So the grocery list constructor function should internally maintain an array to store grocery items. It should also provide methods to add items, display all items, and get the total quantity of items. So to practice abstraction, we will use private methods for operations that should not be exposed directly. Specifically, you will implement a private method for calculating the total quantity of items. So here's a starting point for the grocery list constructor function. We use the function keyword. We'll name it grocery list. This doesn't accept any parameters for the constructor function. Then internally, we have items, which will hold the grocery items. I'll just add a comment, private array to store items. Your task is to complete the grocery list constructor function by adding the following methods. You will implement add item, which accepts two parameters for a name and quantity, and this adds a new grocery item to the list. There is display items, which will display all items in the list. There is get total quantity, which will return the total quantity of all items. And we have a private method, calculate total quantity, to calculate the total quantity of items. So by the end of this exercise, you will have a better understanding of how to implement abstraction in JavaScript using constructor functions. So now let's implement our grocery list constructor function. I'll scroll down so we have more room. So now, first let's implement our private method to calculate the total quantity of items. So, you can use the const keyword, and I'll name this. And we'll name this calculate total quantity. We assign this to an anonymous function. Now we will return this quantity, and we'll utilize the reduce method that's built in for the array data type. So items.reduce. So with this, we can take all the items in our list and reduce it to one value. So here we pass our callback function. So the previous value, which we can name that total, and the current value, so I'll name that item. We use our arrow function syntax. So the total plus the item dot quantity. Right, so here for our grocery list, we have the properties of name and quantity. Now for the reduce method, it also takes an optional second parameter, set that to 0, and this represents the initial starting value. So now I've implemented that. I'll just add a comment here, just so we know that it is a private method. So now we will implement our other methods needed to operate on the grocery list array. This.addItem, so an anonymous function, takes in the name and a quantity. So now let's create that new object. So const item, and then new grocery item. So let's pass in these arguments to create that new object. And then we will add it to our items array. So now we'll implement our display items method. Assign this to an anonymous function. And we can do items, and here we can call the built-in for each method. So it would be the item, so the current item that we are operating on. And we simply want to call the display method. So the display method we have implemented here. And here this console logs the quantity and the name of the item. So we can implement all this on one line. So now we want to implement get total quantity, set this to an anonymous function, and we simply will call this private method that we have implemented here. So now let's utilize this grocery list constructor function. So I'll say const, I'll name it myList, and we'll use the new keyword, then grocery list, and this doesn't accept any arguments. So now that we've created a list, let's add items to it. So myList.add item. So I'll say banana, and a quantity of 5. Then just to copy this, I'll do Shift Option and then down arrow. I'll just rename it to be apple. And let's say the quantity is 3. Let me scroll down so you can see. So now let's call myList.displayItems. So this will go through and output. So let's bring up the terminal. So Command and J or Control and backtick. So I'll do up arrow and then I'll run it. So here I see when I call display items, this outputs the quantity and the item name for all the items in our list. So now I'll comment this out and I'll close the terminal just so we can see better. Now I want to console log. I'll use backticks. Now I want to find the total quantity of items in our grocery list. So total quantity. We use interpolation here. So myList.getTotalQuantity. So we're calling that public method. End it with a semicolon. So once again, we'll open up the integrated terminal. So Command and J or Control and J. Up arrow. And we'll run it again. And here we see the total quantity is 8 items in our grocery list. So some key points on abstraction. Once again, we want to show only what is necessary. So only the methods of add item, display items, and get total quantity are exposed to the user. The user does not need to know about how the total quantity is calculated. So that is a private method. And the second key point is hiding the complexity. So if I scroll up again, so the calculated total quantity method is private, and its functionality is the internal implementation details that should not be exposed. Closures in JavaScript are a powerful way to achieve encapsulation, which is one of the core principles of object-oriented programming. So if you remember our acronym of the 4 pillars of object-oriented programming, which is API, so the A is for abstraction, the P is for polymorphism, the I is for inheritance, and the E is for encapsulation. So what is a closure? A closure means that an inner function has access to variables declared in its outer function. This allows you to hide the internal state and functionality of an object, exposing only what is necessary to the outside world. So this is a technique that enables us to achieve encapsulation. So using closures, we can create private properties and private methods, making JavaScript objects easier to work with. So instead of overwhelming the user or object with too many public properties and methods, you only expose what is absolutely necessary for the object to function properly. So let's go over a simple example to better understand the concept of closures. So I use the function keyword, and I'll name this function example. So within it, I'll create a constant named num, and I will initialize it to the value of 5. So now I'm going to create a function within this function. So remember, in JavaScript, functions are objects. So I can name this log num, and here I'll type log, and then I can log to the console, so I get that auto-completion that Visual Studio Code provides for me, and I will log out that identifier of num. So now I will call or invoke log num. So now let's call example. So here we see this inner function has access to the variables declared in its outer scope. So its outer function, which is this constant value. So let me bring up the integrated terminal. I'll do that with Command J. You can do this with Control J. So node, and I name this file 12-private. I'll do tab so it auto-completes for me. So we output that. So here when we invoked, we called this function example, we get the expected output of 5. This is a simple example demonstrating the concept of closures, where inner functions have access to variables declared in its outer scope. So let's go through a more complex example in the case when we return the function. So rather than simply defining this function, or declaring it rather, let's instead return it. So we can do return, and we'll delete this. So now this function returns a function, and so when we call example, we want to store the result. I'll name this inner function, initialize to that, and so now lognum is now accessible through inner function, right? So this is referencing the function that is being returned. So now let's call that inner function, and we invoke it. So let's bring up the integrated terminal again, up arrow, and we're running. And once again, we get the expected result. So even though this function, which we named example, has finished executing, inner function still has access to num because of the closure. So even after this example, right, even after the outer function has finished executing, the inner function is still able to access all the variables and identifiers declared in its parent scope at the time of declaration. Right, so you'll get more practice with this and you'll become more understandable. Let's go over a more complex example, and here we'll create private properties and methods using closures within a constructor function. So once again, we use the function keyword, and I'll just name this make functions. So here, if we use the let keyword, I'll name this private num, and we'll initialize it to the value of 0. So now we'll create an inner function, private increment. So this increments the value, ++. So now we have these local values, which are not accessible outside of this function. And here we will return a JavaScript object, and we will define an interface. Right, so methods to use. So we'll have our lognum method. We'll define this with an arrow function. So we'll do log, and then tab for that auto-completion. This will console log the number. Now we'll define another method, increment. Once again, we'll use an arrow function to define it, curly braces. So this will call private increment. Here we'll do log, tab, and we'll just say incremented. So now let's call make function. I'll say const. Now we can destructure these values. So use curly braces, log num, and increment, make functions. And so this is an example of destructuring. So we know make functions returns an object, and we've destructured these two methods. So now it's easier to work with. Now, if we didn't do destructuring, we could name this, for example, increment object. We could really name it anything. And through increment object, we can access the increment and lognum methods. But I prefer the destructuring syntax. So, the Command Z to get back to that. So now let's call lognum. This will output the value of 0, which it was initialized with. Then we can call increment, which will update the value, and we will see the console log value of incremented. And then we can call lognum again. So let's bring up the integrated terminal again. Here I will scroll down. We'll clear it with Command K, up arrow, and we run it again. So here we see the initial value of private num is 0. We incremented the value, and the updated value is 1. So this shows an example of closures as this make functions has finished executing. But here, this JavaScript object and the methods defined within it still have access to these identifiers or the variables declared in its parent scope. And this helped us achieve encapsulation because we only expose lognum and the increment method, and we're not exposing the inner implementation details or the private num property. So let's clear this out. We'll go through another example. So using closures in a constructor function. So we'll go back and we'll use our example for the programmer constructor function. The parameters are name and preferred language. So I'll just write some comments just so it's easy for us to identify what we're doing. So we'll specify a private property. So we're not going to use the this keyword. So it's not accessible through dot notation. So I'll use the let keyword instead. And we'll assign this to the value of name. Now an example of a public property, which will be accessible through dot notation. So this dot preferred language assigned to that parameter of preferred language. So now let's define a public method. We use the this keyword, say write code, assign this to an anonymous function. Let's do log and then tab for that auto completion. We use backticks and we can say code in this dot preferred language. Now, an example of our private method again, say let drink coffee assigned to an anonymous function. Here we will log it again. So log to the console. I'll just say gulp dot dot dot. Now we'll say a public method that uses a closure. So this dot start day. Assign this to an anonymous function. And we just call drink coffee. So we are hiding those implementation details of this. So let's actually instantiate a new programmer. So we'll say const programmer. We use the new keyword and the name of our constructor function. We'll say Alice, and the language is JavaScript. End this with a semicolon. Now, programmer.write code, and we'll say programmer.start day. Right, so this repetition is really good to help you get used to the syntax, as well as get a better understanding of the terminology that we use in programming. Let's scroll down, open up the integrated terminal, up arrow, and run. So here we see code in JavaScript and gulp. So in these examples, let's close this, and we'll look over our implementation of this constructor function. So private name, let's actually use it. So you can use private name. Right, so let's run it again. Let's make sure that we're actually utilizing our private property. So here we see Alice codes in JavaScript and just gulp. So private name and drink coffee are private because they are defined with the let keyword and not exposed via the this keyword. So considering public properties and methods, preferred language and write code are public because they are defined with the this keyword and can be accessed outside the function and through dot notation once we create an instance of this constructor function, this programmer. So using closures. So the start day method demonstrates a closure. It is a public method that can access the private drink coffee method because of the closure. It can access the variables and the identifiers declared in its outer scope. So let's consider closures versus scope. So scope is the context in which variables and expressions are visible or can be referenced. If a variable is not in the current scope, it is unavailable for use. Now for closures, these are functions that capture and reference external variables. So when I say external variables, this refers to variables which are not defined locally in the function, but these variables are accessible because they exist in the outer environment. The function defined in the closure remembers the environment in which it was created at the time of function declaration. This is why drink coffee, this method, remains accessible only within functions defined in the same scope, so only within the constructor function. So closures are a fundamental and powerful aspect of JavaScript, allowing for more secure and modular code by protecting and encapsulating behavior within objects. So we covered a lot of new terminology in this lesson. I'm not expecting you to remember and know all of it immediately, and we're going to get more practice and more exposure to these concepts throughout the course, so it will make more sense. The main takeaway that I want you to get from this lesson is that a closure means that an inner function has access to variables declared in its outer function. What are closures? So closures are inner functions that are able to access variables defined in its outer function. So in other words, closure functions can access variables from their outer scope even after the outer function has finished executing. Now you would utilize closures in order to achieve encapsulation and to hide private variables or private properties. So now for your exercise, the objective is for you to understand and implement closures to create private properties and methods within a constructor function. So your task is to create a bank account constructor function that can manage a user's account balance. So the balance should be private, and the constructor should provide public methods to deposit money, withdraw money, and check the balance. So now to go over the instructions. Step 1, you want to define the bank account constructor function. Now it should have a private variable balance to store the account balance. It should have a private method to validate the amount being deposited or withdrawn. So this private method will validate and ensure that the value that you are passing as an argument is of the number data type, and that the amount stored in the balance is greater than the amount being withdrawn, as well as the money that you're depositing is a positive number. So it should have public methods to deposit money, withdraw money, and check the balance. So, step 2, you want to implement the following public methods. The first is deposit, which accepts the parameter of the amount to deposit. So this adds the specified amount to the balance if it is valid, right? You're utilizing that private method to validate the argument. The second method, or second public method, is withdraw, which accepts the parameter of the amount, and this subtracts the specified amount from the balance if it's valid and there are sufficient funds. Now the third public method is getBalance, which simply returns the current balance. So pause the video and attempt to implement this constructor function for the bank account. So now that you've attempted to implement that, we'll go ahead and write the code for that. So we use the function keyword. Then, name of it is bank account. Now for the parameter, I'll specify initial balance. Now I'll use this as a private property, so it's not accessible through dot notation. You can only access it through the public interface or the public methods. This helps us achieve encapsulation. So we're setting that to the initial balance. And I'll add a variable just to better describe what I'm doing. So private variable to store balance. Okay. Now I want to implement the private method to validate the amount. So this amount could be what is being used to either deposit money or to withdraw money. So const, and I'll say is valid amount. The anonymous function, parameter being amount. So return. And I'll use the type of operator because I want to ensure that the amount is of the number data type. So and we will check that the amount is greater than 0 because we can't deposit a negative number and we don't want to withdraw a negative number. So we can utilize this helper method in our public methods that we're going to implement. So I'll just say public method to deposit money. So we use the this keyword to create a public method within our constructor function. We'll name it deposit, and we assign this to an anonymous function with the amount being the parameter. Now we're going to utilize our private method. So if is valid amount for the amount, then I'll do curly braces. So in the case when the amount being deposited is the number data type and it is a positive number, then we want to perform that update. So we will use our shorthand syntax to update the balance in the bank account, and we will log it out. So I'll say log, down arrow, and then tab. I'll use backticks. So deposited. Now, colon. Now we're using interpolation, so I'll do a $sign and then curly braces and the amount. Now, because I'm doing US dollars, I want to use the $sign in the actual output. So I'm going to add another $ before, just so the correct symbol shows up when we output it to the console. So now, else, in the case when it's not a valid amount, so do log, then tab, and then I'll say invalid deposit amount. So informing the user on that. So we've implemented this. I can end that with a semicolon. Now, we want to implement the public method. I'll scroll up so you can actually see better. So public method to withdraw money. So now we'll do this dot withdraw. We'll assign this to an anonymous function. Now once again, we're utilizing our helper method. So if is valid amount, making sure that is a number data type and a positive number. And if the amount that we're trying to withdraw is less than or equal to the balance, then we can actually perform that. So we use shorthand syntax to update the balance. So minus equals. And we will log that to the user to inform that this has been successfully performed. Backticks withdrew interpolation, the amount, and we want the $ to show up, so we'll add that there. Else, we'll log, and then tab, insufficient funds. Now, in the case when it is not a valid amount, so in the case when the amount that you passed as an argument is either not of the number data type, or is a negative value, then we want to output a message for that case. So I'll say invalid withdraw amount. Okay, so we implemented that. We have one more public method, which is to get the current balance. So once again, we use this keyword, get balance, anonymous function, and then we will simply return the balance. So we're just returning this private property that we set here. So now we've implemented this. I'll scroll up so we can actually utilize it. So now let's instantiate an instance of this and call this constructor function. So I'll use the const keyword. I'll name the identifier my account, and we assign this to new bank account. Now for the initial value, I'll specify 100 as the initial balance. So now I can do my account dot deposit, and I'll deposit 50. Now let's do my account dot withdraw, and I'll withdraw 30. Then we can do console.log, and I'll say my account dot get balance. So let's call it. So now let's open up our integrated terminal. I could do that with Command and J or Control and J. Now I'll do up arrow, and I'll run this. So here we see the correct console logging, where we deposited $50, and then we withdrew $30. And because we started with the initial balance of 100, we get the expected output of 120. So let's close this integrated terminal and then scroll back to the code that we wrote for this exercise. So an explanation of it, we have private properties and private methods. Here, our private property of the balance of the bank account, and the private method, which is the isValidAmount helper method. So the balance variable and the isValidAmount function are private because they are not exposed via the this keyword. Right? We're using the let keyword and the const keyword. So these are accessible within the block that it is defined in. So accessible within the constructor function. Now we have public methods with deposit, withdraw, and get balance. And they're accessible and public methods because they utilize the this keyword. They could be accessed outside of the function through dot notation. Now for using closures, the public methods demonstrate closures in the sense that they can access the private balance variable and the isValidAmount function because they are defined within the same scope. Right? So closures are inner functions that can access identifiers or variables in its outer function. So some key points on closures. First is it helps us achieve encapsulation, where we hide internal state and functionality, exposing only what is necessary. Another key point is scope. So this is the context in which variables and expressions are visible or can be reference. And to recap on closures, these are functions that can access variables from their outer scope even after the outer function has finished executing. So by completing and attempting this exercise, you have more experience with closures and have a better understanding of how to create private properties and methods to encapsulate the internal state and functionality of objects. Getters and setters are special methods that provide you with a way to get and set the properties of an object. This encapsulation technique allows you to control how important values are accessed and modified in your objects. It's often used to ensure that data encapsulation and validation rules are followed. Here's how you can incorporate getters and setters into the programmer or constructor function using object.defineProperties. So here we have this private property, private name, and we cannot access it through dot notation. So, in order to access that value, you can do object.defineProperties. Now, if I hover my mouse over, that the first parameter is the object where we want to add or modify properties. So I'll use the this keyword, which means this current object or this programmer object. And for the second parameter, I will specify an object. Again, this with a semicolon. And here we'll define the name of the property. So I'll name it name. And then define an object. And here we can use the special keyword for get. And we'll set it to an anonymous function. And this will simply return the private name. So now, if I actually want to use this property, if I've instantiated a programmer object, I can do log, tab, I can say programmer.name. So rather than having to call .get, I simply can access it through a property, and that will call the get method. So let's run this in the integrated terminal. So Command J or Control J, and I name this file 13 getters and setters. So do tab to autocomplete, and then I'll run it. And here I get the name of the programmer, which I have access through that get method that we defined, right? Through that name property, which we defined here. Now we can also set the value. We use the keyword for set, and we'll set this to an anonymous function. The parameter will be the new name that we want to set. Now with setters, we can implement validation rules to ensure that the value that we are setting is appropriate. So I can check and make sure that the new name is not falsy, which means that the new name is not an empty string, value null. So in the case when the value that I was setting is falsy, I can log to the console and I can say the name cannot be empty. And then we will use the return keyword to stop the execution. Otherwise, we will set the private name. So here, say new name. Now let's utilize this setter method. Now we would do this through the name property. If I scroll down here, if I want to set the name, I can say programmer.name, and I'll set it to my name, Steven. Now here, I'll copy this. And here we see the name is changed. So we'll open up the integrated terminal again. Up arrow, and we run it. So here we see I successfully changed the name to be Steven. We're able to accomplish this because of the setter method. Now let's check and make sure that our validation rules apply. So let's say instead of assigning this to my name Steven, let's say if it was an empty string, run it, integrated terminal, clear this out and run it again. Here we see this console log statement saying the name cannot be empty. And then when we log the name again, we see it continues to be Alice, which means that our validation rules were applied. Getters and setters. The name property has a getter and setter defined, and the getter simply returns the current value of the private name, this private property, while the setter allows you to validate the new name before assigning it to private name. So this is an example of encapsulation, utilizing getters and setters, also known as accessors and mutators. And this structure ensures that the internal state of the object, in this case the private name, can only be changed in controlled ways, increasing data integrity and interaction safety. Using getters and setters not only encapsulates the internal state but also allows for additional logic to be implemented when getting or setting a property, such as validation or logging, which enhances the functionality and robustness of your code. In this section, we covered the fundamentals of object-oriented programming, beginning with a definition of OOP and an exploration of its 4 core pillars. We covered essential concepts and techniques, including object literals, factory functions, and constructor functions, which are foundational in understanding how objects are created and utilized in JavaScript. We also discussed the constructor property, which links an object back to its constructor function, and examine how functions themselves can be treated as objects in JavaScript. This leads to a deeper understanding of JavaScript's flexible approach to OOP. Important distinctions between value and reference types were highlighted, clarifying how JavaScript handles data storage and manipulation, which is crucial for effective memory management and performance. Further, we explored dynamic aspects of objects, such as adding, removing, and enumerating properties, providing practical skills for manipulating object properties in real time. The concept of abstraction was introduced, along with practical implementations of private properties and methods, which enhance encapsulation and data hiding in JavaScript. Finally, the use of getters and setters were discussed, illustrating how these can be employed to control access to an object's properties, ensuring data integrity and encapsulation. This section focuses on inheritance, a fundamental concept in object-oriented programming that allows one object to inherit the properties and methods of another. This mechanism is key for reusing code efficiently and effectively. I'll introduce some terms that are critical to understanding different aspects of inheritance. So the terms to first consider are base class, superclass, and parent class. So these are all synonymous and they all mean the same thing, and these terms refer to the class whose features are inherited by other classes. So now consider the terms derived class, subclass, and child class. So these 3 terms are all synonymous as well, and these are classes that inherit properties and methods from the base class. This relationship is often referred to as an is-a relationship, indicating that the derived class is a specialized form of the base class. So I don't expect you to memorize these right away, but I wanted to expose you to these terms so you understand what they are, and we'll see practical examples throughout this course. So we can also differentiate between 2 types of inheritance. The first being classical inheritance. So this is found in class-based languages where inheritance is defined through classes, and these include programming languages like C# or Java. Now, the second type of inheritance is prototypical inheritance. This is specific to JavaScript, and this type of inheritance does not involve classes. Instead, JavaScript uses prototypes. This refers to objects that other objects can inherit properties and methods from. It's important to note that in JavaScript, the traditional concept of classes is implemented differently. While ES6, which stands for Modern JavaScript, introduced class syntax, it is syntactic sugar over JavaScript's existing prototypical inheritance model. Understanding this helps clarify how JavaScript handles inheritance and sets the stage for using these concepts to structure and reuse code effectively. What is inheritance and why is it important? Inheritance is a concept in programming where one object can inherit properties and methods from another object. In JavaScript, this is done through prototypical inheritance, also called prototypal inheritance. It's important because it allows for code reuse, making programs more efficient and easier to manage. Inheritance is one of the 4 pillars of object-oriented programming, along with encapsulation, abstraction, and polymorphism. What type of inheritance model does JavaScript use? Prototypical inheritance or classical inheritance? JavaScript uses the prototypical inheritance model. This means objects can inherit properties and methods directly from other objects, rather than from classes, as in classical inheritance. What do these 3 terms refer to? Base class, superclass, and parent class. In JavaScript, the term is base class, superclass, and parent class all refer to the same concept, the class from which another class inherits properties and methods. These terms are often used interchangeably to describe the original class that provides functionality to a derived or child class. What do these three terms refer to? Derived class, subclass, and child class. In JavaScript, the terms derived class, subclass, and child class all refer to the same concept, a class that inherits properties and methods from another class, with that other class being the parent class. These terms are often used interchangeably to describe the new class that extends the functionality of the original class. In programming, enhancing an object's functionality is a common task. I will initialize some objects. I'll say let user and assign this. So it's just an empty object literal. Then I'll create admin and I'll create a guest. So now consider these three objects that we've created. Now if we were to add properties and methods to this user object literal, and we also have the admin and guest objects, it is beneficial to reuse what we have in the user object, as they're going to have the same properties and methods. Now, the admin and guest objects are more specific versions of the user object. Now, both the admin and guest are users of the website. So we can utilize prototypical inheritance to accomplish this. In JavaScript, objects possess a special hidden property, prototype, that is either null or references another object. This reference object is also called a prototype. When you see the term prototype, think of it as interchangeable with parent, similar to a parent class from which properties and methods are inherited. So I'll add some properties and methods to this user object to demonstrate this. If this user object were to have the property of name, I'll set that to my name. Then the property of surname, so I'll set it to my last name. Email, which is Steven at stevencodecraft.com, is active. Say true. Now I can define some getters and setters, so I'll use the set keyword, and I'll set it to be full name. The parameter will be value. So now we'll perform destructuring, so I'll use square brackets, and I'll say this.name and this.surname is assigned to value.split on whitespace. So with the set keyword, I'll be able to use full name through dot notation and assign it to a value. So for example, it would look like user.fullname is assigned to, let's just say, Bruce Wayne, for example. So here is how we would utilize this setter. Now we call the split method on the value that is passed in, which is this string, and we split it on whitespace. So now we are destructuring it, because when we call split, this stores these strings into an array. So Bruce would be at the 0th index, and Wayne would be at the 1st index. And so that is how we set it here, and this is a clean syntactic sugar that we can use to do it all on one line. So now we'll define a getter. So I'll say get full name, and then I can just return. I'll use backticks, so I can use interpolation. This.name space this.surname. And I'll end this with semicolon. So I need to add a comma here, and then a comma after this. So now I'll add two more methods for login and logout. So I can console.log. I'll use a shorthand, so log, and then backtick this.fullname. Right, so I'm using the setter here. Logged in. Then another comma, and then log out. To log, and then tab, backtick, this.fullname, logged out. So here we see we have implemented properties, the setters and getter, and two methods. Now, this same functionality is also required in the admin object and the guest object. Now, we don't want to duplicate our code and have to copy and paste it. So there is a cleaner way that we can do this, utilizing inheritance, and specifically prototypical inheritance, or prototypical inheritance. So here, rather than having to copy and paste it, because admin is a user of the website, it satisfies that condition. We can use a special property known as proto, which stands for prototype. So it's 2 underscores, then proto, 2 more underscores. And that will be the key for this property. And we set this to user. So what we're doing here is we're saying that the parent of this object is the user object. So it's going to inherit these properties and methods. So this enables us to inherit all this functionality without having to duplicate all the code. So because admin is a more specific version, it is a derived class, it's more specialized than the user object. It's more specific. So I can say is admin is true. So here we are inheriting all the functionality of that user object, and we are also extending it. So I can also add a custom method, manage users, which is just specific to the admin object. So here I would do log and then tab backticks. So here we can utilize what we inherited from the user object. So this.fullname is managing users. Now we can also utilize prototypical or prototypical inheritance in the guest object. So once again, we use proto and the user. So we can say is guest. It's true. And I'll add a custom method here. So say browse content log, and I'll say this.fullname is browsing content. Notice how we are not duplicating properties and methods in our objects. If you attempt to use a property not defined in an object, JavaScript automatically retrieves it from the prototype. This concept is known as prototypical inheritance. The prototype property is internal and hidden, but it can be set in various ways, one of which is using the special proto property that we were using here. So if we didn't set it in the definition of this object literal, let's say if I were to remove this, for example, then we can also set it through dot notation. So I can do admin, proto, assign it to user. So that would work as well. So I'm going to do Command Z, undo this. So if the user object here has many useful properties and methods, they become automatically available in their derived objects. So admin and in guest. And these properties that it inherits is known as inherited properties. So the prototype chain can extend even further. So let's say if we had an even more specialized object, let me define that here. I can say let superadmin, which is an even more specific object with enhanced privileges and enhanced functionality, I can say the proto, right? So its parent object is admin. So it's referencing as a parent this admin object, and this prototype is set to the user object. So superadmin will inherit all of the properties and methods defined here in the user object, and it will inherit the properties and the method of the admin object. So let's add some more specialized functionality. I can say is superadmin is true, and I'll add a method. I'll say manage admins. I'll do log and then tab. This.fullname is managing admins. Cool. So there are some limitations to prototypical or prototypical inheritance. The first being is that prototype references cannot form a circular chain. Otherwise, JavaScript throws an error. For example, setting the user proto object to be superadmin would cause a circular reference. Now, the second limitation is that the proto value can only be an object or null. Other types are ignored. An object may not inherit from 2 other objects simultaneously. The value of the this keyword in methods refers to the current object, even if the method is inherited. So here, we're using the this keyword. It's referring to this current object, the admin. It's not referring to the user object. So setting a property in an inherited object modifies only that object state and does not affect the base object state. So to demonstrate that, if I scroll down here, let's say if I were to do admin.fullname and I set this to Bruce Wayne. Now, say if I log this out, I will log the admin.fullname, and I will log out the user.fullname. I'll bring up the integrated terminal. I go back, and I change into prototypes directory. I'll do node to, and I'll do tab to autocomplete it. If I run it, here I see the admin's name is Bruce Wayne, and by setting it, it did not change its parent. It did not change its prototype, right? So it only affected the current object. So when I log out user, it logs out Steven Garcia, which is the value that we set when we first created the object literal. So now consider the for in loop. So we can use the for in loop to iterate over both the object's explicitly implemented properties and inherited properties of an object. So here, if I just comment this out, I will say for let key in admin. I can do log, and here I would just log out the key. Once again, when we bring up the integrated terminal, I'll clear this, Command K, up arrow, and run it. So here we see is admin. We scroll to the admin implementation. Here we see that property being defined. We see manage users, which is that specialized method we implemented. And we see all of the properties and methods implemented by its parent, by its prototype, in the user object. Now, one thing to differentiate, here we comment this out, if we were to do or utilize object.keys, object.values, or object.entries, this will return only the explicitly implemented properties for that object. It will not output the inherited properties or methods. So if I were to do log, and then I do object.keys of the admin, let's bring up the integrated terminal, up arrow, and we'll run it. So here we see is admin, that property that we explicitly defined, and that specialized method, manage users. So this will not output any of the inherited properties and methods of the prototype. So for this video, we were using the proto property, which is a getter and setter for the internal prototype property. However, in modern JavaScript, we prefer to use object.getPrototypeOf and object.setPrototypeOf. So a summary of what we covered so far. In JavaScript, all objects have a hidden prototype property that is either another object or null. If an object or method is not found in an object, JavaScript looks for it in the prototype. Write and delete operations directly affect the object itself and not the prototype. So by changing that in the derived class, it will not impact the parent object. So by changing that in the derived object, it will not impact the parent object. And the for in loop iterates both over explicitly defined properties and inherited properties of an object, while other key value getting methods only operate on the object itself. So let's go over another example. In JavaScript, we know that inheritance is achieved using prototypes, which are essentially objects that other objects can use as a template. And we know that this process is called prototypical inheritance. So for another example, let's create an object that encapsulates common behavior and properties that are shared amongst all programmers. So I'll use the const keyword, and I'll name it programmer prototype. So the object literal, we'll define a method, so an anonymous function. We'll log it, backticks, say writing code in this dot preferred language, comma, we'll define another method, drink coffee, so an anonymous function, and we will log drinking coffee. Now we'll end this object literal with a semicolon. So now we can create a constructor function, and it will use this base object as its prototype, so as the parent object. So we'll use the function keyword, and we'll name it programmer. The two parameters are the name and the preferred language. So say let private name is assigned to name. So this is a private property. So I can say object.define properties. The first argument will be this for the current object, and we'll pass an object as the second argument. So we'll specify the property to be name. Then we'll have a getter and setter. So define the get anonymous function, and this just returns the private name, comma, then set the new name. Private name is assigned to the new name. Now we'll also set the preferred language. Let's just do that here. This dot preferred language is set to the preferred language. Now, at the bottom, we want to inherit the common behavior. Let me scroll up. Defined in the parent object. So I can say object dot set prototype of. So the first argument will be this for the current object, and the second argument will be the object, which will be the prototype. So in this case, it is the programmer prototype. So let's instantiate this. I'll say const and JS programmer equal to new programmer. So the name will be Alice, and the preferred language is JavaScript. So to better explain what we just implemented, we define a programmer constructor function that has a private property named private name. We define getters and setters, so we can access this private name through the property of name. So this demonstrates encapsulation. So we are hiding the inner details of this object. And we also set the prototype with the method setPrototypeOf. So this will allow all instances of programmer to utilize the methods built into its parent object. So all instances, when we call a programmer, will have the writeCode method and the drinkCoffee method. So now let's verify that the inheritance is working correctly by calling the methods on this JS programmer object. So we can do JS programmer dot writeCode. You can try JS programmer dot drinkCoffee. Now we'll log it out. So it'll be JS programmer logging out the name. So here we are utilizing this getter to get the private name. Now we'll use the setter, and I'll set this to my name, Steven, and we will log out the updated value. So jsprogrammer.name. So let's scroll up and open up the integrated terminal with Command J. So up arrow, and we run it. So here we see the result of the writeCode method. It says writing code in JavaScript. If I scroll up, this functionality is in the prototype. Here we see writing code in preferred language. Now when we called the drinkCoffee method, this outputted the expected string drinking coffee. Now if I scroll back down, we outputted the name, so we got Alice. We updated the name and logged that out, and we saw the name of Steven. So this example showcases how to effectively use prototypes to implement inheritance in JavaScript, allowing for shared behavior and properties while maintaining encapsulation of private data. So by leveraging prototypes, the programmer object can be extended to create various types of programmers with minimal code duplication. What is the proto property? In JavaScript, the proto property is a reference to the prototype of an object. It allows objects to inherit properties and methods from another object. This property is used to set or access the prototype directly, but it is considered outdated. Instead, modern JavaScript uses object.getPrototypeOf and object.setPrototypeOf for these tasks. In JavaScript, multi-level inheritance allows objects to inherit properties and methods from multiple levels of prototypes. So consider this simple example. If I just declare an array, and I assign this to an empty array, so when my array is created, it is not just an instance of an array, but also part of a larger inheritance hierarchy. So my array is an instance of array, and array.prototype, also referred to as array base, provides methods and properties common to all arrays. Now, object.prototype, also referred to as object base, is the prototype for array base. It provides methods and properties that are inherited by all objects in JavaScript, including arrays. This setup forms a multi-level inheritance chain, where my array inherits from array.prototype, and array.prototype inherits from object.prototype. This is how the inheritance looks in a structured form. So the base is object.prototype, also known as object base. Then array.prototype extends that, also known as ArrayBase, and then our instance of the myArray. So some key points: objects created by a specific constructor, like array, will share the same prototype, in this case array.prototype. This multi-level inheritance allows objects like myArray to access properties and methods defined in object.prototype, giving JavaScript its dynamic and flexible nature. Understanding this inheritance structure helps in recognizing how methods like toString or hasOwnProperty are available to your array, even though they are not directly defined within the array constructor or on the array instance itself. This concept is fundamental to mastering JavaScript's prototype-based inheritance and helps in designing more efficient and robust applications. So moving forward in this course, we'll be using the live server extension in VS Code in order to improve our productivity and reduce our need to run our code in the integrated terminal. So click on the icon for the extensions marketplace and search for live server. So this extension allows us to have hot reloading, where it will run our JavaScript code in a web browser, and when we make a change in our JavaScript code, it will automatically update and we can see those changes without having to constantly run it in the terminal. So now that you have that installed, I'll close this. Back to our folders. I'll create a directory, so you can click on this icon, and I'll name it _practice. You can name it whichever you prefer. Now within it, I'll create a new file, and I'll name it index.html. Now I'll be creating a course on HTML and CSS, so no need to be an expert in those technologies. We just need this file in order to open up a web page with live server. I'll also create a file named index.js. And here we will place our JavaScript code for our lessons. So back to the HTML file. We need to create the boilerplate for an HTML document. So Visual Studio Code will generate this for us. Simply type in an exclamation point, and here we see Emmet abbreviation. So just do tab, and here VS Code generated this for us. So now we want to reference our JavaScript file. So within the body elements or body tags, type in script, and then type text/JavaScript. Now we will reference our index.js file here. So we'll do source./index.js as it's in the same directory. Then we will have a closing tag, and that's it. So now we'll open up our command palette. So that's Command-Shift and P or Control-Shift and P. Type in live server, open with live server. So this will open our index.html in our web browser. Now because we don't have any HTML written between the body, it's just a blank web page for now. So let me close the sidebar with Command B, and I will resize this. So now our JavaScript will be running in the JavaScript console, but we can see that in the DevTools. Also, I suggest that you use Google Chrome unless you are more comfortable with Microsoft Edge or Firefox. So now to open up the Google DevTools, the keyboard shortcut is Command, Option, and J. You can also right-click and then click on Inspect. So here, in order to get this to open in a new window, click on these three dots. And here when it says Dockside, you want to click the leftmost icon. So this will open the DevTools in its own window. Now to see our JavaScript code, you want to click on Console. So now we can click on this settings icon to hide that. Now, in order to see and execute our JavaScript code, type in log, right, and then we'll do tab, and then hello world. Then save it, and now we see it reflected on the right side console. So we no longer have to constantly run it in the integrated terminal. So here I'll do Command and plus, so we can see the text more easily. So in JavaScript, we know that we can define an object like this by creating an object literal. Say the name and the value is Steven. We can end this with a semicolon, and we can log out this object, the person. And here we see outputted on the right-hand console. Now let's iterate through this using a for in loop. So I can do for let key in person, then log, and tab, and just log out that key value. So here we see the key of name was outputted. Now notice how only the properties defined directly in this person object are displayed. Similarly, if we use object.keys, so let's log that out, object.keys, and then the person object, we output that, we see the value of name. So this only shows the properties defined at the object's own level. So the properties that it inherited from object.prototype, also referred to as object.base, aren't displayed because of specific attributes attached to those properties. So these attributes can control whether properties are enumerable, writable, and configurable. So in other words, these attributes determine whether the property will be outputted when iterating over it, such as with a for in loop, or if using object.keys, object.values, or object.entries. So let's see this in action. I'll clear this out. And we'll examine the property descriptor for the toString method, which this person object inherits from object base. So I'll clear this out as well. And I will expand this so we can see it more easily. So we'll say let object base assign to object.getPrototype of the person object. So we're getting the parent object of this person object. Now we will do property descriptor. So this is object.getOwn property descriptor of the object base, so that parent object, and the toString method, which is defined in its parent. So now we'll do log tab property descriptor, and we will see those attributes that determine whether the toString method will be shown when we enumerate through the person object. So let's save this, and we'll see the result in our console. Let's expand this. So we see the attributes of configurable, enumerable, what the value is, and writable. So the one we are concerned about is the enumerable, and we see the value is set to false. So when the enumerable attribute is set to false, this prevents the toString method from appearing in the output of a for in loop and methods like object.keys. So you can also define or modify these attributes, so configurable, enumerable, and writable, for properties in our own objects. So for instance, if we wanted to make the name property here non-enumerable, you could do this. So we can do object.define property. Now the name of the object and the name of the property. And we can pass in an object where we can define these attributes. So we can say writable is false. Now enumerable is false. So now it won't show up when we do a for in loop. And configurable is true. So let's comment this out for now. We'll expand this. So after this change, the name property will no longer appear in a for in loop or object.keys. So let's just demonstrate that. Let key in the person object. Then we can log all the keys that are enumerable. Then we resize this. And we can clear this out by clicking this icon. You can save it. And here we see there are no enumerable keys. So no enumerable properties in this person object, because we defined this here for the name property. So by default, when properties are created directly on an object, they are writable, enumerable, and configurable attributes are set to true. This allows properties to be modified, enumerated, and reconfigured unless explicitly changed. Understanding these property attributes and their implications helps in managing how data in objects is accessed and manipulated, providing greater control over object behavior in JavaScript applications. What are the property descriptors or attributes in JavaScript that determine whether a property can be accessed, modified, or iterated over? In JavaScript, property descriptors or attributes that determine whether a property can be accessed, modified, or iterated over are enumerable, writable, and configurable. So for enumerable, if true, the property will appear during for in loops and object.keys. For writable, if true, the property's value can be changed. For configurable, if true, the property descriptor can be changed and the property can be deleted. In JavaScript, every object has a prototype, except for the root object, which is at the top of the prototype chain. The prototype acts as a template or parent from which the object inherits methods and properties. Accessing an object's prototype. The recommended method to get the prototype of an object is by using object.getPrototypeOf. This function returns the prototype, or the parent, of the specified object. Constructors and their prototypes. In JavaScript, constructors are special functions used to create instances of objects. Since functions in JavaScript are objects themselves, they too have properties, one of which is the prototype property. This property is not the prototype of the constructor itself, but rather the object that will be used as the prototype for all instances created with that constructor. So for example, if I create a constructor function with the function keyword, and if I name it circle, now the code within the code block, so that will be used for instantiating a new circle object. So now, if I log this out, we know that functions are objects in JavaScript. So I can do circle, and it has a property of prototype. So if we log that out, here we see this empty object. We can expand it. This object is used as the parent for all objects created with new circle. Close this out, and I can comment this out. Creating objects and their prototype links. When you create a new object, its prototype, or its parent, is set to the prototype of its constructor function. So this is illustrated with, say if I create an object literal, and I assign this to curly braces. So this is syntactic sugar for let object equal to new object. So the prototype of obj or object can be referred to using the proto property, which is an accessor property that exposes the internal prototype linkage. So we'll just log that out. Log, and then tab, see, the object, and then 2 underscores, before and after proto. So here we outputted that. We can expand it. So this would be the same as doing, say if we do log, object.prototype. So we get the same output. Close this, we expand it. So now if we were to expand it, we can expand the get, and here we see the internal prototype is object. So understanding how prototypes and constructors work in JavaScript is crucial for effectively leveraging the language's object-oriented capabilities. By grasping these concepts, developers can better manage and utilize object inheritance in their programs and reduce code duplication. Does every object have a prototype? In other words, does every object have a parent object? Every object has a prototype, or a parent object, except for the root object, which is at the top of the prototype chain. So an object will inherit the properties and methods from its prototype or parent object. Do constructor functions have their own prototype? Yes, constructor functions have their own prototype. In JavaScript, functions are objects, so they have their own prototype property, which is used to assign properties and methods to instances created by the constructor function. Optimizing memory usage with prototypes in JavaScript. In practical applications, especially those involving numerous object instances, it's important to manage memory efficiently. If each object instance were to maintain its own copies of methods, this would lead to significant memory overhead when dealing with thousands of objects. How JavaScript handles method access. To address this, JavaScript utilizes prototype-based inheritance. When a method is called on an object, the JavaScript engine first checks if the method exists on the object itself. If the method is not found, the engine then looks up the prototype chain of the object. Utilizing the prototype property. Each constructor function in JavaScript has a prototype property, which is shared by all instances of the constructor. This shared prototype is crucial for memory efficiency. So to demonstrate an example of this, we just create a constructor function, name programmer, the 2 parameters being name and preferred language. Then we use this keyword to assign it and the preferred language. So now, methods added to the prototype are shared across all instances. So I will expand this just so we can see it more easily. We can do programmer, so that constructor function dot prototype dot write code. So we can assign this to an anonymous function, and here we do log and backtick, so we can use interpolation. This.name writes code in this.preferred language. We can end this with a semicolon. We could also override the toString method for all instances. So we can do programmer.prototype.toString, assign this to an anonymous function. Say programmer, this.name, comma, language, this.preferred language. End that with a semicolon. So now let's create an instance of this programmer. So I can say const JS programmer, new programmer. I'll say Alice, and the language is JavaScript. Now let's just call it JS programmer.writeCode. Now we save it. And here in the console, we see the expected output. So the advantages of using prototypes, let me expand this again so we can see the code. The first advantage is memory efficiency. Since methods defined on the prototype are shared, there is only one copy of each method in memory, regardless of the number of instances. This is especially beneficial in applications where many instances of a class are created, as it saves a significant amount of memory. So for example, if we were going to create many programmer objects, they would all share these same methods. So write code and this implementation of the toString method. So the second advantage is flexibility. JavaScript's dynamic nature allows you to add or modify methods on the prototype at any time. Modifications to the prototype are reflected across all instances immediately, which can be particularly useful for updating functionality at runtime. And the third advantage is overriding methods. So you can easily override inherited methods by defining new implementations on the prototype. For example, the toString method for programmer has been overwritten to provide more specific information about each programmer instance. Managing instance and prototype members. So first consider instance members. These are defined within the constructor function, and these are unique to each instance, such as the name and preferred language in the programmer constructor. These properties are set per individual object and manage data that varies from one instance to another. Now consider prototype members. These are defined on the constructor's prototype, and these members are shared across all instances, like the write code and toString methods. This setup is optimal for methods that perform generic actions applicable to all instances. By strategically using prototypes to share methods among instances, you can enhance your JavaScript applications both in terms of performance and maintainability. This approach ensures efficient memory usage while maintaining the flexibility to adapt the shared behavior of objects. How does using prototype-based inheritance in JavaScript help in managing memory efficiently when dealing with numerous object instances? Using prototype-based inheritance in JavaScript helps manage memory efficiently because methods defined on the prototype are shared among all instances of an object. Instead of each instance having its own copy of the method, there's only one copy stored in memory. This significantly reduces memory usage, especially when creating thousands of instances, as all instances refer to the same method on the prototype. What are the advantages of defining a method on a constructor's prototype as opposed to defining them within the constructor function itself? Defining a method on a constructor's prototype in JavaScript has several advantages. One being memory efficiency. Methods on the prototype are shared by all instances, so only one copy of each method exists in memory, saving space when creating many instances. A second advantage is consistency. Changes to a prototype method are immediately reflected in all instances, making it easy to update functionality across multiple objects. The third advantage is performance. Shared methods reduce the memory overhead and can lead to better performance, as there is no need to duplicate methods for each instance. Understanding prototype dynamics in JavaScript. So in JavaScript, changes to a constructor's prototype affect all instances, regardless of whether they were created before or after the changes. This behavior highlights JavaScript's use of object references for prototypes. Consider the programmer constructor function. So, let's create this. Takes the name and preferred language as parameters. We'll set these properties. So now, Let's instantiate it. I'll say const. I'll just call this programmer, new programmer, with the name of Steven and the language of JavaScript. So now let's add a new method to the programmer prototype. So we'll do programmer prototype write code, sending this to an anonymous function, console.log, say this.name, writes code in this.preferred language. We end that with a semicolon. And let me expand this so we can see the full method. So even though programmer, this instance, was created before the write code method was added to the prototype, this instance can still access the write code method. So let's do that. We'll do programmer.writeCode. We can save that. And here in the console, we see the console log statement, Steven writes code in JavaScript. So enumerating object properties. So using a for in loop, you can enumerate over all properties of an object, including those on the prototype. So here we can do for let key in programmer. We'll do log. We'll output the keys. And let's comment this out for now. We can save that. Now here, we have enumerated over the properties. So we have the name, the preferred language, and the method write code. So based on the JavaScript documentation, properties defined directly on the object are referred to as own properties, while those inherited from the prototype are called prototype properties. So checking for own properties. You can use the hasOwnProperty method to determine if a property is an own method of the object. So we'll see an example of that. Do log programmer.hasOwnProperty. We'll say the name. Output that. And here we see the output of true. Let me comment this out. We'll clear it just so it's easier to see. So that the name property is an own method, meaning that it was defined within the constructor function. So let's see another example. I'll do shift option and down arrow to copy that. And I'll specify write code. So this is the name of the method or the member that was defined on the prototype. Here when we save this, we get the value of false, indicating that this is a prototype property. So this method, hasOwnProperty, helps distinguish between properties that are part of the object itself and those inherited from the prototype. Understanding the distinction between own and prototype properties is crucial for working effectively with object-oriented features in JavaScript. This lesson demonstrates the dynamic nature of prototypes and their practical implications, providing a deeper understanding of how JavaScript handles object properties and inheritance. How does adding a new method to a constructor's prototype affect existing instances of that constructor in JavaScript? Adding a new method to a constructor's prototype in JavaScript makes that method available to all existing instances of that constructor, as well as any new instances created afterward. This is because instances reference the prototype for methods, so they automatically have access to any new methods added to the prototype, even if they were created before the method was added. What is the difference between own properties and prototype properties in JavaScript? And how can you check if a property is an own property of an object? In JavaScript, own properties are those defined directly on an object, while prototype properties are inherited from the object's prototype. To check if a property is an own property of an object, you can use the hasOwnProperty method. If this returns true, the property is an own property. If it returns false, the property is inherited from the prototype, or from its parent. While JavaScript allows you to extend the functionality of built-in prototypes, such as adding a shuffle method to array.prototype, it is generally advisable to avoid doing so. So here's an example of what it might look like. Do array.prototype, and we extend it by adding a shuffle method, assigning this to an anonymous function, and here I'll just add a comment. This would be the implementation of the shuffle. So then when we create a new array, assign this to an empty array, then I'll be able to call array.shuffle. So here, let me open up the tools. And let's just log something out. I'll just do log, and I'll say shuffle. I save that. Here we see the output of shuffle. So this approach may seem convenient because we can add our own custom methods to built-in data types in JavaScript. However, it carries significant risk, so there is a potential for conflict. For example, library conflicts. If you modify a built-in prototype, you risk conflicts with third-party libraries that might rely on the default behaviors of these objects. Different implementations of the same method can lead to inconsistent behavior across parts of your application. As a best practice, do not modify objects that you do not own. This helps with maintainability and compatibility. Modifying objects that are globally accessible, like built-in prototypes, can make your code harder to manage and predict. It may also break compatibility with future versions of JavaScript or interfere with enhancements in third-party libraries. So for an alternative approach, instead of modifying built-in prototypes, consider a safer alternative. You can use a utility function. So rather than doing this, I comment that out. You can do function shuffle array. This takes in an array as parameter variable. And here you have the shuffle logic here, and then you return the array. So then, to utilize that, you can simply do const shuffle array. Then you simply invoke that function and pass in the array. Now you can also extend the prototype safely. So if absolutely necessary, you want to ensure that your modification does not overwrite existing methods and check if the method isn't already defined. So, for example, you can do if type of array.prototype.shuffle. So if the type of is not a function, meaning that it's not defined, then I just copy this and paste it here and uncomment that. Do tabs. So this is an example of how you can extend the prototype safely. By adhering to these guidelines, you ensure that your JavaScript code remains robust, maintainable, and compatible with other libraries in future updates. Why is it generally advisable to avoid modifying built-in prototypes in JavaScript? It is generally advisable to avoid modifying built-in prototypes in JavaScript because doing so can cause conflicts with third-party libraries that rely on the default behaviors of these objects. Modifying prototypes can also make your code harder to maintain and predict. It might break compatibility with future versions of JavaScript or interfere with enhancements in other libraries. What are some safer alternatives to modifying built-in prototypes in JavaScript, and how can they help maintain code compatibility and predictability? Some safer alternatives to modifying built-in prototypes in JavaScript include using utility functions, where you create standalone functions to add new functionality without affecting built-in prototypes. This avoids potential conflicts and keeps your code isolated and maintainable. You can also extend prototypes safely, so if you must extend a prototype, first check if the method already exists to avoid overriding existing functionality. These approaches help maintain code compatibility and predictability by preventing conflicts with existing or future code and ensuring your additions do not interfere with standard JavaScript behavior or third-party libraries. So to summarize inheritance and prototypes in JavaScript, this section has provided a thorough exploration of several key concepts in JavaScript related to object-oriented programming. We began by understanding inheritance, including prototypes and prototypical inheritance, which are fundamental to how JavaScript handles objects and classes. We discussed multi-level inheritance, where objects inherit properties and methods across multiple levels, allowing for a more structured and hierarchical object model. The use of property descriptors was covered to control and manage how properties behave, including their enumerability, configurability, and writability. Further, we examined the distinction between constructor prototypes and instance members, emphasizing the difference in roles of each in JavaScript programming. The process of iterating over both instance and prototype members was covered, giving practical insight into how to access and manipulate object properties effectively. Lastly, we addressed best practices regarding prototype manipulation, specifically advising against extending built-in objects. This practice, while possible, can lead to conflicts and compatibility issues, especially when dealing with third-party libraries. Overall, this section aimed to equip you with a solid understanding of how inheritance and prototypes contribute to efficient and effective JavaScript programming, promoting better coding practices and a deeper understanding of the language's capabilities. What is the significance of prototypes and prototypical inheritance in JavaScript's handling of objects and classes? Prototypes and prototypical inheritance are crucial in JavaScript because they allow objects to inherit properties and methods from other objects. This enables code reuse and efficient memory usage, since methods can be shared across instances rather than duplicated. Prototypical inheritance also supports a flexible and dynamic object model, allowing developers to extend and modify objects at runtime, which is fundamental to JavaScript's object-oriented programming capabilities. How do property descriptors help manage the behavior of object properties in JavaScript, and what attributes can they control? Property descriptors in JavaScript help manage the behavior of object properties by allowing you to control specific attributes of those properties. The attributes they can control are enumerable. This determines if the property shows up in the for and loop and object.keys. Writable. This determines if the property's value can be changed. And configurable. This determines if the property descriptor can be changed and if the property can be deleted. Using property descriptors, you can precisely define how properties behave, making your objects more secure and predictable. Why is it generally advised against extending built-in objects in JavaScript, and what are the potential risks of doing so? It is generally advised against extending built-in objects in JavaScript because it can cause conflicts with third-party libraries that rely on the default behavior of these objects. This can lead to inconsistent behavior and bugs. Additionally, modifying built-in objects can make your code harder to maintain and predict, and it may break compatibility with future versions of JavaScript or interfere with updates in other libraries. A better practice is to use utility functions or safely extending prototypes by checking for existing methods. When building software, duplicating methods across different objects not only consumes more memory, but also goes against the DRY principle. DRY stands for Don't Repeat Yourself. Let's consider how we can use inheritance to share common functionality in a way that aligns with best practices. Imagine we have multiple types of programmer objects, such as front-end programmer and back-end programmer, and they share some common behaviors. Instead of duplicating methods across both constructors, we can define a generic programmer object that contains shared methods. So let's define a base shape for our shared methods, and we name it programmer. Now this will accept one parameter, which will be name. So we can set this property for the name, and we can define all of the shared methods that we want. So we can do this.code, assigning this to anonymous function, and here we log out, this.name, starts coding. Then we can define this.debug. Let's extend this so we can see it more easily. Function. And here we log out. This.name is debugging. And our last method, this.meeting, we log it out. This.name is attending meetings. So here, let's create two instances of this. So we can say Alice, we call a new programmer to call this constructor function, pass in the name, and let's duplicate it. So Shift Option and down arrow. I'll pass in Steven. So now, let's do alice.code and steven.code. Right here, we save this, and we see the expected console log statements. So when you define methods directly within the programmer constructor function, each instance of programmer will have its own copy of these methods. So here, the instance of Alice will have its own methods for code, debug, and meeting, as well as the instance for Steven. This approach is less efficient in terms of memory usage because every instance has duplicate methods. So remember, functions are objects in JavaScript. So let's compare the code functions for these two programmer objects. So here, I comment this out, and then I'll log out, alice.code, so that reference, and we'll see if this is strictly equal to steven.code. So we are comparing to see whether these functions reference the same object. So we see the value false. So in this case, Alice and Steven each have their own copies of the code, debug, and meetings method, which is redundant and can consume more memory, especially if you create many instances. So here, we can clear this out. I'm going to expand this. So instead of defining these three methods in the constructor function, we can define it in the prototype so that these methods will be shared. I can define it here, do programmer.prototype.code, and then I can assign the function here. And I'll do the same with the other methods. So programmer.prototype.debug. We'll copy this and paste it there. Now we have one more for the meetings. Programmer.prototype.meetings. And then we will copy the implementation here. Now since we defined on the prototype, we can remove this. So now when we compare these functions, so alice.code and steven.code, we saw the output of true because they are referencing the same function on the prototype. So these functions are shared amongst all instances. So when you define methods on the programmer.prototype, all instances of programmer share the same method implementation. So this is more memory efficient because the methods are not duplicated for each instance. Instead, they are shared among all instances, which is the essence of prototypical inheritance in JavaScript. In this case, Alice and Steven share the same code, debug, and meetings method, which are defined on the prototype. This reduces memory usage and ensures that all instances benefit from any updates to these methods without needing to update each instance individually. What are the benefits of defining methods on the prototype of a constructor function in JavaScript? And how does this approach align with the drive principle? Defining methods on the prototype of a constructor function in JavaScript provides two main benefits. The first being memory efficiency. Methods defined on the prototype are shared among all instances of the constructor. This reduces memory usage since each instance does not create its own copy of the method. The second benefit is code reuse. By using the prototype, you avoid duplicating code across multiple instances, aligning with the drive principle. This makes the code easier to maintain and update. In summary, prototypical inheritance allows for shared behavior and memory efficiency, making your code more maintainable and performant. So let's summarize what we covered so far. We implemented methods on the prototype for three reasons. One is memory efficiency. So defining methods on the prototype ensures that all instances share the same method implementations, reducing memory usage. The second benefit is method sharing. So prototype methods are shared among all instances, making it easier to maintain and update the methods. And the third is the benefit of inheritance. Prototypical inheritance leverages the shared behavior, allowing derived objects like front-end programmer and back-end programmer to inherit and use these methods without duplication. By defining methods on the prototype, you adhere to the principle of efficient memory usage and code reuse, making your JavaScript code more maintainable and performant. Now let's define more specific programmer roles. You can expand this. Scrolling up, we can create a front-end programmer constructor function. So this also takes in a name. And we'll create our constructor function for a back-end programmer. Now we want to call the programmer constructor function to initialize the name property. So we want this version, front-end programmer and back-end programmer, to be derived objects that inherit from the programmer constructor function. So in order to call the programmer constructor function, we'll do programmer.call. Now, for the first argument, we will pass the current context. So we use the this keyword. So this references this current object, meaning the instance of the front-end programmer. Now, for the second argument, we will pass a name, because that is the expected parameter for the programmer constructor function. So here when we scroll up, this constructor function expects a name. So we can also repeat this for the backend programmer. So using programmer.call, we are calling the programmer constructor function and setting the context to the new instance of the front-end programmer or back-end programmer. This ensures that the name property is correctly initialized for each specific programmer type. So, for setting up the inheritance, to enable the front-end programmer and back-end programmer to inherit the methods from the programmer prototype, we need to set their prototypes to be instances of the programmer constructor function. So to do that, we can do front-end programmer.prototype. This is assigned to object.create programmer.prototype. Now we repeat this, so shift option down arrow for the backend programmer. I'll also set the constructor. So frontend programmer.prototype.constructor, and set this to frontend programmer, and we'll repeat that for the backend programmer. So now frontend programmer and backend programmer instances can use the methods defined in programmer. So it has access to code, debug, and the meeting method. So let's actually see this. Here I will set this here. We'll clear it out. Let's comment out this console log statement, and we'll utilize these two instances. We can do const, say Joe is new frontend programmer, the name of Joe. So here we can say joe.code, joe.debug, and joe.meeting. And we see the expected console log statements defined on the programmer prototype. Now let's create an instance of the backend programmer. So I can say const, and I'll say gen new backend programmer gen. So we'll call the same methods gen.code, move this up, gen.debug, and gen.meeting. And here we see the expected console log statements. So this setup uses prototypical inheritance to share common methods among different types of programmers, minimizing redundancy and enhancing maintainability. By structuring objects in this way, you effectively utilize JavaScript's dynamic nature and prototypical inheritance to create more efficient and organized code. This approach ensures that all specific programmer types benefit from updates to the programmer prototype without needing to modify each constructor separately, adhering to efficient coding practices and the principles of object-oriented design. How does using programmer.call, passing in for the first argument the this keyword, and for the second argument passing in the name, within the constructors of frontend programmer and backend programmer, ensure proper initialization of the name property for these specific programmer types? Using programmer.call within the constructors of frontend programmer and backend programmer ensures proper initialization of the name property by calling the programmer constructor with the current instance, the this keyword. So this way, the name property is correctly set for each frontend programmer and backend programmer instance, just like it would be for a programmer instance. Why do we use object.create and pass in for the argument programmer.prototype to set the prototypes of frontend programmer and backend programmer? And what is the significance of resetting their constructor properties? We use object.create to set the prototypes of frontend programmer and backend programmer so they can inherit methods from programmer. This allows instances of these objects to share the same methods, making the code more efficient. Resetting their constructor properties ensures that instances are correctly identified as front-end programmer or back-end programmer, maintaining proper type identification. So recap and core concepts. The term prototype in JavaScript essentially means the parent object. In our constructor functions, we define properties and methods. Often we define a general constructor function, like programmer, which contains common properties and methods. So in this case, the name property and the code method. However, we may need to create more specialized objects, such as front-end programmer, which has specific capabilities. Instead of duplicating the properties and methods defined in programmer, we use prototypical inheritance, also called prototypal inheritance, to reduce code duplication. By doing this, front-end programmer, so this, will inherit the properties and methods from the programmer parent object. When we call a method, such as this code method, JavaScript checks the front-end programmer object. If it doesn't find the method definition, it looks up the inheritance chain to the programmer prototype and uses the method defined there. This setup means we write less code, which is easier to maintain and modify because the code is defined in one place and reuse. As applications grow, reducing code duplication through inheritance makes logical sense. So addressing constructor property issues in prototypical inheritance. When implementing inheritance, a common issue is the constructor property. This property is important for creating instances dynamically based on the constructor function associated with a prototype. So let's illustrate this with our programmer example. Here we have the parent object, or the base object, and we have the derived object, the front-end programmer, which is a more specialized version of the programmer base. By using programmer.call, we inherit the name property, but we also want to inherit its methods. So to do this, we would do front-end programmer.prototype assigned to object.create programmer.prototype. Right, so add a comment here. So this is setting up inheritance. So we inherit methods. So every object has a constructor property, which refers to the function called to initialize the object. When we call new front-end programmer, so here when we are creating an instance of front-end programmer, we wanted to call the front-end programmer constructor. This refers to this constructor function. However, after setting the prototype to object.create and passing in programmer.prototype, as we did here, to inherit the methods, the constructor property of front-end programmer.prototype points to the programmer constructor function. So it's pointing to this constructor function as opposed to this one. So this can cause confusion. So to demonstrate this, you can log it out, say front-end programmer.prototype.constructor, and strictly equal to this constructor function. Just to demonstrate that it is now referencing this constructor function rather than the front-end programmer constructor function that we wanted to. So, we can resize this so we can see the output in our console, and I'll save it. And here we see the value of true. So this shows that it's referencing this constructor function. So to correct this, we reset the constructor property after changing the prototype. Right, so after we inherit the methods, then we need to make sure that we're referencing the correct constructor function. So to do this, we would do front-end programmer.prototype.constructor, and we assign this to the front-end programmer constructor function. So now, here when we log this out, if we save this again, we see the value is false, because the front-end programmer constructor function is no longer referencing the programmer constructor function. So to recap, whenever you change the prototype of a function in JavaScript, reset the constructor property. This ensures the constructor property accurately reflects the actual constructor function for instances, preventing potential issues in object creation and inheritance. This practice maintains consistency and predictability, especially in complex inheritance hierarchies. What is the primary benefit of using prototypical inheritance in JavaScript when creating specialized objects like front-end programmer from a general constructor function like programmer? The primary benefit of using prototypical inheritance in JavaScript is that it reduces code duplication. By inheriting properties and methods from a general constructor function like programmer, specialized objects like front-end programmer can use those shared features without having to rewrite them. This makes the code easier to maintain and update since the common code is defined in one place and reused across different objects. Why is it necessary to reset the constructor property when setting up inheritance using object.create in JavaScript? And what potential issues can arise if this step is omitted? It is necessary to reset the constructor property when setting up inheritance using object.create in JavaScript because object.create changes the prototype, which can mistakenly point to the wrong constructor. If you don't reset it, the constructor property might refer to the parent object, like programmer, instead of the child object, like front-end programmer. This can cause confusion and bugs when creating new instances, as JavaScript won't know the correct function to use for initializing the objects. How does JavaScript handle method lookups in the context of prototypical inheritance, and what is the sequence of steps when a method like code is called on an instance of front-end programmer? When a method like code is called on an instance of front-end programmer, JavaScript follows these steps. The first is checking the instance. JavaScript first looks for the code method directly on the front-end programmer instance. Second, check the prototype. If it doesn't find the code method on the instance, it looks up the prototype chain to the front-end programmer.prototype. Next, it checks the parent prototype. If the code method isn't there, it continues up the chain to programmer.prototype, where it finds and uses the code method defined there. This process ensures that the instance can use methods defined in its own class or any parent class, following the inheritance chain. So in object-oriented programming in JavaScript, constructors play a crucial role in setting up new objects. So constructor functions essentially refer to the function that is called or invoked to instantiate an object with a given state. So we will modify the programmer constructor that we've been working on. So we can do function, we can call it programmer, and we'll specify two parameters, so the name and the specialization. And we can set that here with the this keyword and this.specialization assigned to specialization. So now let's create a derived constructor function. So this will be a more specific type of programmer, which we will call a front-end programmer, who will also have a preferred framework along with a name and specialization. So we have function, front-end programmer, name, specialization, and preferred framework. So to inherit the name and specialization properties from this parent object, rather than having to duplicate that code, we do programmer.call. For the first argument, we'll pass in the this keyword. So that refers to this current object. And then we'll pass in name and specialization, because these are the two arguments needed, because these are the two parameter variables defined in this programmer constructor function. So now that we've inherited those two properties, we need to assign our preferred framework. Now that we implemented that, let's create an instance of front-end programmer. We can say const, say Steven, new front-end programmer, Steven. For the name, the specialization will be front-end, and the preferred framework, we'll specify that to be React. So React is actually a JavaScript library, but in this context, we will consider it a framework. So let's talk a bit about the new keyword. When you use the new operator, several things happen. First is a new object creation. So JavaScript creates a new object in memory. Second is setting the prototype. It sets the prototype of this new object to the prototype of the constructor function from which it was called. So it would be programmer.prototype if you were to do new programmer, and it is front-end programmer.prototype for when you do new front-end programmer. So third is executing the constructor. The constructor function is called with the this keyword bound to the newly created object, allowing properties and methods to be assigned to this. And fourth is returning the object. Unless the constructor explicitly returns a different object, the new object is returned by default. So let's discuss the this keyword. So in the context of a constructor function called with the new operator, by default, the this keyword refers to the new object being created. And second, if the constructor function is called without the new operator, then it would refer to the global object. So this would be the window object in browsers or the global object in Node.js, which can lead to unexpected behaviors and errors. Show an example of this. Here we log out. The front-end programmer name. Now to shift option down arrow to create those copies, the specialization, and the preferred framework. Let's resize this so we can see our output in the console. We can clear this out. And when we save it, we get our expected output, logging our properties. So the key takeaway, using constructor functions properly with the new operator ensures that the new objects are set up correctly with their intended prototypes and properties. It is essential to use the new operator to avoid unintended side effects and ensure that the this keyword behaves as expected within the constructor function. This mechanism is fundamental for implementing inheritance and creating a hierarchy of objects in JavaScript. Explain the steps involved when the new operator is used with a constructor function in JavaScript. Why is it important to use the new operator when calling a constructor function? When the new operator is used with a constructor function in JavaScript, the following steps occur. First is a new object creation. So, a new JavaScript object is created in memory. Second is setting the prototype. The new object's prototype is set to the constructor function's prototype. Third is executing the constructor. The constructor function is called with the this keyword bound to the new object, allowing properties and methods to be assigned to it. And the fourth step is returning the object. The new object is returned automatically unless the constructor explicitly returns a different object. It's important to use the new operator to ensure that the this keyword refers to the new object being created. Without the new operator, then the this keyword will refer to the global object or be undefined if you were using strict mode, leading to unexpected behaviors and errors. So refactoring with the programmer function. So suppose we have a base programmer class and specific subclasses like front-end programmer and back-end programmer. So here's how you can set up inheritance using a generalized extend function. So we have our base programmer constructor function and a method. Now let's create our specific programmer types. So that's function front-end programmer with the name. We call programmer.call, this, and name. So let's copy this and we'll create our backend programmer. So let's define an extend function that automates the process of setting up prototypical inheritance between a parent and a child constructor function. So we can inherit the methods and properly assign the constructor function. So we can do function extend. So for the first parameter variable, I'll specify that to be the child object or child class. And the second will be the parent. So we want to inherit the methods of the parent. So we do child.prototype is assigned to object.create parent.prototype. So then we will assign the constructor prototype.constructor to the child. So now using the extend function. So with this extend function implemented, you can easily set up inheritance for any number of specific programmer types by simply calling it. So we'll just do extend front-end programmer and programmer. So I'll do shift option and down arrow, and I'll pass in back-end programmer. So now let's test the implementation. I'll resize this so we can see it in our console. So we'll create instances of the front-end programmer. So that's a const Steven assigned to new front-end programmer. And I'll do shift option and down arrow, and I'll just change this to be back-end programmer with the name of Alice. So now we can call and invoke the method that we inherited, which is the code method here. So it is defined on the parent object, which is programmer. So we can do Steven.code, and we can do Alice.code. And here when we save it, we get the expected output. So the benefits of using the extend function, the first is encapsulation. So by encapsulating the inheritance logic in the extend function, we avoid redundancy and make the code more maintainable. And second is reusability. The extend function can be reused across the project wherever inheritance is needed, promoting consistency and reducing the chance of errors. This approach not only streamlines the inheritance process, but also makes the codebase more organized and easier to manage. By using a generalized method for extending prototypes, you ensure that all derived classes correctly inherit from their parent class without manually setting the prototype and constructor each time. What are the benefits of using a generalized extend function to set up prototypical inheritance in JavaScript? Explain how it improves encapsulation and reusability in your code. Using a generalized extend function to set up prototypical inheritance in JavaScript has several benefits, one being encapsulation. The extend function wraps the inheritance logic in one place, so you don't have to repeat the same code for every new child constructor. This makes your code cleaner and easier to maintain. And the second benefit is reusability. Once you have the extend function, you can use it whenever you need to set up inheritance, saving time and reducing the chances of mistakes. This ensures consistency across your codebase. Overall, it makes your code more organized and easier to manage. To demonstrate method overriding, we'll redefine the code method in front-end programmer to include additional behavior specific to front-end programming. So currently, we have this derived object, the front-end programmer, which inherits the properties and methods from the base programmer object. So when we call or invoke the code method, it simply calls the function derived in its parent. But we can override this functionality. So here, before I instantiate it, I will scroll up. So I'll resize this. Then before instantiating it, so I can say frontend programmer.prototype.code and assign this to an anonymous function. So I'll say programmer, so that constructor function for the parent.prototype.code.call, and then I'll pass this keyword. So this calls the base implementation defined up here. Now I can say log, and I'll do backticks. This dot name is coding in HTML, CSS, and JavaScript. So now I will save this, and we're invoking the code method on a front-end programmer. We can save it. Let's restart the live server. So Command Shift and P, live server open. Let's resize this. All right, I'll close this one out. Open up the developer tools, so Command Shift and J. So now I close the sidebar with Command V or Control V, and I get the expected output. I get Steven starts coding, which is the output defined in the programmer implementation of the code method. And in this derived object, where we did method overriding, I also log out. Steven is coding in HTML, CSS, and JavaScript. So an explanation of method overriding. This setup showcases how a prototypical inheritance works in JavaScript. When you call the code method on an instance of front-end programmer, JavaScript first checks the front-end programmer prototype for this method. Since we've overwritten code in front-end programmer, this version is executed, which also calls the base class method to maintain the general programming behavior, then add specific behavior. So if I were to comment this out, it would simply override it and simply log out what we define here. Right, so just this expected output. So some key points. The first is method lookup. JavaScript's prototype chain means that method lookup starts with the object itself and moves up the chain until it finds the method or reaches the top of the chain. And second, using the call method for base methods. To include the base class methods functionality when overriding methods, use call to specify the context, passing in this keyword, and ensure the base method executes correctly for the derived class instance. By following these principles, you can effectively manage and extend behaviors in JavaScript, allowing for more flexible and reusable code structures. How do you override the code method in front-end programmer to include additional behavior while still calling the base class method? To override the code method in front-end programmer and include additional behavior while still calling the base class method, you could do the following. First, you would define the new code method on front-end programmer.prototype. Inside this method, you call the base code method using programmer.prototype.code.call and passing in this keyword, and this will keep the original behavior. And then you would add the new behavior specific to front-end programmer. This way, when code is called on a front-end programmer instance, it will first run the base code method and then add the new behavior. What is the significance of using call when invoking the base class method in an overridden method in JavaScript? Using call when invoking the base class method in an overridden method is important because it ensures the base method runs in the correct context. By using call, you pass the current object, which would be this keyword, to the base method, so it behaves as if it was called directly on that object. This allows the base method to properly access and modify the object's properties. Polymorphism is a key concept in object-oriented programming. So polymorphism stands for many forms, and it is what allows objects of different classes to be treated as objects of a common superclass through inheritance. It's essentially the ability for different objects to respond to the same method call in different ways. First, let's look over this starting code that we're using. We have the extend method, which is a utility function that we are using so that a child object can inherit methods from parent object and make sure that we are resetting the constructor. We have a base object for our programmer, which just sets a name property, and we define a method named work, who simply logs out a string. Then we have two derived objects, front-end programmer and back-end programmer. So both of them inherit the name property from this base programmer object. And we are calling the extend method. So we are inheriting the work method. So now we have this boilerplate code. Let me resize there. So implementing polymorphism. We have our specialized programmer types, which is front-end programmer and back-end programmer. We want each of them to have a unique implementation of the work method. Before instantiating an instance of front-end programmer, we could do front-end programmer.prototype.work and assign this to an anonymous function. So we are overriding this method. We could do log, and we'll do backtick, is designing and coding the front end. We have implemented that method overriding implementation. Now we can do backend programmer.prototype.work, assign this to an anonymous function, and we will log it out. Backticks, we can say this.name is developing server-side logic. All right, let's create a backend programmer. So I'll scroll up and I'll do Shift Option and down arrow. And I'll just name this to be Alice, and backend programmer. So we've instantiated two instances. So one for the front-end programmer and one for the backend programmer. So using polymorphism. So let's create an array of programmer objects, which can be either a front-end programmer or backend programmer. So since we are utilizing inheritance, we know that a front-end programmer is a programmer and backend programmer is a programmer. Right, so the concept of is very important, such that our inheritance makes logical sense. So by creating this array, we'll say programmers. This will demonstrate how each object can use the work method differently, according to their specialized class definition. So create an array, and first I'll pass in Steven, so that front-end programmer, and Alice, the back-end programmer. So now let's iterate through this programmer's array. I can do that with a for-of loop. So I'll say for let programmer of programmers, and then we'll call programmer.work. And so now I will call its unique implementation of the work method. So the front-end programmer will call this method, and the back-end programmer will call its own implementation of the work method. So now let's save this and we'll see the output in the console. So now on the right, we see Steven is designing and coding the front end, and for the back-end programmer, Alice is developing server-side logic. So some key points. The first is no type checking is needed. So with polymorphism, you don't need to check the type of each object before calling the work method. Each object knows its own implementation of the work method, allowing them to behave correctly according to their specific type. And the second is code flexibility and reusability. Polymorphism simplifies code management and enhances its reusability by allowing you to use a general interface for a range of different objects. This example demonstrates how polymorphism can be leveraged in JavaScript to interact with objects from different classes through a common interface, enabling flexible and easily manageable code. This approach is particularly useful in systems where new types might be added, but existing code shouldn't need extensive changes to accommodate them. How does polymorphism allow different objects to respond to the same method call in different ways? Polymorphism allows different objects to respond to the same method call in different ways by using method overloading. Each object, even if they are of different classes, can have its own version of a method. So when a method is called, the correct version for that specific object is executed. What are the benefits of using polymorphism in terms of code flexibility and reusability, as demonstrated by the programmer example? Polymorphism increases code flexibility and reusability by allowing objects of different types to be treated through a common interface. In the programmer example, it means that you can call the same method, in this case it is the work method, on any programmer object without worrying about its specific type, making the code simpler and easier to extend with new types of programmers. understanding inheritance in composition with the programmer function. While inheritance is a powerful feature in object-oriented programming, it's important to use it carefully to avoid creating overly complex and fragile systems. So, potential issues with inheritance. Inheritance should always satisfy the is-a relationship, meaning that a subclass should represent a more specific version of the superclass. For instance, a front-end programmer, which is the subclass or derived class, is a specific type of programmer, with programmer being the superclass or base class. However, problems can arise if the subclass inherits methods that do not logically apply to it, leading to an inappropriate relationship. Example of inheritance complexity. So consider a scenario where you are expanding the programmer function to include different types of technical staff in a company. So I can resize this. I implement a base object. So this will be an employee object, which has a name parameter, this.name, and we'll set the name value. Now we can create a more specific version of an employee. So this subclass will be programmer. So it takes in a name, and we call employee.call. Then the this context for the first argument, referring to this programmer object, and the name. So this now inherits the name property. If we can create another subclass or derived object, and this would be a manager. So this will also inherit from the employee base object. So a programmer is an employee and a manager is an employee. So it satisfies the is-a relationship. So I can call employee.call, this, and the name. So manager inherits from employee. Now if the employee had programming methods, those methods will not logically apply to a manager object. So this example shows that the inheritance hierarchy can become inappropriate and bothersome, as you don't want to inherit methods that don't make logical sense. So this would happen in the case if this.employee had a method like code, and then we'll log out, write code. So it wouldn't make logical sense for a manager to have that functionality. We'll clear that. So as a best practice, you want to limit the inheritance depth. In general, it's best to keep inheritance hierarchies shallow, ideally not going beyond one level. Deep inheritance trees can become difficult to manage and understand, favoring composition over inheritance. An alternative to inheritance is composition, where you build classes out of components rather than using a strict parent-child relationship. This approach often provides greater flexibility and reduces dependencies between classes. When you think of the term composition, imagine it as a has-a relationship, whereas inheritance represents an is-a relationship. With composition, an object includes instances of other objects and their functionality, allowing it to have the behavior it needs without relying on hierarchical structure. Implementing composition with mixins. In JavaScript, composition can be achieved using mixins, where functionality can be mixed into a class. For example, instead of having a programmer inherit all behaviors, specific functionalities like can code, can review, can design might be mixed in as needed. So, const can code, which would be a JavaScript object literal, and within it, we can have a method for coding. So I'll say log, and I'll say this.name is coding. I can define another object, say can review, and it will define a review method, so log, and I can say this.name is reviewing code. So now, let's actually move this up. So I move it up with Shift and the up arrow. So I'll just reorder that. So we have these objects defined before the implementation of our programmer constructor function. So let's create an instance of a programmer. So I'll say const Steven equals new programmer. Just pass in my name. So now, for this programmer constructor function, to utilize the code method and review method, we can do object.assign this as the first argument, and we'll pass in can code and can review. So I can add a comment here. Scroll up and I'll say composing the object with necessary functionalities. So now let's create an instance of programmer. So I can say const Steven equals new programmer. I'll pass in my name. So then I can do Steven.code and Steven.review. I can save that, and I get the expected output. So in summary, in software design, while inheritance might seem like a straightforward way to reuse code, it's essential to evaluate whether it introduces unnecessary complexity. Often composition provides a more flexible and robust alternative, allowing objects to be constructed from discrete, reusable behaviors. This approach aligns with the principle of favoring composition over inheritance, helping to maintain clean and manageable code bases. What is composition? Composition is a design principle where an object is made up of one or more other objects, allowing it to use their functionality. It represents a has-a relationship, meaning that an object contains and uses other objects rather than inheriting from a parent class. What are potential issues with inheritance, and why is it important to ensure that a subclass satisfies the is-a relationship with its superclass? Potential issues with inheritance include creating complex and fragile systems if subclasses inherit methods that don't logically apply to them. It's important to ensure that a subclass satisfies the is-a relationship with its superclass to maintain logical consistency. For example, a front-end programmer should be a specific type of programmer. How does composition offer a more flexible alternative to inheritance in software design, and how can it be implemented in JavaScript using Mixins? Composition offers more flexibility than inheritance by allowing objects to include and use functionality from other objects, avoiding complex hierarchies. In JavaScript, it could be implemented using Mixins, where specific functionalities are added to an object as needed. This way you can add functionality without relying on inheritance. What is a Mixin? A Mixin is a reusable piece of code that adds specific functionality to objects or classes. In JavaScript, Mixins are used to share behavior across multiple objects by copying properties and methods into them. In JavaScript, object.assign is a powerful method used to copy properties from source objects to a target object. This capability is particularly useful for implementing Mixins, where common functionalities can be shared across different objects without forming a rigid inheritance structure. Here's how you can apply this to a programmer function, allowing programmers to have modular capabilities like eating, walking, and coding. So defining Mixin objects. First, let's define simple objects that contain methods which can be mixed into any target object. So we can implement a canEat method, and within it has an eat method. Set this to an anonymous function. So I can say this.hunger is decreased, and I can log, use backticks, this.name is eating. So end that with a semicolon. Now I'll implement two other objects. So the next will be canWalk. Then we'll have a walk method. So I'll say a function, and we will log it out. I'll say this.name is walking. We'll end that with a semicolon. And then we have can code. So we can have a method coding, and we will log out this.name is coding. We end that with a semicolon. And I'll just add a period here just to be consistent with the other strings that we're outputting. So using object.assign to mix capabilities. You can use object.assign to add these capabilities to a programmer. So if I scroll up, I'll define a constructor function for a programmer. This takes in a name parameter variable. So we set the name, and we'll set a property for the hunger So this will be the default hunger level. So now we have the mix-in functionalities into the programmer's prototype. So you do object.assign programmer.prototype. So this would be the target, and the source objects that we want to copy will be can eat, can walk, and can code. So now we can instantiate a programmer. So I'll say const programmer, and then new programmer, passing in my name. And I can call each of these methods. So first, let's just log this out. I can log programmer. Let's resize this so we can see it in the console, and I'll save it. So here when we expand, we see the property for hunger and the name. Right, so our expected properties. So now let's call programmer.eat, and then I'll do shift option down arrow just to make copies of this. And then I'll say walk, and then I'll say code. Save that. And here I get the expected outputs. So Steven's eating, Steven is walking, and Steven is coding. So to create a reusable mixin function, to streamline the process of mixing capabilities into different objects, you can create a reusable mixin function. So let's define that just at the top. So I can say function, and I'll name it mixin. Now for the parameters, we'll specify a target object, and we will use the rest operator with 3 dots, sources. So we can pass in one or more values as an argument. So we'll utilize object.assign the target, and then we will spread the sources. Right, so now when we use this, rather than doing object.assign, let's expand this so we can see it better. So now I can comment this out, and we utilize our mixin function. So here, I can say mixin. So the target is programmer, and we can pass in a variable number of arguments. So I'll say can eat, can walk, and can code. So let's resize this. And when I save it, I get the same expected output. So this approach demonstrates the flexibility of composition over inheritance. By composing objects from smaller, function-focused objects, you can easily extend functionality without the constraints of a strict class hierarchy. This method not only makes your code more reusable, but also makes it modular and easier to understand. Using mixins with object.assign allows for dynamic capabilities to be added to objects, promoting code reuse, and reducing the complexity typically associated with deep inheritance hierarchies. This method aligns well with the modern JavaScript best practice of favoring composition over inheritance, providing greater flexibility and easier maintenance. How does using object.assign facilitate the implementation of mixins in JavaScript, and what are the benefits of this approach compared to traditional inheritance? Using object.assign in JavaScript makes it easy to implement mixins by copying properties from multiple source objects to a target object, adding new capabilities without using inheritance. This approach offers greater flexibility, avoids complex inheritance hierarchies, and promotes code reuse by allowing you to combine only the needed functionalities. This section delved into several advanced topics essential for mastering object-oriented programming in JavaScript. We covered creating your own prototypical inheritance, so we explored how to establish custom inheritance chains using JavaScript's prototype-based inheritance system. We covered resetting the constructor. The importance of properly resetting the constructor property when modifying an object's prototype was emphasized to maintain proper linkages. We covered calling the superconstructor, so techniques for invoking a superclass constructor within a subclass were discussed to ensure that inherited properties were correctly initialized. We covered intermediate function inheritance. We examined how to implement inheritance through intermediary functions, enhancing flexibility in how inheritance is applied. We covered method overriding. The course covered strategies for overriding methods in subclasses to tailor or enhance functionality derived from a superclass. We covered polymorphism, we discussed how polymorphism allows objects of different classes to be treated as objects of a common superclass, facilitating flexible and dynamic code. We covered when to use inheritance. Guidelines were provided on appropriate scenarios for using inheritance, focusing on maintaining a clear is-a relationship. And we covered Mixins. The use of Mixins was introduced as a flexible alternative to inheritance for composing objects with multiple behaviors or capabilities without forming rigid, hierarchical structures. By understanding and applying these advanced concepts, you can write more robust, maintainable, and scalable JavaScript applications. This knowledge will enable you to leverage the full power of object-oriented programming in JavaScript, adapting to various programming challenges with effective solutions. So let's go over modern JavaScript classes, which is syntactic sugar over prototypical inheritance. In modern JavaScript, the class syntax provides a cleaner and more intuitive way to define constructor functions and manage prototypical inheritance. This new syntax simplifies the creation of objects and their prototypes, even though it is essentially syntactic sugar over the existing prototypical inheritance model. This syntax, introduced in ES6, which stands for ECMAScript 2015, is part of a specification that enhances JavaScript by adding new language features to modernize it. So consider the traditional constructor function for a programmer that we've been working with. So if I use the function keyword and I name it programmer, I specify two parameters, name and preferred language. Then I set the properties with the this keyword. So this.name is assigned to name, and this.preferred language is assigned to preferred language. Now to create a method, I'll use the this keyword, and I'll name my method code, assigning this to an anonymous function. So let's log to the console, backticks, this.name is coding in this.preferred language. So now I can create an instance of this with the new keyword to create a new object in memory. So I'll say const programmer is assigned to new programmer. I'll pass in my name, Steven, and the preferred language is JavaScript. So now I can call programmer.code, and we can output that to the console. And here we see our expected console log statement. So let's rewrite this constructor function using modern class syntax, which makes it clearer and more structured. So we can comment this out. So this is the syntax that you would use in modern JavaScript applications. You would use the keyword class, and then you name that class. So in this case, it's programmer. And now you would define a constructor function. So classes in JavaScript have one constructor function, and this is the function that is called when you use the new keyword. So it is named constructor, right? So that's the keyword. And in this case, the parameters are name and preferred language. And within it, we set our properties. So this.name is set to name, and this.preferred language is set to preferred language. So now to define our method, we'll name it code, and we will log the same output statement. So let me just copy it here, just to save us some time. So this is the modern way to define our classes in JavaScript rather than using constructor functions. And when we save it, we will get the same output. Right, so once again, we get Steven is coding in JavaScript. So understanding the underlying functionality. Despite the use of the class keyword, the underlying mechanism remains the same. So consider the type of operator. Even with the class syntax, programmer is still a function in terms of JavaScript's type system. It's specifically a constructor function. So let's log that out so I can demonstrate that. And then I do log, and then tab. If I do type of, and then programmer, we will see that the type is a function. So when we save this, we see that it is a function. ES5 compatibility. For environments that do not support ES6 classes, tools like Babel, available at babeljs.io, can transpile this modern JavaScript back to ES5 compatible code, ensuring that the classes work across all browsers. So consider the benefits of using class syntax. The first benefit is clarity and simplicity. The class syntax is easier to read and understand, especially for developers coming from other object-oriented languages like Java or C#. The second benefit is encapsulation. Using class syntax encourages better encapsulation and a more declarative structure for defining object constructors and methods. And the third benefit is standardization. It offers a standardized way of object creation and inheritance that aligns with other programming languages, easing the learning curve. So in summary, by utilizing modern JavaScript class syntax, you could write cleaner, more maintainable code while still leveraging the powerful prototypical inheritance model that JavaScript offers. This approach not only enhances readability, but also simplifies complex coding structures, making it an essential skill for developers working in modern JavaScript environments. How does the class syntax in modern JavaScript improve the process of defining constructor functions and managing prototypical inheritance? The class syntax in modern JavaScript makes it easier and clearer to create objects and their prototypes. It provides a straightforward way to define constructor functions and methods, making the code more readable and organized compared to the older method. Even though it looks different, it still works the same under the hood. What are the benefits of using class syntax over traditional constructor functions in JavaScript? There are three main benefits of using class syntax over traditional constructor functions in JavaScript. The first being clarity. The class syntax is easier to read and understand. The second benefit is encapsulation. It helps organize code better by keeping related methods together. And the third benefit is standardization. It aligns with how other programming languages handle classes, making it easier to learn and use. So for your exercise, update this function constructor to use the ES6 class syntax. So here, I'll call item.display, and I get the output of the name of the item and the quantity. So to implement this, I'll comment this out. So now I'll do class, and I'll name the class grocery item, then curly braces, and then I'll define the constructor function, which will be executed when I use the new keyword. So the parameter is the name and the quantity. And I just assign this with the this keyword to set the properties and for the quantity. Now I'll define a method. So I'll say display, and I'll just copy this console log statement and paste it here. So let's clear our console, and I'll save it, and we get our expected output. In JavaScript, functions can be defined using either function declarations or function expressions. Both methods serve similar purposes but have key differences in behavior, particularly regarding how they are hoisted. So let's consider function declarations. Function declarations are hoisted to the top of their containing scope. This means that they are moved to the top during the compile phase, allowing you to call them before they are physically defined in the code. So to demonstrate this, I'll implement a function, I'll name it greet, and then I will log out, hello world. Now, to demonstrate function hoisting, I can call or invoke the greet method before it is defined. So if I save this, I get the expected output. So because of hoisting, JavaScript will move this function to the top of the file during the compile phase. So now considering function expressions, in contrast, function expressions are not hoisted, which means you cannot call them before they are defined in the code. Trying to do so will result in a reference error. So to demonstrate this, I'll just comment this out since we don't need it. I can say const say goodbye, set this to an anonymous function, and then we will log out goodbye. So now if I try to invoke it before it is defined, let's clear this out, and I save it. Here we see we get a reference error. So we can comment this out. So now let's apply this concept to the programmer class context. So you scroll up. Now let's consider this class that we defined in our previous lesson. When working with classes, it's crucial to understand that, like function expressions, class declarations are not hoisted. This means you must declare a class before you can instantiate it. So let me move above it just to demonstrate that we cannot instantiate it before it's being defined. I can say const dev is assigned to a new programmer. I'll say my name and the preferred language of JavaScript. And I'll just save that. And here we see we get a reference error. We cannot access programmer before it's initialized. So using class expressions. Just as with function expressions, classes can also be defined using a class expression syntax, which is not hoisted and allows for more dynamic declarations. So to demonstrate that, I'll just define this here. I can say const my programmer class, set this to the keyword of class, and then curly braces. And then I want it to have the same functionality as this programmer, so I'll just copy this over. Let's comment out this line, so we don't need that. So we've created this class expression, and let's create an instance of it below its declaration. So I can say const programmer and new my programmer class, pass in Steven, and in this case I'll say JavaScript. And then we can call the method programmer.code. Let's clear this out, and we'll save it. And we get our expected output. So here we are creating an instance of it after its declaration. Now, if I were to move it up, so I'm moving it up with Option and up arrow, moving it up here. So now that I try to instantiate an instance of this before its declaration, if I save it now, then I get a reference error. Note that you wouldn't actually use this class expression syntax very often, but I wanted to demonstrate it just to show that it is possible. In conclusion, choosing between function declarations and expressions, or class declarations and expressions, can impact how you structure your JavaScript code. For simplicity and clarity, especially when defining constructors and methods within a class, using class declaration syntax is often preferred. However, being aware of hoisting rules is crucial for avoiding runtime errors and ensuring that your JavaScript code executes as intended. What is the main difference in behavior between function declarations and function expressions regarding hoisting in JavaScript? The main difference is that function declarations are hoisted to the top of their scope, so you can call them before they are defined in the code. Function expressions are not hoisted, so you must define them before calling them, otherwise you'll get a reference error. Why is it important to understand hoisting rules when working with class declarations in JavaScript? It's important to understand hoisting rules because class declarations are not hoisted. This means you must define a class before you use it, or you'll get an error. Knowing this helps you avoid mistakes and ensures your code runs correctly. In object-oriented programming, especially within JavaScript classes, we distinguish between instance methods, which act on instances of the class, and static methods, which are called on the class itself and are often used as utility functions. So let's consider the programmer class that we have defined. So whenever we create an instance of a programmer, it has access to the code method. So to demonstrate that, we have dev.code. When we save that, we get the expected output, which is this console log statement. So now let's define a static method, which would be accessible through the programmer class. So I'll use the static keyword, and then I'll name this method compare skill, and this will accept two parameters. So I'll say programmer1 and programmer2, and this will return a Boolean value comparing programmer1 and their preferred language, and strictly equal to programmer2 dot preferred language. So let's create another instance of this programmer. So I'll do Shift Option and down arrow to create a copy, and I'll name this dev2. I'll change the name to be Alice. Now to compare it, I will log the result of that Boolean value. So let me scroll up and see better, and I'll say log I'll do programmer, and then the static method, so I do dot compare skill. Now I'll pass in dev and dev2, and we'll expect this to be true because they're using the same programming language. So let's clear this first, and then save it. So we get the output of true because they both have JavaScript as their preferred language. So let's scroll back up so we can review our class. So instance methods, like code, are used to perform actions that are relevant to the individual objects created from the class. And static methods, such as compareSkill, are used for operations that are relevant to the class as a whole or involve multiple instances of the class, but don't depend on any single object state. So understanding the utility of static methods are particularly useful for utility functions, where the operation does not depend on the state of a particular instance, but rather on the parameters provided to the function. This makes them similar to functions provided by the math object in JavaScript, such as math.round or math.max, which perform general utility operations and are not tied to a specific object. In conclusion, understanding when to use instance methods versus static methods in your JavaScript classes can significantly impact the design and functionality of your applications. Instance methods are best for manipulating or utilizing the state of individual objects, while static methods are ideal for tasks that require a broader scope, ones that involve the class itself or interactions between multiple instances. This distinction helps in organizing code logically and maximizing the efficiency and readability of your JavaScript applications. What is the difference between instance methods and static methods in JavaScript classes? Instance methods are used on individual objects created from a class and act on the data within those objects. Static methods are used on the class itself and are typically utility functions that don't rely on the data of any single object. Why are static methods useful in JavaScript, and when should they be used instead of instance methods? Static methods are useful for tasks that don't depend on the data of a specific object, but rather on parameters provided to the method. They should be used for general utility functions or operations involving multiple instances of the class. So for your exercise, to add a static method to the grocery item class, you can define the method with the static keyword. So static methods are called on the class itself rather than on instances of the class. So for your exercise, create 2 instances of the grocery item class, and have each of these objects have different names and quantities. Then implement a static method named compareQuantities to compare the quantities of the 2 items and print out the result. So if the quantity of item number 1 is greater than item number 2, then log that the name of the first item has more quantity than the name of the second item. If the quantity of item 1 is less than item 2, then log that the name of item 2 has more quantity than the name of item 1. Otherwise output that both of them have the same quantity. So to implement the compareQuantities static method, I'll use the static keyword, and we name it compareQuantities. Then it takes in item 1 and item 2. Then I'll use an if statement. So if item 1 dot quantity is greater than the quantity of item 2, quantity, then I will log, use backticks so I can use interpolation, item 1 dot name has more quantity than item 2 dot name. Else if item 1 dot quantity is less than item 2 dot quantity, then I will log out item 2 dot name has more quantity than, let's fix this, move that y, then item 1 dot name. Else will be the case when they're equal, and log out item1.name and item2.name have the same quantity. So let's create two instances of the grocery item class. So I'll say const, I'll call this apple equals new grocery item, and then the name is apple, and the quantity is 4. So I'll just copy this line with Shift Option and down arrow, and I'll rename this to be banana. Let's just copy this over, and I'll update this value to be 7. So now I can call this static method with grocery item dot compare quantities of apple and banana. So let's save that. And here we get the expected output that banana has more quantity than apple. Let's switch these values around just so we get the expected result. We'll clear it out. And when we save it, we get apple has more quantity than banana. And in the case when they're equal, we get that apple and banana have the same quantity. Let's go over understanding the this keyword in different contexts with the programmer class. The this keyword in JavaScript behaves differently based on how a function is called. This behavior can lead to unexpected results, especially when functions are detached from their object context. So let's first illustrate this with a programmer constructor function. So we'll use the function keyword. We'll name it programmer. This accepts a parameter of name. So we'll set the name property. Then we'll implement a method named code. So we assign this to an anonymous function. Then log, and then tab. And we will log out the this keyword. So let's create an instance of this programmer object. So we'll name it programmer, assigned to a new programmer, and I'll specify my name, so Steven, and then I will call the code method. So now when I output this and save it, here I see it outputs this instance of the programmer, so that object in memory. So here we see the property of the name and the code method. So now let's consider detaching a method. When you detach a method from its object and call it independently, the this keyword loses its original context. In JavaScript, functions are objects, so we know that this method, or in other words, this function, is just an object in memory. So to get access to it, I can call it detach code method, and I set this to a reference to that object, right? So functions are objects. And so now this identifier, detach code, will reference this function. However, because it's detached, it has lost context of its this keyword. So now let's invoke this. So I can say detach code. And then let me clear this out so we can see it. And so when I save it, here I see in the original instance, when I call code, it logs out the programmer object. However, when I call detach code, it logs out the window object. So in web browsers, the this keyword will reference the window object. And in Node.js, it will reference the global object. So how can we fix this? We can utilize strict mode. So we go up here. In JavaScript, strict mode changes the behavior of the this keyword in function calls not associated with an object. So in strict mode, the this keyword becomes undefined instead of defaulting to the global object. So if I were to use strict as a string, ended with a semicolon, and I would specify this to be the first line in the program. So now let's clear this out. And when I save it, the first time when I call the code method and it console logs the this keyword, it references the current object that it's referring to. However, in the case when we call a detach method, previously it was referencing the window object, but now since we're in strict mode, it outputs undefined. So here we're using a constructor function. Now if we were to use classes, they implicitly use strict mode to avoid these issues. Instead of using a constructor function, I'll specify it to be a class. So I'll define the constructor method. This sets the name property, and I'll define a method for code, and it outputs the this keyword. So let's comment this out. so we don't need to explicitly specify use strict. Let's clear this out. And when we save it, so because we're using the class syntax, it is implicitly using strict mode. So let's cover the benefits of strict mode in class bodies. The first benefit is safety. It prevents functions from unintentionally modifying global variables, which can lead to difficult to track bugs. And the second benefit is consistency. It ensures that the this keyword behaves consistently, making the code more predictable and less prone to errors. In conclusion, understanding how the this keyword behaves in different contexts is crucial for JavaScript developers. By using strict mode and being cautious of how methods are called, developers can write more robust and secure code. The implicit use of strict mode within class bodies in modern JavaScript helps enforce these best practices, preventing common mistakes associated with the this keyword in global context. What are the potential consequences of detaching a method from its object context in JavaScript? Detaching a method from its object context in JavaScript can cause the this keyword to lose its original reference. Instead of pointing to the object it belongs to, the this keyword may point to the global object, like window in browsers, or be undefined in strict mode. This can lead to unexpected behavior and bugs because the method no longer has access to the object's properties or methods. How does strict mode in JavaScript enhance code safety and consistency, particularly in the context of class bodies? Strict mode in JavaScript makes code safer and more consistent by changing how certain things work. In class bodies, it ensures that the this keyword is not accidentally pointing to the global object. Instead, if the this keyword is not set, it will be undefined, which helps prevent bugs. Strict mode also stops you from making some common mistakes, like creating global variables by accident, making the code easier to understand and less prone to errors. So understanding abstraction with the programmer class. Abstraction in programming involves hiding complex implementation details and exposing only the necessary parts of an object. This is commonly achieved through private properties and methods. Let's apply the concept of abstraction to a programmer class where certain details like the programming language proficiency level might be internal to the programmer's operations. Let's consider the first approach where we achieve private properties through the naming convention. So one approach is to use an underscore prefix to indicate a private property. So if we create a programmer class, and we have the constructor, taking a name and language, then we can do this dot underscore language, assigned to language. I'll just add a comment here. It's not truly private, just a naming convention. So now, if we were to instantiate it, const programmer, new programmer, passing in Steven and the language of JavaScript. Here, if I log out, we do programmer.underscore language. So here it outputs JavaScript. So we still have public access, but the use of the underscore indicates to the programmer that this is supposed to be a private property. Now, there are issues with this. An issue is that this method relies on the naming convention and does not provide true privacy. Properties are still accessible from outside the class. So let's consider a second approach, which uses ES6 symbols. A more secure way to implement private properties is using ES6 symbols, which provides a way to create unique identifiers. So before I create my class, I will say underscore language and set it to a symbol value, which is a unique identifier, a unique value. So rather than setting it through dot notation, underscore language, I'll use the square bracket notation and I'll pass in the symbol as a key. Just to demonstrate this, this is more private, but still accessible through reflection. So here, if we try to access underscore language, that's not a property defined in it. So we can actually access this, but it is not straightforward. But to demonstrate how you could, I will log out object.getOwnProperty symbols. I'll pass in the identifier for our object. Let's save that. So here we see an array of symbols. So using this, if I want to get the value at the 0th index, I could do so. So if I want to access that value at the 0th index, I can say const language symbol is assigned to, and let's just copy this value over, and the 0th index. So I can use this as the key in order to get the language. I do log, programmer, and then square bracket notation, the language symbol, and it outputs the value of JavaScript. So here we see that this property is still accessible through the outside, although it is not intuitive. So some observations. Symbols provide a pseudo-private mechanism as they are not accessible through normal property access methods. However, symbols can still be accessed through object.getOwnProperty symbols, so it's not completely private. So let's consider private methods using symbols. Similarly, you can use symbols to create methods that are not accessible directly via the class instance. So let's say if I were to define a symbol, I'll say underscore code, and set that to a new symbol, so a unique value. Now, I can create a private method, so I'll use square bracket notation, then the symbol as the name of that method, and then let's log, I'll say this.name is coding in, and I'll say this underscore language. And that with a period and a semicolon. So in conclusion, while symbols enhance privacy, they do not provide a foolproof solution for private properties or methods. For truly private class fields, ES 2022 introduces private class fields and methods using the hash symbol, or the hash prefix. So this is also called the pound symbol or octothorpe symbol, but I'll refer to it as the hash symbol. And this is the best approach going forward for ensuring data encapsulation and adhering to the principles of abstraction and object-oriented programming. So let me clear all this so we can start from scratch. I'll clear this out. Now we can say class programmer. Now I'll create a private property. We'll name it language. And here we see it is prefixed with the hash symbol. Now let's define our constructor, which takes in a name and a language. And we do this dot hash language is assigned to the language. And let's set the name to this dot name, this like the name. Now we can define a truly private method. We could do so with hash and then code. So we can just log coding in this hash language. So now let's create an instance of this class. So we're creating a new object in memory, programmer, passing in my name and the language. Let's log this programmer object. And when we output it, we can expand it and we see the name and the language. Now if we try to access the property of language, let's try doing that here. Programmer dot, if I do hash and then language, here we see the private field hash language must be declared an enclosing class. So in other words, it is not accessible. If we try to access it by language, we get the value of undefined. So this method ensures that the language property and code method are completely private, encapsulated within the programmer class, and not accessible from outside. This approach aligns closely with the principle of abstraction, keeping implementation details hidden and interfaces clean and straightforward. What are the benefits and limitations of using symbols for creating private properties in JavaScript classes? Using symbols for private properties in JavaScript classes has benefits and limitations. Now the benefits are improved privacy. Symbols make properties less accessible through normal methods, adding a layer of privacy. Another benefit is unique identifiers. Symbols create unique property keys, reducing the risk of naming collisions. Now the limitations. The first limitation is that it is not fully private. Properties created with symbols can still be accessed using methods like object.getOwnProperty symbols. Another limitation is complexity. Using symbols can make the code harder to read and understand, as accessing these properties isn't straightforward. How do private class fields introduced in ES 2022 improve data encapsulation compared to previous approaches? Private class fields introduced in ES 2022 improve data encapsulation by providing true privacy for properties and methods. Using the hash prefix, these private fields are completely hidden from outside access, ensuring they can only be used within the class. This prevents accidental or unauthorized access, making the code more secure and easier to maintain compared to previous approaches like naming conventions or symbols, which didn't fully hide the data. So your exercise is to implement private properties and methods with ES 2022 in a grocery list application. In this exercise, you will create a grocery list class and a grocery item class to manage a grocery list application. The goal is to understand and apply the concept of abstraction by using ES 2022 private properties and methods. This will help you hide the implementation details and expose only the necessary parts of these classes. So let's do a quick overview of the instructions for this exercise. The first is to create the grocery item class. This class should have private properties for the item's name and quantity. It should include a constructor to initialize these properties and implement a method to display the item details. This method should be public and provide a formatted string of the item's details. Second, create the grocery list class. This class should have a private property for the list of grocery items, include methods to add an item to the list, remove an item from the list by name, and display all items in the list, and ensure that the internal list of items is not directly accessible from outside the class. Now, the third instruction is using ES 2022 private properties and methods. Use the hash prefix to define private properties and methods in both classes. Ensure that no implementation details are exposed outside the class. So the example code, here is the starting point for the grocery item and grocery list classes. So we will create a grocery item class. So we'll have a constructor which takes in the name and the quantity. Now it will have a public method to display item details. So I'll name this display item. Now let's create our grocery list class. And I'll scroll up so we can see it better. So this will have a constructor. It will have a public method to add an item to the list. So we will name that add item. And that takes in name and quantity. We will have a public method to remove an item from the list by name. To name that remove item, pass in the name as the parameter, and a public method to display all items in the list. To name that display list. So this is our starting point code. So now the task checklist. First, define the grocery item class. Create private properties, name and quantity, implement the constructor to initialize these properties, and implement the display item method to return a formatted string of the item's details. Task number 2. Define the grocery list class. Create a private property, items, to hold the list of grocery item objects. Implement the add item method to add a new grocery item to the list. Implement the remove item method to remove an item by name. Implement the display list method to display all items in the list. The third task is to test the classes. Create an instance of grocery lists, add multiple items to the list, display the list to ensure items are added correctly, remove an item and display the list again to ensure the item is removed correctly. By completing this exercise, you will gain hands-on experience with ES 2022 private properties and methods, enhancing your understanding of abstraction and encapsulation in JavaScript. So now for our grocery item, let's declare our private properties, which is name and quantity. Now we will set these private properties. So this hash name is set to name, and this quantity is assigned to quantity. Now to display the items, we can log. And actually, I'll have it return the value rather than log. So I will use backticks. I can say item, this, and then hash name, and then quantity, this, quantity. So we've implemented that class. Let's expand this so you can see a bit better. Let's scroll. Now we want to create a private property for our list of grocery items. So we'll name that items. And within the constructor is where we will initialize this array. So this items assigned to an empty array. And I'll scroll up. So for adding an item, I will create a new grocery item object. So item, new grocery item, passing in the name and the quantity. So now I will push to the end of the array. So items.push, adding that new item. So now for the remove method, say this items is assigned to this.items. We use the filter method. We pass in a callback function. This is a predicate. So the item dot display item. So that output here, which includes the name and the quantity. So if that includes, I'll use backtick, item, and then the name, then in that case, it would be filtered out in the case when it is not included. And now to display everything, I can say return this items.map, and pass in our callback item.display item. And I can say .join, and we'll specify a new line. So all the items will be displayed on their own line. So now, let's resize this so we can see our console. So now we want to create a new instance of the grocery list. New grocery list. Grocery list. Let's add some items. So .add item. So I'll say apples, the quantity of 5. And I'll do shift option down arrow. So just to add bananas. And we'll specify the quantity to be 3. Then we can call log grocery list dot display list. Let's save that. So here we see the expected output. So it's calling the display item method for each of them. So now let's remove an item. So I can say grocery list dot remove item. So remove apples. And then let's copy this and we will call it again. So now let's say if I clear it and we run it again, we see for the first output is apples and bananas. And after we call the remove method, it successfully just displays what is left in our grocery list, which is bananas. WeakMap provides a way to securely store private data for an object without preventing garbage collection when the object itself is no longer in use. Here's how you can use WeakMap to implement private properties and methods within the programmer class. So let's define underscore language and instantiate a new WeakMap and const underscore work new WeakMap. So this data type allows us to store key value pairs. So now we will create a programmer class. The constructor will take in a name and a language. So now we can set the name to be a public property, but in this case we want the language to be private. I'll just add a comment here to better describe what we're doing. So store language in a WeakMap with this as the key. So I can set underscore language dot set. So here we are set in the WeakMap. So for the first argument, we specify the object. So in this case, it would be the this keyword, which refers to this current programmer object. And we will specify the value being language, right? So the value that we pass in to the constructor. So now let's store a private method in a WeakMap. So underscore work, right? This WeakMap that we created up here, we will set the this keyword referring to this current object. And for the value, we will specify a callback function. So within it, we will log, use backticks, this .name is coding in, we'll do the WeakMap, which is named _language, .get, and the this keyword as its key. So now we can save that. So now let's implement a method named code. So this is a public method, and this will call the private method that we have stored in the WeakMap. So I'll add a comment, access, and invoke the private method. So _work, which is the name of that WeakMap, call the get method, and we pass in the this keyword, so this current object, which is the key, and now we need to call or invoke this method. So open and closing parentheses to call that method. So now let's create an instance of this programmer class. So I'll say const programmer, new programmer, with my name as Steven and the language of JavaScript. And let's call that public method code. And we save that, we see Steven is coding in JavaScript. So we call the code method, and this called the method defined in our WeakMap, which is a private method. So let's go over a discussion of the WeakMap data structure and the benefits and usage. So first is garbage collection. A major benefit of using WeakMap is its handling of keys. If there are no other references to a key object, in this case, an instance of programmer, it can be garbage collected. This helps prevent memory leaks in applications where objects are dynamically created and destroyed. The second benefit is encapsulation. Using WeakMap for storing private data ensures that these details are not accessible from outside the class. This is much more secure than using properties prefixed with an underscore, as these are only conventionally private. Third is arrow functions and the this keyword. Arrow functions do not have their own this keyword context. Instead, they inherit the this keyword from the enclosing execution context. Within _work, this refers to the programmer instance, allowing access to the instance's name and other properties securely stored in the WeakMap. So let's consider an alternative with a single WeakMap. You can also group all private properties into a single WeakMap entry per object, though this might make the code slightly more verbose. To show you an example of that, let's comment out this implementation. We will create a new one. So I'll say const private props new WeakMap. So now we will create a new implementation of programmer. So the constructor takes in the name and the language. Let's remove that underscore. So our curly braces. Now we will say private props. Move this up. Dot set. So for the key, it is this current object, so that this keyword. And for the value, we will specify a JavaScript object. So here we will store key value pairs. So we'll specify the name, the language. So now let's specify the work method. So we'll specify a callback. So we will log backticks private props .get the this keyword and the property of the name is coding in private props .get the this keyword .language. So now we'll implement our public method code, and this will call private props .get the this keyword and calling the work method. So now when we output it, we get the same expected result. So in conclusion, using WeakMap for managing private data in JavaScript classes provides a robust way to ensure encapsulation and data security. This approach is particularly useful in scenarios where data privacy is crucial and helps maintain clean API boundaries within your classes. How does using WeakMap for private properties and methods enhance data encapsulation and security in JavaScript classes? Using WeakMap for private properties and methods enhances data encapsulation and security by ensuring that private data is not directly accessible from outside the class. This keeps the implementation details hidden, providing a secure way to manage private data within objects. What are the benefits of using WeakMap in terms of garbage collection, And how does this prevent memory leaks in JavaScript applications? WeakMap allows objects to be garbage collected when there are no other references to them, even if they have private data stored in the WeakMap. This helps prevent memory leaks by ensuring that memory used by objects no longer in use is freed up automatically. What distinguishes WeakMap from the ES 2022 hash syntax for private properties and methods, and why might you choose to use WeakMap? WeakMap allows you to store private data for objects without preventing their garbage collection when they're no longer in use, making it useful for managing memory efficiently. The ES 2022 hash syntax provides built-in support for private properties and methods, making them truly private and not accessible from outside the class. You might use WeakMap if you need private data that can be automatically cleaned up by garbage collection to prevent memory leaks. So we'll start by demonstrating how to store a private property in a programmer class using a WeakMap, and then show how to define property accessors. So let's set language to a new WeakMap, and we'll define a programmer class. So once again, we have our constructor setting the name and the language. Let's remove that underscore. We'll set the name and the language with the WeakMap, so this operator, or this keyword rather, for the current object, and the language. So this property is public, and this is private. Now we'll define a method named getLanguage in order to access this private property with a private value, which is the language. So we will return language.get and then this keyword. So we'll create a new programmer. So const programmer is assigned to new programmer, Steven, and the language of JavaScript. So now let's call the getLanguage method. We need to call the console log. So log, and then programmer.getLanguage. Save that. And we get the value of JavaScript. So now using object.defineProperty to define a getter. For cases where you want the property to be accessible more like a property rather than a method, you can use object.defineProperty. So rather than calling the getLanguage method, we prefer to access it through a property named language. So here we can set object.defineProperty. So the first argument is this keyword, so this current object. Now we would name the property. So in this case, I'll name it to be language. And then we'll pass in an object. So use the get keyword, set this to an anonymous function, and here we return language.get and this. Right, so we don't need this method anymore. Now we can access it through dot notation through this property that we created. So rather than doing get language, you can access it with language, as that is the name of the property that we specified here. So now when we call it, let's clear it actually, and save it. We get the expected result, as this is calling this function defined here. Cleaner ES6 syntax for getters and setters. In ES6, getters and setters can be defined within the class body, providing a more concise and readable way to access properties. So let's delete here where we define the property, and let's define a getter. So we use the get keyword, and then space, and then the name of the property. So we'll name it language. And this returns, right? So we're using the WeakMap here, get, and then this keyword. So now let's define a setter. So we'll set the language. The parameter will be new language. Let's move this up. So if new language is falsy, in the case when it's an empty string, for example, then we'll throw an error saying language cannot be empty, and that with the semicolon. Otherwise, we will update the value stored in the WeakMap. So set, so the key is this keyword, so this current object, and we'll update the language. Right, so now we can access language as if it were a property. So here, let's clear this. When we save it, we get the expected result. So now let's update the language. So I can say programmer.language, and I'll set this to a new language such as Python. So let's scroll up. So let's log this out. Programmer.language. When I save it, here I see the value has been successfully updated to be Python. As when we set this value, so programmer.language is assigned to Python, we are calling this setter. Let's expand this, and I'll discuss it. So first, let's consider the WeakMap, which we define here. This provides a way to securely store private data associated with an instance. So object.define property. This method is useful when you need to create getters or setters that appear like properties but are backed by methods. It allows for fine-grained control over property characteristics. ES6 getters and setters. These provide syntactic sugar that makes accessing and modifying properties intuitive and similar to accessing traditional class properties. This method is particularly useful for validation, logging, or handling side effects during property access. In conclusion, these different approaches allow JavaScript developers to encapsulate and protect data within classes effectively, ensuring that implementation details are hidden and that public interfaces are clean and easy to use. Using these features appropriately can help maintain and scale large codebases, making your code more robust and easier to manage. How do ES6 getters and setters enhance the encapsulation and control of property access within classes? ES6 getters and setters enhance encapsulation and control by allowing you to define methods that get or set property values. This provides a way to add logic when accessing or modifying properties, such as validation or transformation, while keeping the syntax similar to regular property access. What are the benefits of using the get and set keywords in ES6 classes compared to traditional methods for accessing and modifying properties? Using get and set keywords in ES6 classes allows for more intuitive and cleaner syntax for accessing and modifying properties, similar to regular property access. They also enable adding custom logic, such as validation, when getting or setting a property, enhancing encapsulation and control. So let's cover inheriting and extending the programmer class. We'll start with a base programmer class that has a constructor for initializing a programmer with a name and a basic method for coding. So we'll specify our class, and our constructor accepts a name. Now we'll just set this name property. And we have a simple method for coding. So this will log out, do backticks, this.name, starts coding. So we've implemented our base class. So now let's create a derived class, which would be a front-end programmer. So we will extend this general base programmer class to create a front-end programmer class that includes additional properties and methods relevant to front-end programming. So implement that just below it. So it will be class front-end programmer. And we'll use the special keyword extends programmer. So the derived class will inherit from the base class when we use the extend keyword. And this is because the front-end programmer is a programmer. So this is how you would achieve inheritance using the ES6 class syntax. So we inherit the properties and the methods from the base class. So let's create our constructor function. This accepts the name, and we'll specify an additional parameter, which will be tools. So we can call super and then name. And so this keyword, super, this calls the superclass constructor with the name argument. So we'll call this constructor of the base class. So let me add a comment here just to better describe that. I'll say calls the superclass constructor with the name. Now we'll set the tools based on the argument passed in. So I'll add a comment to describe this as well. I'll say additional property specific to front-end programmers. So now we will specify its own code method. So we'll say super.code. So this calls the generic code method from the programmer base class. And now we'll add additional functionality. So I'll log out. We'll use backticks. I'll say this.name codes with, I'll say this.tools. We'll end it with a period and a semicolon. Let me extend this so we can see it better. So now we can add methods specific to a front-end programmer. So I'll say design. Let me scroll up so we can see. Now we'll log out. Backticks. This.name also designs the user interfaces. So here we see our derived class, front-end programmer, is a more specific version of the programmer base class and has additional functionality. So now let's use this derived class. We create an instance of the front-end programmer class, and we'll demonstrate the use of both inherited and specific methods. So I'll say const front-end dev assign to a new front-end programmer. I'll pass in my name, and I'll specify the React JavaScript library as the tool. So let's resize it so we can see the output. And I'll say front-end dev, and we call the code method. And we save it. So here we see Steven starts coding, and Steven codes with React. So that first log statement, Steven starts coding, is implemented in the general or the base programmer class. All right, that is because we called super.code. And then we see it outputs the log statement in the front-end programmer. So we resize it when it says Steven codes with React. So now let's call another method. I'll say front-end dev.design. Implement that. And here we see this log statement we specified here, which is Steven also designs the user interfaces. So let me expand this, and we can discuss it. So we covered inheritance. So the front-end programmer class inherits from the programmer base class, gaining access to its methods, while also being able to introduce new properties and methods or override existing ones, like how we did with this code method. We use the keyword for super, so the super keyword is essential for calling the constructor of the base class, so in this case the programmer class, from the derived class. It ensures that all the initialization logic in the superclass is properly executed before additional setup in the subclass. And we covered method overriding. The code method is overridden in front-end programmer to extend its functionality, but it also calls the superclass's code method to maintain the general coding behavior. In conclusion, this example clearly illustrates how to effectively use inheritance in JavaScript to create a hierarchy of classes, where derived classes extend and specialize the behavior of their base classes. This pattern is crucial for structuring complex applications in a way that promotes code reuse and logical organization. How is the super keyword used in the front-end programmer class? The super keyword in the front-end programmer class calls the constructor of the programmer base class, ensuring that the name property is initialized correctly before adding more properties or methods specific to front-end programmer. What are the benefits of using inheritance when extending the programmer class to create the front-end programmer class? Using inheritance to extend the programmer class allows the front-end programmer class to reuse existing code, add new properties and methods, and override existing ones, making the code more organized and easier to manage. Let's go over method overriding with ES6 classes. We will start with a base programmer class that has a generic work method, then we'll create a specialized front-end programmer class that extends programmer and overrides the work method to add specific behavior. So let's implement our base class. So that will be a programmer. We'll implement the constructor to accept a name parameter. So this.name is assigned to name. Now let's implement the generic work method. So we'll say log and tab backticks. This.name is solving problems. So this is our base class, which we will extend. So we'll implement class front-end programmer extends the programmer base class because the front-end programmer is a programmer. So this accepts a name, and we call the superclasses constructor. So comment initialize the base class part of the object, and we will override the work method. So we'll call super.work. So this calls the base class method. And now we will add our own specific functionality. So I'll say log, say this.name is also designing and implementing UI components. So now let's use our derived class. Say const, I'll say Steven equals new front-end programmer. So it accepts a name parameter. So I'll pass Steven as the argument. Now we'll say Steven.work, and we'll save it. And here we see our expected output. So it calls super.work. So it calls the base class's implementation of the work method. So we see Steven is solving problems. And then we will log out. Steven is also designing and implementing UI components. So let's expand this. So understanding the method lookup and the super keyword. So method lookup. When a method is called, the JavaScript engine first looks for it on the object itself. If it can't find the method, it walks up the prototype chain to find the method in the parent class. So in this case, front-end programmer, its prototype or its parent is the programmer base class. And we're able to achieve inheritance through the extends keyword. So using the super keyword. The super keyword is crucial in subclass methods to call corresponding methods defined in the superclass. This feature allows subclasses to enhance or modify the behavior of methods they inherit without completely rewriting them, thus promoting code reuse and reducing duplication. In conclusion, by overriding methods and using the super keyword effectively, you can ensure that subclasses not only tailor inherited methods to their specific needs, but also leverage and extend the functionality provided by their superclasses. This approach is beneficial for maintaining logical and maintainable code in object-oriented JavaScript applications, as it minimizes redundancy and ensures a clear and efficient inheritance structure. What is method overriding in ES6 JavaScript classes? Method overriding in ES6 JavaScript classes is when a subclass provides a specific implementation for a method that is already defined in its parent class, replacing the parent's method with its own version. How does method lookup work when calling a method on an object in JavaScript? When calling a method on an object in JavaScript, the engine first looks for the method on the object itself. If it's not found, it checks the object's prototype and continues up the prototype chain until it finds the method or reaches the end of the chain. What is the role of the super keyword in a subclass methods in JavaScript? The super keyword in subclass methods in JavaScript is used to call methods from the parent class, allowing the subclass to build on or modify the behavior of those methods. So let's summarize what we covered in this section. ES6 Classes. We explored how ES6 class syntax provides a clearer, more concise way to define constructor functions and manage inheritance. Classes make the structure of object-oriented JavaScript cleaner and more similar to other programming languages, which helps in organizing code and improving readability. Hoisting. The concept of hoisting was discussed to understand how JavaScript interprets function declarations and variable declarations differently. We noted that function declarations are hoisted to the top of their containing scope, allowing them to be used before they appear in the code. Static methods. We learned about static methods, which are called in the class rather than on instances of the class. These methods are useful for utility functions that operate independently of class functions. The behavior of the this keyword in different contexts was examined, especially how it can vary depending on the scope and the manner in which functions are called. Private members using symbols. The use of ES6 symbols as a way to somewhat hide implementation details was covered. Symbols provide a way to create properties that are not easily accessible from outside the class. Private members using WeakMaps. We discuss using WeakMaps to securely store private data for objects, providing true encapsulation by ensuring that these details are inaccessible from outside the class and are eligible for garbage collection when no longer needed. Getters and setters. The implementation and benefits of getters and setters were explored. These are used to control access to the properties of an object, allowing for validation, logging, and other side effects when properties are accessed or modified. Inheritance. We covered how classes can inherit from other classes, allowing for shared behavior across different types of objects and reducing code redundancy. Method overriding. The ability to override inherited methods was demonstrated, showing how subclasses can modify or extend the behavior of methods defined by their superclasses. This section aimed to deepen your understanding of modern JavaScript features and best practices, enhancing your ability to write clean, maintainable, and efficient JavaScript code in a professional development environment. As applications grow in size and complexity, managing all the code in a single file becomes impractical and hard to maintain. To address this issue, it's beneficial to split the code into multiple smaller files, each encapsulating a specific functionality or feature. These smaller files are called modules. Let's go over the benefits of modularity. The first benefit is maintainability. Smaller modular files are easier to understand, debug, and test. The second benefit is code reuse. Modules can be reused across different parts of an application or even in different projects, reducing code duplication. The third benefit is abstraction. Modules allow developers to hide implementation details while exposing a clear interface, making it easier to interact with the code. Practical implementation. Imagine you have a programmer class and its related functionalities divided across multiple modules for better organization. You would place the programmer base class in its own file and, for example, the front-end programmer class in a separate file. As these classes grow and gain more methods and enhanced functionality, managing them becomes easier since each class is in its own file, or in other words, its own module. Module systems in JavaScript. Historically, JavaScript did not support modules natively, and various solutions were developed. One of them being AMD, which stands for Asynchronous Module Definition. This was primarily used in browsers, and this format allows modules to be loaded asynchronously. Another module system is CommonJS. This is used in Node.js, and this format is designed for server-side development. Another module system is UMD, which stands for Universal Module Definition. This combines the approaches of AMD and CommonJS, making modules usable in both the browser and Node.js environments. ES6 Modules. With the introduction of ES6, JavaScript now natively supports modules in the browser. This system uses import and export statements to handle dependencies. This course will cover CommonJS for server-side applications and ES6 modules for browser-based JavaScript, providing you with the skills to work flexibly with JavaScript in multiple environments. In conclusion, understanding and using modules in JavaScript not only improves the structure and maintainability of your code, but also enhances its scalability and reusability. By adopting modern JavaScript module standards like ES6 modules and CommonJS, you ensure that your applications are robust, maintainable, and ready for growth. What are the key benefits of using modularity in JavaScript applications, and how do modules improve maintainability, reuse, and abstraction? The key benefits of using modularity in JavaScript applications include maintainability. This leads to smaller, modular files that are easier to understand, debug, and test. The second benefit is code reuse. Modules can be reused across different parts of an application or in different projects, reducing code duplication. The third benefit is abstraction. Modules allow developers to hide implementation details while exposing a clear interface, making it easier to interact with the code. By organizing code into modules, you make the application more manageable, enhance its scalability, and improve overall code quality. How do CommonJS and ES6 modules differ, and why is it important to understand both for developing JavaScript applications in various environments? CommonJS and ES6 modules differ primarily in their usage and syntax. With CommonJS, it is used in Node.js for server-side development, and it uses the require function to import modules and module.export to export them. With ES6 modules, this is supported natively in browsers, and it uses import and export statements to manage dependencies. Understanding both is important because it allows you to work flexibly across different JavaScript environments, using CommonJS for server-side applications and ES6 modules for browser-based applications, ensuring compatibility and leveraging the strengths of each module system. Modularity is a fundamental concept in software architecture that helps organize code in a way that enhances maintainability, reusability, and scalability. Let's apply these principles using the programmer class in a Node.js environment. So let's consider the principle of cohesion. Cohesion refers to how closely related and focused the responsibilities of a single module are. High cohesion within modules often leads to better code maintainability and understanding. In the context of Node.js, you can create a module for the programmer class, so each module in Node.js has its own scope, and anything defined in the module is private unless it is explicitly exported. So let's create a new folder, and I'll name this _ Node.js. Now within it, I'll create a new file, and I'll name this programmer.js. So within it, I can define the programmer class. So I'll say class programmer, define my constructor function. So it takes in the name and the preferred language of the programmer. So I'll say this.name and this.language. Now implement a simple method for code, which will just console log. I'll say this.name is programming in this.language. And that with a period. So now this class is only accessible within this file, so within this module. So we want to export it. So I'll write a comment, export the programmer class as the module's default export. So in order to make this class available in other files, I can say module.exports, and I will assign it to the programmer class. So by doing this, this makes this class the default export. Now I could also put it inside a JavaScript object, and by doing this, it now becomes a named export rather than a default export. So I'll undo that with Command Z. So now using the programmer module, in another file, I'll create index.js, and I want to utilize the programmer class in this file. So I need to import that. So I can do const programmer, and I will use the built-in require function and pass in a relative path to where the programmer class is, or the programmer module is. So it will be /, meaning the current directory, and the name of the file, which will be program. I can end that with a semicolon. So now I can create an instance of a programmer. So I can say const, I'll say Steven equals new programmer, passing in my name and the preferred language of JavaScript. And I can call Steven.code. So the importation here utilizes the require function provided by CommonJS in Node.js. So Node.js refers to server-side environments. So let's bring up the integrated terminal, and I'll navigate to Node.js, and I will run the index file, so node index.js. And here we see outputs, what we expected, as the console statement. So I log here, the console statement defined in the code method. So this was achieved through a default export. Now if I were to use a named export, right, so I put it inside a JavaScript object and save that. Now in order to utilize this, I would need to destructure it. Put it within curly braces. Now if I bring up the integrated terminal, up arrow and run it again, we get the expected result. But in this case, since we are just exporting one class, it makes more sense to make it a default export. Clean this up, put Command D. So encapsulation and privacy. By structuring your application into modules and only exporting what is necessary, you enhance encapsulation. For example, if there were private methods or properties within the programmer class, these would not be accessible to consumers of the programmer module, who only receive what is explicitly exported. So the encapsulation ensures that only the intended public interface of the programmer class is exposed and used. In conclusion, this lesson highlights the importance of modularity in software development, particularly in Node.js using CommonJS Modules. By organizing code into cohesive modules and properly managing exports, developers can create maintainable, reusable, and scalable applications. The modular approach not only supports good software design principles, but also ensures that each part of the application can evolve independently. Why is high cohesion important in software modules, and how does it contribute to the maintainability and understandability of the code? High cohesion in software modules means that the functions and responsibilities within a module are closely related and focus on a specific task. This is important for two main reasons. The first being maintainability. Modules with high cohesion are easier to update and debug since changes are localized to a specific area with related functionality. This reduces the risk of introducing errors elsewhere in the system. The second reason is understandability. High cohesion makes the code more intuitive and easier to understand. When a module has a single, well-defined purpose, developers can quickly grasp what it does and how it works without needing to sift through unrelated code. In summary, high cohesion leads to more organized, manageable, and comprehensible code, making the development process smoother and more efficient. Explain the concept of encapsulation in the context of modular programming. How does using modules in Node.js enhance encapsulation, and what are the benefits of this approach? Encapsulation in modular programming refers to the practice of keeping a module's internal details private and only exposing a limited, necessary interface to other parts of the application. In Node.js, using modules enhances encapsulation by scope isolation. Each module has its own scope, meaning its variables and functions are not accessible outside unless explicitly exported. By only exporting necessary parts of a module, you control what other parts of the application can interact with, reducing the risk of unintended interference and misuse. Now, there are three main benefits. The first is improved security. Sensitive or complex logic is hidden, preventing unauthorized access and potential misuse. The second benefit is the ease of maintenance. Encapsulated modules can be updated or refactored independently without affecting other parts of the application. And the third benefit is clear interfaces. Well-defined interfaces make the system easier to understand and use, promoting better code organization and collaboration. In summary, encapsulation via modules and Node.js leads to safer, more maintainable, and better organized code. What is the syntax for exporting a class or function as the default export in a CommonJS module? And how do you import and use this default export in another file? In CommonJS, to export a class or function as the default export, you use module.exports. To import and use this default export in another file, you use the require function. So for your exercise, create a file named groceryitem.js and implement a grocery item class with the properties of name and quantity. Then implement a display method. Export that file or module and utilize it in index.js. So for your exercise, here in the Node.js directory, I'll create a file and I'll name it groceryitem.js. So within it, I'll implement this class. So it's class grocery item, then our constructor. So it'll take in a name and a quantity. So I'll assign these properties for the name and for the quantity. And then we'll have a display method. So log and then tab, backtick. So I'll say the interpolation of this.name times this.quantity. So I implemented this simple class, and now I want to export it so that I can import this class and utilize it elsewhere. So module.exports, and I'll make it a default export. Assign this to the grocery item class. And so this enables me to import and utilize this class in other files. So in the same directory, I will create a file index.js, and I will use the CommonJS syntax to import it. So I'll say const, and the name of that export is grocery item, assigned to, and I use the built-in require function in CommonJS, and the directory is grocery item. So now I can utilize this class, grocery item, as if it was defined in this file. So I can say const item, new grocery item. So the first parameter it accepts is name, so I'll say apple. So apples as the argument, and for the quantity, I'll say 4. So now I want to call item.display. Let's bring up the integrated terminal. So I'll do Command J. It'll be Control J on Windows. And I will navigate to this file. So I'll run node index.js. And here I get the expected output. So let's cover modularizing the programmer class using ES6 modules. In the previous lesson, we used CommonJS modules in order to import and export modules in server-side environments using Node.js. So with ES6 modules, this provides a modern and cleaner syntax in order to achieve the same thing for JavaScript files that run in web browsers. So consider this scenario. We want to ensure that certain properties of our programmer class, such as skills, are kept private and managed through a WeakMap. We'll separate the concerns into two modules, one for the WeakMap and the other for the programmer class itself. So here in our directory _practice, I'll create a new file and I'll name this programmerskills.js. So this module will maintain a WeakMap to store private data related to programmers. So let's create that WeakMap structure. So programmer skills is assigned to a new WeakMap. So now we'll create a function. So I'll name this setSkills. This will accept two parameters, so a programmer object and the skills. And we will just update the WeakMap. So it'll be programmer skills.set. So the first parameter that we need to pass is the key. So that would be the programmer object or instance. And then the value. So that will be the skills. So now we'll create another function for retrieving the value. So we'll name this getSkills. This accepts one parameter, which will be the programmer. And we'll use that as the key in order to return the value. So programmerskills.get, and then programmer as the argument. So these functions are only available within this file. So if we were to use CommonJS syntax in order to export these two functions so we can use it elsewhere in our program, we would need to do module.exports, then a JavaScript object, and specify setSkills and getSkills. But with ES6 modules, we have a cleaner syntax to accomplish the same thing. So we can remove this and just use the export statement. So now both these functions are available to be used in other files. So let's create another file in our _practice directory. And I'll name this programmer.js. So this module defines the programmer class and imports the functionality from programmer skills to manage skills privately. So we'll use ES6 module syntax to import those two functions. So I'll use the keyword of import, and then curly braces, setSkills, and getSkills. Now we use curly braces because we are destructuring it. So we use the from keyword, and then we'll specify the path to the file. So it's // for the current directory, and then programmerskills.js. So now we can utilize these two functions in our class. So it'll be class programmer. We'll define our constructor function. This accepts two parameters, so the name and the skills. So now let's assign the name property and let's utilize that function in order to set the skills and manage it privately. So the first argument will be the this keyword, meaning this current programmer object, and the value will be the skills. So let's define another method. I'll name this code. So this will log, so tab, and then backticks, this.name is coding in. Then we'll utilize the getSkills function that we imported and pass in the this keyword, so this current programmer object. So once again, we will use the export keyword, which is provided in ES6 Modules, and we'll utilize this in our index.js file. So once again, we use our import statement, import the programmer from programmer.js. So let's create an instance of this object. I'll say dev, new programmer, the name of Steven, and the skills of JavaScript. So now we will call the code method. So now in order to utilize ES6 modules and have it executed in our web browser, we need to update this script tag. So instead of the type being text/JavaScript, we'll update this to be module. So it's treated as an ES6 module. So let's start live server. So we'll bring up the command palette with Command Shift and P. Then it's live server, open with live server. And then we can inspect. Let's go to our console. And let's resize this. So here we see our expected output when we call the code method, which is Steven is coding in JavaScript. So another thing I want to show, here in our programmer.js file, we exported our programmer class, but we can also make this a default export. So rather than using the export statement here, I'll remove that, and I can say export default programmer. So now when we go to our index.js file, because it is a default export, I can remove the curly braces and save it. Let's see our output. And here we see, actually let's clear it again just so it'll make it more easily viewable. I can save it again, and I get our expected output. So this shows how we can use ES6 modules in order to organize our code. So as our applications grow in size, we want to split up our functionality into different files. So let's cover some key points. The first is modularity and privacy. By separating the programmer class and its skills management into different modules, we keep implementation details hidden and only expose what is necessary through exports. ES6 modules. Using import and export statements, we can clearly define dependencies and how modules interact. This approach is cleaner and more maintainable than older module systems. Webpack and browser modules. While modern browsers understand ES6 modules natively, complex applications might benefit from tools like Webpack for bundling modules, managing dependencies, and optimizing load times. In conclusion, this setup illustrates how to effectively use JavaScript modules to encapsulate logic, manage privacy, and expose a clean public API. This modular approach not only aids in code organization, but also enhances security and scalability in web development projects. How do ES6 modules enhance code maintainability and organization compared to older module systems? ES6 modules improve maintainability by providing a clear structure for defining and managing dependencies with import and export statements. This helps keep the code organized and easier to manage. What are the benefits of using tools like Webpack in conjunction with ES6 modules for modern web development? Using tools like Webpack with ES6 modules helps bundle and optimize code, managing dependencies more efficiently. This improves load times and ensures that all necessary modules are correctly included, making the development process smoother and the application faster. So for your exercise, use the ES6 module syntax and create a file named groceryitem.js and implement a grocery item class with the properties of name and quantity, Then implement a display method. Export that file and utilize it in index.js. So you implemented this exercise previously, and you use the CommonJS Modules syntax in a Node.js environment. But in this case, we will implement these files and utilize it in a web browser. So to implement this, in the directory _practice is where I have my index.html file. So I'll create a new file, groceryitem.js. So I didn't implement this in the previous lesson. So to help us save time, I'll just copy this, and I will paste it in here. But currently I'm using the CommonJS syntax, but instead I want to use the ES6 module syntax. So I'll make the grocery item class a default export. So I can do that with export default and then grocery item. So now I can import this in my index.js file. So I'll use the keyword import and then grocery item from groceryitem.js. So now let's create a new item equals new grocery item of bananas and a quantity of 5. Then I will call item.display and I will save it. Let's resize this so we can see the web browser. Close the sidebar with Command B. And here I see the expected output of bananas times 5. In the landscape of modern JavaScript development, especially when building browser applications, the roles of transpilers and bundlers are crucial. These tools help manage and adapt code for various environments, ensuring compatibility and efficiency. Transpilers. A transpiler is a type of tool that transforms source code written in one programming language or version, like modern JavaScript ES6, into another version that may be more compatible with current environments, such as older JavaScript ES5 that all browsers can understand. A popular transpiler is Babel. One of the most widely used transpilers, it allows developers to write modern JavaScript while ensuring that the code runs smoothly in environments that only support older standards. For instance, features like classes, the let keyword, the const keyword, arrow functions, and template literals introduced in ES6 are not universally supported in older browsers. So suppose you have a programmer class defined with modern JavaScript features. Using Babel, this can be transpiled to be compatible with environments that do not support the latest JavaScript syntax. Now let's consider bundlers. A bundler aggregates all the modules in your project, and sometimes their dependencies, into a single file or a few files. This process is crucial for optimizing load times and managing resources efficiently. A popular bundler is Webpack. Webpack is the most popular bundler in the modern web development toolkit. Webpack not only bundles files, but also minifies code and provides optimization, like tree shaking, which refers to removing unused code. So an example with Webpack, you can configure Webpack to bundle your JavaScript modules, including the programmer class module, into a single file. This bundled file is then included in your web application, ensuring that all script dependencies are resolved and managed efficiently. So why would you use these tools? Well, one reason is compatibility. It ensures that modern code works in environments that are not up to date with the latest ECMAScript standards. The second reason is performance. It reduces the size of the code and the number of server requests required to load your application. And third is for development efficiency. It simplifies development by allowing you to use modern JavaScript features without worrying about browser compatibility. While these tools are essential for browser applications due to their varied support for JavaScript standards across browsers, Node.js environments generally do not require such tools for running JavaScript code, as Node.js is typically up to date with the latest JavaScript features. However, bundlers like Webpack might still be used in Node.js applications for optimizing the application deployment. In conclusion, understanding and utilizing transpilers like Babel and bundlers like Webpack is essential for any modern web developer looking to create efficient, maintainable, and compatible web applications. They are especially important when the application needs to be scaled or maintained across different browser environments. What is the primary function of a transpiler in modern JavaScript development, and why is it important? The primary function of a transpiler in modern JavaScript development is to convert code written in newer versions of JavaScript, like ES6 Classes, into older versions, like ES5, that is compatible with a wider range of environments, including older browsers. This is important because it ensures that modern JavaScript features can be used by developers without worrying about compatibility issues, allowing the code to run smoothly across all browsers. How does Babel help in making modern JavaScript features compatible with older browsers? Babel helps make modern JavaScript features compatible with older browsers by converting newer JavaScript syntax and features like classes, the let keyword, the const keyword, and arrow functions into older syntax that all browsers can understand. This process, called transpiling, ensures that code written with the latest JavaScript standards can run on any browser regardless of its version. What role does a bundler like Webpack play in optimizing web application performance and resource management? A bundler like Webpack optimizes web application performance and resource management by combining all your JavaScript modules and their dependencies into a single file or a few files. It also minifies the code and removes unused parts by utilizing tree shaking, which reduces the file size and the number of server requests needed to load the application. This leads to faster load times and more efficient resource usage. Why might Node.js applications generally not require transpilers like Babel, but still benefit from using bundlers like Webpack? Node.js applications generally do not require transpilers like Babel because Node.js often supports the latest JavaScript features. However, they can still benefit from using bundlers like Webpack to optimize performance by combining multiple files into one, reducing file size through minification, and managing dependencies more efficiently. This makes the application faster and easier to deploy. So let's set up our JavaScript development environment. So first we will cover installing essential tools with npm. Before you start, ensure that Node.js is installed on your machine, as it comes with npm, which stands for Node Package Manager. This tool is crucial for managing third-party libraries and development tools. With npm, we can install open source packages to utilize in our projects. So let's open up the integrated terminal. I can do that with Command-J or Control-J for on Windows. So ensure that Node.js is properly installed by checking its version in the terminal. I can do that with node-v. And here I see I have version 20.16.0. So now let's create a new directory for our project and we will navigate to it. So rather than clicking on this icon, I can just do that through the command line. So I'll do mkdir for making a new directory, and I'll name it ES6, actually I'll name it underscore ES6 Tooling. Now I specified the underscore so that this directory shows up first when I view my project files in VS Code. So now let's change directory into that new folder that we created. So now we will create a package.json file. So first let's cover what JSON is. JSON stands for JavaScript Object Notation, and it is a lightweight data interchange format that is easy for us to read and write, and easy for machines to parse and generate. It is often used to transmit data between a server and web applications, serving as an alternative to XML. XML standing for Extensible Markup Language. So JSON is a more modern way to do this. JSON data is structured as key-value pairs within curly braces and supports nested objects and arrays. So let's run the following command to create a package.json file in this new directory that we created. And this file will help us manage all of our project's dependencies and other configuration. So I'll run npm, and then the keyword init, and then -- yes to accept all the default settings. So after I run this creates a new file named package.json to help manage my npm dependencies. So I can close this. So here I see it is just a JavaScript object containing properties. So now let's focus on setting up Babel. So this is to transpile modern JavaScript in ES6 Classes to backward compatible JavaScript like ES5 and we will use Babel to accomplish this. So let's clear this out. So step 1 is we want to install the necessary Babel packages. You could also reference the documentation at babel.dev/docs/usage. So now let's install the necessary Babel packages using npm. These include Babel CLI, Babel core, and a preset package, Babel preset environment, which includes all the latest ECMAScript features. So we can do that with npm install, then at babel/CLI, then at babel/core, at babel/preset environment, and we will specify a flag for save dev. So it's 2 hyphens, save, hyphen, and then dev. And so what this does is that this installs the packages as developer dependencies. So let's discuss what these packages stand for. So Babel CLI, this provides the Babel command line interface for running Babel from the command line. So Babel core, this contains the core functionality of the Babel transpiler. In Babel preset environment, this includes plugins to enable transformations for all modern JavaScript features. So let's run this. So our packages have been installed successfully. So I'll do Command K to clear this, and then Command J to close it. And here we see our 3 developer dependencies have been installed, and they are now listed in our package.json file. So now we need to configure Babel. So we want to update our scripts here. So our scripts determine different command line scripts that we can run. So I'll add comma, and I will name this script Babel. So the value will be what command we want to run, which will be Babel, then index.js, which will be our project file, and then we'll specify the output with -o, and it will be in the build directory /index.js. So let's create a build directory in here. So it'll be build, and let's create another file, index.js. So here we replace our ES6 JavaScript, and after transpiling it, the result will be stored in the build directory. So we also need to add a file, and it will be period Babel RC. So by prefixing it with a period, this means that this is a hidden file. So Babel RC is a configuration file used by Babel, which is a JavaScript compiler, to specify options and presets for transforming your JavaScript code. The name Babel RC stands for Babel Resource Configuration. So we'll just define this object here. So the key will be presets, and the value will be an array with the string at Babel/preset environment. We can save that. So let's go back to our index.js file, and let's write code in ES6 which uses modern features. So I'll specify a class, and I'll name it programmer. Now I'll define a public field, so I'll say the role of the programmer, and we'll just assign this to developer. Now we'll define a private field, so this is a modern syntax, and I'll name it experience. So now let's define our constructor function. This takes in the name, this takes in the technology they work with, and I'll say experience. So we will set the name. We can set the technology they work with. And let's set the private field of experience. So assign this to experience. Let's define, I'll close the sidebar so we can see the code better. So Command B, I'll name it develop. And then this will log out, backtick, this.name, develops software using this.technology with this.experience. This is actually a private, so I need the hash for it. Years of experience. So we can save that. And I'll have another method, which is getExperience for accessing this private field. And this will return this.experience. And also we will export it. So we use that export keyword. So here we see this class is using the modern features of having a private field but this language feature is not supported in JavaScript ES5. So that's why we need Babel to transpile this index.js file to ES5 syntax. So let's navigate again to our package.json, and we have this script that we define, and so we can execute this from the command line, and it will run this command specified here as the value. So let's bring up with Command J or Control J, and I'll run npm run, and then the name of the script, which is Babel. So here in our output, if we view the build directory, the result of transpiling this modern ES6 code can be found here, and this is the result of using Babel. So this code is now usable for browsers that only support older versions of JavaScript. So now let's cover integrating Webpack for more efficient builds. While Babel is excellent for single files, Webpack is more suitable when your project consists of multiple files, as it bundles all your project's JavaScript into one or a few files. Webpack will minify both your code and the final bundles to reduce file sizes. Minifying JavaScript code involves removing unnecessary characters like spaces, comments, and line breaks to reduce file size and improve load times without changing its functionality. So step 1 for setting up Webpack, you will install Webpack and configure it to work with Babel to handle the entire project, not just individual files. And second, we can automate with npm scripts. So we navigate back to package.json. We will update package.json to include a script that runs Webpack, ensuring all your JavaScript files are processed through Babel and bundled correctly. We will cover this in the next lesson. So in conclusion, by following these steps, you set up a modern JavaScript development environment capable of handling ES6 syntax and producing code compatible with older browsers. This setup ensures that your development process is efficient and your applications are robust and maintainable. What command do you use to initialize a new npm project, and what file does it create? To initialize a new npm project, you use the command npm init --yes. This command creates a file named package.json, which manages your project's dependencies and configuration. Why is Babel used in a JavaScript development environment, and what does it transform? Babel is used in a JavaScript development environment to convert modern JavaScript code, so this refers to ES6 and newer, into an older version, so this is ES5, that can run in any browser. This ensures that new features and syntax can be used without worrying about browser compatibility. What is the purpose of the .babelrc file, and how is it typically structured? The purpose of the .babelrc file is to configure Babel, specifying how JavaScript code should be transformed. It is structured in JSON format and usually contains an object with properties like presets and plugins that define which transformations to apply. Webpack is a powerful tool that bundles JavaScript files into a single file, optimizing load times and simplifying deployments. Webpack is a very large topic, and it's a very configurable technology. So this course lesson will just scratch the surface of its capabilities so that you are familiar with it, and you can explore the documentation at webpack.js.org. So from a very high level, Webpack takes many files and optimizes it for production by bundling everything into either a single file or a smaller amount of files. So Babel, on the other hand, transpiles modern JavaScript, so ES 2015 or newer, into backwards compatible versions so that our code can successfully run on older browsers, and while in development, we can still utilize the newest language features and syntax of modern JavaScript. So let's continue with the project that we were working on in our previous lesson. Let's bring up the integrated terminal with Command J or Control J, and we'll run npm install, and we'll install the package of Webpack, Webpack CLI, Babel loader. We'll specify the flag of save dev and -- legacy peer dependency. So this package Webpack is a powerful module bundler for JavaScript applications. it takes modules with dependencies and generates static assets representing those modules. So Webpack CLI, this is a command-line interface for Webpack. It provides commands to initialize, run, and configure Webpack from the terminal. So this package, Babel Loader, this is a Webpack loader that allows Babel to transpile JavaScript files. It converts modern JavaScript code, so ES6 and newer, into backwards compatible versions, so ES5, using Babel. In this flag, legacy peer dependencies, this tells NPM to use an older algorithm for resolving peer dependencies, which can help bypass conflict. So, we'll install this. So it's successfully installed. We can view our package.json, and here we see these packages have been added to our developer dependencies. So now let's create a webpack.config.js file. So we can right-click, webpack.config.js. So it is not mandatory to provide a custom configuration file for Webpack, as it does have a default convention. Before this course, we'll create a simple configuration file. So we want to use the CommonJS module syntax to import a library, so that's path, require, and then path. And then we would do module.exports, assign this to a JavaScript object, and here we'll define our configuration. So we can specify the mode. So for now, it's just development. We'll define the entry point of our application. So we'll say that is in source and then index.js. And we will define the output. So after Webpack bundles everything, where will it place those files? So we'll specify the path. And here we will use this path that we imported. And so what this will do is this will create an absolute file path to where we want the output to be. So there's a keyword, so that's 2 underscores and directory name. And we'll specify the name of the directory to be dist for distribution. So with this configuration, we're basically telling Webpack, after you bundle all of our files and minify our code, place everything in a directory named dist. And we'll specify the file name of the output, and it'll be main.js. So now we'll use module. We will define some rules because we want to utilize Babel. So it's actually an array. Let's update that. So now it's the object, and then test. So it's a regular expression of /then \period to escape it, JS, a $, and then another /. So basically we're telling Webpack every JavaScript file, or every file that ends with a JavaScript extension. We can say exclude node modules, so the node modules directory, so we don't want to include the dependencies. And we can say use, and we want to utilize Babel to transpile our ES6 code into backwards compatible ES5 code. So we can save this. So this is our custom configuration. Don't worry about memorizing all this. This is just to demonstrate what Webpack is, so you have more insight. So here we define the entry point of our application to be in the source directory in the index.js file, but currently our index.js file is at the root of the project. So let's create a new directory, and I'll name it source, and this will contain our source code. So I will copy this into that directory. So I'm going to create an instance of this programmer class. So I'm going to say consdev new programmer. So the name of Steven, the technology of JavaScript, and the experience, I'll say 10. And I will call the develop method. Now let's go to our package.json file. We want to define another script so that we can utilize Webpack. So I will name the key to be build and the value to be Webpack. So last thing I want to do is I want to create an index.html file. So index.html at the root of the project. So exclamation point and then tab. And I just want to create a simple h1 tag, and I'll say using Webpack. I also want to specify a script tag. So this will be in the distribution directory, and the output will be main.js. So now let's bring up the integrated terminal with Command and J, and I'll clear this out. So we want to run our build script. So we're going to run Webpack. So npm run build. So Webpack successfully bundled our code for our very simple project. So here we specified our output directory to be dist for distribution. And so this is the output that Webpack generated to create backwards compatible code. So once again, it's because this modern syntax that we use is not compatible with older web browsers. So we use Babel to transpile our code into ES5 syntax. And so Webpack is used to bundle our code for production. So this is a really simple example because we just have one file, but you can imagine as our projects grow and we have hundreds of JavaScript files, then Webpack becomes a mandatory tool to optimize our code for production. So here we can see what was generated. Now, I can also update this. So if I go to the Webpack configuration file, I specified the mode to be development. Let's change this to be production. And I'll bring up the integrated terminal. And let's run the build command again. So here we see the code has been minified. So everything is placed on one line. And all the spaces and new lines have been removed to make the file size as small as possible. This will help make our application faster once it's running in a web browser. So we can see this in action and actually see this in a browser. So I'll resize this. And let's open up the integrated terminal. And I'll do open and then period. So this will open up Finder on my Mac. So now I'll drag my index.html file and drag it to my browser. So let's close this out. So here in our index.html file, I have the h1 tag saying using Webpack. So we see that here. And in our script tag, this is referencing the production code that Webpack and Babel generated for us. So this code. And so the code that we were using in development was utilizing the programmer class with modern ES6 syntax. I created an instance of the programmer and called the develop method. So it logged this out. Let's check that it did that in our browser. We can bring that up with doing the developer tools. We drag that over here. In our console, we get our expected log statement. View our sources, and here we see the production code that Webpack generated for us. So I can close this. So this is a very quick and brief overview of Webpack, just so you have a better understanding of what it does. So in conclusion, using Webpack and Babel together simplifies the process of modern JavaScript development by bundling and transpiling your code. This streamlined setup ensures compatibility across browsers and improves developer efficiency. So for more detailed and advanced configuration, refer to the Webpack documentation at webpack.js.org and Babel at babeljs.io. So let's recap what we covered in this section. First, we covered modules. This lesson introduced the concept of modules in JavaScript, explaining how they help organize and maintain code by breaking it into manageable, reusable pieces. We covered CommonJS. So we explored CommonJS, which is a standard for modularizing JavaScript that allows the encapsulation of functionality into reusable packages, which has been widely used in Node.js. ES6 Modules. This section covered ES6 Modules, a native JavaScript feature that supports static import and export of code, offering a more integrated and optimized way to handle modules directly in the browser or in Node.js environments. ES6 Tooling. This topic addressed various tools and technologies that support ES6 development, enhancing code compatibility across different browsers and environments. Babel. We discussed Babel, a JavaScript compiler that allows developers to write modern JavaScript code that is then transpiled into backward-compatible versions for better support across all platforms. Webpack. The lesson on Webpack provided insights into how this powerful tool bundles JavaScript files and dependencies into a single file, improving site speed and efficiency. Each topic was designed to equip you with the necessary skills to effectively use modern JavaScript tools and practices, streamlining your development process and ensuring your projects are robust and maintainable. Node.js is an open-source, cross-platform runtime environment that enables the execution of JavaScript outside of a web browser. It's primarily used for building server-side applications and networking tools. Node.js supports the development of backend services, commonly known as APIs. This stands for Application Programming Interface. These are essential for powering client applications such as web and mobile apps. So, key features of Node.js. One of the key features is its versatility in backend development. Node.js is suited for creating highly scalable, data-intensive, and real-time applications. Its non-blocking, event-driven architecture allows it to handle numerous, simultaneous connections with high throughput, making it an excellent choice for developing services like chat applications and online gaming servers. The second feature is that it is quick to start and agile-friendly. Node.js is known for its ease of use and minimal setup, enabling developers to quickly start building applications. This attribute aligns well with agile development practices, where time to market and adaptability are critical. Another feature is real-world usage. Prominent companies such as PayPal, Uber, Netflix, and Walmart leverage Node.js in their production environments. These organizations have reported benefits such as reduced development time, decreased number of code lines and files, which in turn contribute to enhanced performance in terms of request handling and response times. Another feature of Node.js is that it enables you to use JavaScript for your backend and frontend. This allows developers to use the same language for both server-side and client-side scripts, promoting skill reuse and reducing the learning curve for new developers. It provides a uniform programming language across the stack, which leads to a clearer and more consistent codebase. Node.js also has a rich ecosystem. Node.js benefits from a vast ecosystem of open-source libraries available through NPM, which stands for Node Package Manager, which simplifies the addition of functionalities and accelerates the development process. In conclusion, Node.js is a popular choice for developers looking to build efficient and scalable web applications. Its ability to run JavaScript on the server side, along with its robust tooling and supportive community, makes it a dependable and practical choice for modern web development. What is Node.js? Node.js is a runtime environment for executing JavaScript outside of a web browser. So let's go over understanding runtime environments. A runtime environment is a setting where programs are executed. It provides built-in libraries and manages the program's execution, offering various services such as handling I/O or network requests. So JavaScript and web browsers. Historically, JavaScript was primarily used within web browsers. Each browser comes with its own JavaScript engine, which interprets and executes JavaScript code. So Microsoft Edge uses the Chakra engine, the Firefox browser uses the SpiderMonkey engine, and Google Chrome uses the V8 engine. These different engines can lead to variations in JavaScript behavior across browsers. Within a browser, JavaScript interacts with the document object model, otherwise known as the DOM, to manipulate web pages, using methods like document.getElementById, with the ID being root for this example. The evolution to Node.js. In 2009, Ryan Dahl, the creator of Node.js, proposed an innovative idea which was enabling JavaScript to run outside the web browser. He leveraged Google Chrome's V8 engine, known for its speed, and embedded it within a C++ program. This integration birthed Node.js, which is essentially an executable or a .exe program that extends JavaScript's capabilities beyond web browsers. So Node.js does not have browser-specific objects like the DOM because it is not intended for controlling web page content. Instead, it includes additional modules that provide JavaScript the ability to interact with the file system, create servers, handle network protocols, and more. For example, fs.readFile can be used for reading files from the system, and HTTP create server for creating a web server. These functionalities demonstrate that Node.js is equipped to handle backend services, making it ideal for building scalable network applications. What Node.js is and is not. Node.js is not a programming language. It uses JavaScript as its scripting language. Node.js is not a framework. It does not impose any specific way of organizing your project. It merely provides a runtime environment with useful libraries. Node.js is a runtime environment. It extends JavaScript's reach to the server side, offering tools and libraries that are not available in a browser context. In conclusion, Node.js revolutionized JavaScript's programming by expanding its scope from the client-side and browsers to include server-side applications. This advancement has made JavaScript a versatile, powerful choice for full-stack development. Node.js continues to thrive as a popular runtime environment due to its efficiency and the vast NPM ecosystem, which provides numerous libraries and tools to enhance functionality. Node.js operates on a non-blocking, asynchronous model, which can be likened to a highly efficient restaurant service. So let's consider a restaurant analogy. Think of Node.js like a single waiter serving multiple tables. Instead of waiting for one table's meal to cook before taking another table's order, the waiter keeps taking orders and serving food as it becomes ready. This demonstrates the asynchronous operations that Node.js supports. So now a technical explanation of this. In Node.js, when a request is made, the request is processed without blocking other operations. Node.js does not wait for the database response, but instead places a callback in the event queue, which will be executed once the response is ready. This allows the Node server to handle other requests in the meantime. Contrasting this with synchronous operations, in more traditional synchronous models, like those used by frameworks such as Ruby on Rails, each request might be handled by one thread. If the thread is busy, it cannot take on more work. This can lead to inefficiencies, as other requests have to wait until free threads are available or additional hardware resources must be provided. Synchronous operations have blocking behavior. In such synchronous environments, a thread handling a database query will remain idle until the data is returned, which is inefficient compared to Node's asynchronous approach. So let's go over the benefits of the Node.js model. The first benefit is efficiency. Node.js can handle numerous simultaneous operations on a single thread thanks to its event-driven model. This increases efficiency as the server can manage multiple tasks without waiting for any single task to complete. The second benefit is scalability. The ability to handle many requests on few threads allows Node.js applications to scale effectively without requiring significant hardware resources. This is particularly beneficial for I/O-intensive applications such as web APIs or real-time data processing. And the third benefit is resource management. Node's model promotes better resource utilization as the server remains active and non-idle even when data operations are pending. Let's consider ideal use cases for Node.js. Node.js is well suited for applications that require real-time data processing, such as an online gaming application, chat applications, and live streaming services. It excels in environments where the application needs to handle a large volume of short messages or commands that require low latency. Let's consider the limitations of Node.js. Node.js is less ideal for CPU-intensive tasks. For applications that require intensive data processing tasks, such as video encoding, image manipulation, or large-scale mathematical calculations, Node.js might not be the best choice. Its single-threaded nature means CPU-heavy tasks can block the entire system, leading to delays in processing other concurrent operations. In conclusion, Node.js leverages an asynchronous, non-blocking model to provide efficient and scalable solutions for many modern web applications. While it excels in handling I/O operations, it's less suited for tasks that are heavily CPU-bound. Understanding when and where to use Node.js can help developers maximize their application performance and efficiency. How does Node.js's asynchronous, non-blocking model improve server efficiency and scalability compared to traditional synchronous models? Node.js's asynchronous, non-blocking model improves server efficiency and scalability by allowing a single thread to handle multiple requests simultaneously. Unlike traditional synchronous models, where a thread waits for a task, like a database query, to complete before moving on, Node.js processes requests without waiting. It places tasks in an event queue and continues handling other operations. This approach prevents idle waiting, maximizes resource utilization, and allows Node.js servers to manage more requests with fewer hardware resources, making them highly efficient and scalable. What types of applications are ideally suited for Node.js, and what limitations should developers consider when choosing it for their projects? Node.js is ideally suited for applications that require real-time data processing and handle many simultaneous connections, such as online gaming, chat applications, and live streaming services. It excels in managing a large volume of short, low-latency messages. However, developers should consider its limitations for CPU-intensive tasks, like video encoding or large-scale mathematical calculations. Node.js's single-threaded nature can cause performance bottlenecks in such scenarios, making it less suitable for applications requiring heavy data processing. Node.js's module system is a powerful feature that allows developers to organize the code of large applications efficiently. Modules are discrete units of functionality that could be imported and used in other parts of a Node.js application, or even across different Node.js applications. So what are modules? A module in Node.js encapsulates related code into a single unit of functionality. This could be anything from a library of utilities to a set of related functions that handle specific functionalities, like database interactions, file operations, or network communications. So why do we need modules? Modules are essential for several reasons. One reason is maintainability. By dividing applications into smaller, manageable pieces, modules make the codebase easier to understand and maintain. The second reason is reusability. Modules can be reused across different parts of an application or even in different projects, which reduces code duplication and effort. The third reason is namespace management. Using modules helps avoid global namespace pollution by confining variables and functions within a local scope rather than cluttering the global scope. So how do modules work in Node.js? In Node.js, each file is treated as a separate module. Node.js provides a simple and efficient way to create modules and expose them to other parts of your application. So step 1 of creating a module, you can create a module by placing the code into a separate JavaScript file. For example, if you are creating a utility module, you might have a file named utility.js. So step 2 is exporting module contents. Node.js uses exports and module.exports to make functions and objects available to other files. For instance, if our utility.js file contains a function to check if a number is prime, you can export it like this. So implement a function, I'll name it isPrime. This accepts a number as a parameter, so I'll implement this. If the number is less than or equal to 1, return false. If the number is equal to 2, return true, since 2 is prime. Now if the number is divisible by 2, then we'll return false. Let n, we'll initialize that to 3. We'll take the square root of the number. So don't worry about memorizing this. This is just to demonstrate. So while n is less than or equal to the limit, if the number is divisible by n, then we know that it is not prime. So we'll update the value by 2. Only want to consider odd numbers. Otherwise, it is prime. So to make this function usable outside of this file or outside of this module, we need to export it. So we use the CommonJS syntax, module.exports is prime. So now, let me create another file, and I'll name this index.js. So step 3 is importing a module. So we use the require function to include the module in another file. So I can say const is prime, then the require function. I'll pass in a relative file path to the utility. And save that. Utility.js. Now I can utilize that. I can say log is prime. I'll pass in the number of 5. Let's bring up the integrated terminal, and I will run node index.js. So here we see the output of true because 5 is prime. Let's do the value of 6, for example. We'll run it, and here we see the value of false. So this demonstrates how you would implement a function, export it, and utilize it in another file. So creating your own modules. Creating your own modules is as simple as writing any regular JavaScript file, and then using module.exports to expose parts of the module to other parts of your application. You can expose objects, functions, or any JavaScript data structure. In conclusion, understanding how to effectively use the Node.js module system is crucial for developing scalable and maintainable Node.js applications. By leveraging modules, developers can create well-organized, modular code that enhances code quality and development efficiency. How does the Node.js module system contribute to the maintainability and scalability of large applications? The Node.js module system contributes to maintainability and scalability by organizing code into smaller, reusable units, making it easier to manage, understand, and update individual parts of a large application without affecting the entire codebase. What advantages does the modular approach in Node.js offer in terms of code organization and reuse across different projects? The modular approach in Node.js improves code organization by encapsulating functionality into separate units, reducing complexity. It also enhances code reuse, allowing modules to be easily shared and used across different projects. In Node.js, global objects are special objects that are available in all modules. These objects provide essential functionality that can be accessed anywhere within a Node.js application, making them a fundamental part of the Node.js runtime environment. Let's cover the built-in global objects. Node.js comes with a set of predefined global objects that are readily available for use. These objects serve various purposes, from fundamental JavaScript objects to node-specific objects that provide functionality unique to the Node.js environment. The first one we will cover is the global object. This is similar to the window object in browsers. Global is the top-level object in Node.js. Almost all other objects are either properties of this object or derived from it. Let's consider the process global object. This is one of the most important global objects in Node.js. It provides information about and control over the current Node.js process. Through process, you can access environment information, read environment variables, communicate with the terminal, or exit the current process. The console global object. This is used to print information to the standard out and standard error. It acts similarly to the console object in browsers. The buffer global object. This is used to handle binary data directly. It is built specifically for managing streams of binary data in Node.js. Now let's consider global functions, which consist of setImmediate, clearImmediate, setTimeout, clearTimeout, setInterval, and clearInterval. These globals are timer functions that help you schedule tasks to run after a specified duration or at a regular interval. Creating your own global objects. While Node.js manages a variety of built-in globals, developers can also define their own global variables that need to be accessible throughout the application. Here's how to define and use custom global objects in Node.js. Step 1 is defining a global object. You can attach your custom properties or objects to the global object. This makes them accessible from anywhere in your Node.js application. So we'll use the global built-in object. We'll add a property, and I'll name this myConfig. Let's assign this to a JavaScript object. Close it with a semicolon. So we'll add the property API URL. We'll just do a sample URL of https api.example.com. We'll add another property, so at port 3000. Step 2 is using the global object. Once a property is attached to the global object, it can be accessed in any module without requiring imports or passing it explicitly. So we can log this out. We'll do log and then tab for that keyboard shortcut. Then we'll do global. Then that property we just defined, which is myConfig.API URL. Now I'll bring up the integrated terminal. So I'll use the keyboard shortcut of Command and J or Control and J. Now I've already navigated to where this file is in its directory. So I'll run node, and I name this file 5 global objects. And here we get our expected value, which is that API URL value that we added. So caution when using global objects. While global objects can be incredibly useful for sharing information across modules, their use should be minimized due to the potential for creating tightly coupled components and the difficulty in tracking changes throughout the application. It's generally better to explicitly pass objects you need within modules through module exports and require statements. In conclusion, global objects in Node.js are powerful tools for developing applications with shared functionalities. Understanding both built-in and custom globals can help you effectively manage application-wide settings and maintain state across various parts of your application. However, limited use of globals is recommended to maintain a clean and manageable codebase. How do built-in global objects in Node.js facilitate application-wide functionality and control? Built-in global objects in Node.js provide essential tools that can be accessed from anywhere in the application, allowing for easy control and management of the Node.js environment. They enable functionalities like process management, timing operations, and handling binary data without needing to import or define them explicitly in each module. This makes them crucial for application-wide tasks and system-level operations. What are the potential risks of using custom global objects in Node.js, and how can they be mitigated? Using global objects in Node.js can lead to tightly coupled code, making it harder to track changes and debug issues. Globals are accessible everywhere, so unexpected modifications can cause bugs that are difficult to trace. To mitigate these issues, it's better to minimize the use of globals and instead pass needed objects explicitly through module exports and imports. This keeps the codebase cleaner, more modular, and easier to maintain. Global objects provide essential functions and variables that can be accessed from anywhere within a JavaScript environment, whether in a browser or a Node.js application. Let's go over common global functions. The first one being console.log. This is a global function that outputs information to the console useful for debugging and logging application data. Second is setTimeout. This allows you to schedule a function to be executed after a specified delay. This function is very handy for executing code after a pause. ClearTimeout. This is used to cancel a timeout previously established by calling setTimeout. setInterval. This schedules a function to be run repeatedly at specified intervals. This is useful for tasks like updating the UI at regular intervals. ClearInterval. This stops the repeated execution set using setInterval. So let's cover global scope in browsers. In browser-based JavaScript, the global object is window. All global variables and functions are attached to this window object. Accessing globals. When you declare a variable or function at the global level, it's accessible through the window object, such as window.setTimeout or window.message. Global scope in Node.js. Node.js does not have a window object because it does not run in a browser environment. Instead, it uses a global object to provide a similar functionality. So let's discuss Node.js globals. In Node.js, you can access built-in modules and global functions through the global object, such as global.console.log or global.setTimeout. So an example of that, we are to global.console.log. This is a global console call, and that with a semicolon. Now if we were to run, let's save this and execute it. We get our expected console output. Now let's call setTimeout. setTimeout. So the first argument to pass is a callback function. So we'll specify an arrow function here. So I'll say log and then tab. I'll say this happens after a timeout. Now for the second argument, for the setTimeout global function, we specify the time in milliseconds. So I'll say 1,000. So after 1 second, we'll execute this again. We get our expected output, and then after 1 second, we see this console output. So both of these, setTimeout and console.log, are available globally. So let's further discuss variables and global scope. Unlike in browsers, if you declare a variable with the var keyword, let keyword, or const keyword at the global level in Node.js, it does not attach to the global object. This behavior encapsulates the variables within the module scope, avoiding unintentional conflicts. So for example, let's comment this out. If I were to do let message assigned to hello world, and then we log that out, say global.message, clear this out with Command K, up arrow and run it, we see the value undefined. So even though this message variable was defined at the global level, it is not attached to the global object. So it is enclosed within this file, within this module. So let's cover an example using setInterval and endInterval. So we can comment this out. Let's define a function, and I'll name it updateTime. So we'll set the current date, so new date, and then we will log it out. So backticks to create a template literal. I'll say current time, and then our $sign in curly braces, now.to locale datetime string. So now we will write a comment, set an interval to run update time every second, right? So every 1,000 milliseconds. I'll say const interval ID, set interval, and we want to call update time every second. So this returns an interval ID, which we will use to cancel it. So we want to eventually stop the interval, and we'll do so after 5 seconds. So we'll call set timeout. Once again, the first argument is a callback function, so we'll use our modern arrow function syntax. And after 5 seconds, we want to clear the interval to stop it. And we need to pass the interval ID. Then we can log out. Interval cleared. No more time updates. Now for the second argument, we'll pass in 5,000 for 5 seconds. So let's run this. We'll clear this out. We'll run it. So it shows the current time every second. Then after 5 seconds, we see interval cleared, no more time updates. So let's discuss best practices. While global objects and functions are extremely useful, you should limit their use. Reason being is you want to avoid polluting the global scope. Adding too many objects to the global scope can lead to conflicts and difficulties in maintaining the code. It's generally better to keep global usage minimal. Second is you want to use local scope where possible. You want to encapsulate variables and functions within a local scope, such as within functions or modules, to avoid unintended interactions and make the code easier to manage and debug. In conclusion, global objects and functions are fundamental in both browser and Node.js environments, providing developers with powerful tools for performing common tasks. Understanding how to use these tools effectively and responsibly is crucial for developing robust applications. How do global objects differ in scope and behavior between browser-based JavaScript and Node.js environments? In browser-based JavaScript, the global object is the window object, and global variables and functions are attached to it. In Node.js, the global object is named global, but variables declared with the var keyword, let keyword, or const keyword are not attached to it. Rather, they are scoped to the module, or in other words, the file that they are defined in. This difference helps prevent global scope pollution in Node.js, making it easier to manage variables and avoid conflicts. What are the best practices for using global functions and variables in JavaScript to maintain code quality and avoid conflicts? Best practices for using global functions and variables in JavaScript include minimizing their use to avoid polluting the global scope, which can lead to conflicts and difficult to maintain code. Instead, encapsulate variables and functions within local scopes, such as functions or modules, to keep your code organized and reduce the risk of unintended interactions. This approach helps maintain code quality and makes debugging easier. In JavaScript, defining variables or functions directly in the global scope is straightforward, but can lead to complications in larger applications. So let's consider the global scope in browsers. In a browser environment, when you declare a function or a variable using the var keyword at the top level, it is added to the global scope, which means it is accessible through the window object. So for example, if you were to use var say hello and assign this to an anonymous function that logs out hello, you can access it with window.sayHello. So that will successfully call the function. Now, problems with global scope. While convenient, using the global scope can lead to several issues. The first being namespace pollution. The global namespace can become cluttered with too many variables and functions, making it difficult to track down where specific things are defined. The second problem is accidental overriding. If multiple parts of an application inadvertently use the global variable names, they can overwrite each other, leading to bugs that are hard to diagnose. For example, defining say hello in multiple files will cause the last loaded script to override all earlier definitions. So for example, in file 1, if we have var say hello set to an anonymous function, and in file 2, we have a function with the same name. So here, if in file 2, if that is imported after file 1, then when we call say hello, this will always log hello from file 2, regardless of expectations. So the importance of modularity. To mitigate the risks associated with global scope, it's essential to adopt modularity in your development approach. So let's cover modules in Node.js. In Node.js, every file is treated as a module, and anything defined within that file is local to the module unless explicitly exported. This encapsulation ensures that variables and functions do not inadvertently interfere with each other across different parts of an application. The benefit is that it is private by default. Variables and functions are private to their module, providing a clean namespace and preventing accidental interference. And second is explicit exporting. To make a function or variable available outside its module, it must be explicitly exported, adding a layer of control over what is exposed. So for example, in a Node.js file, we define say hello, assign this to an anonymous function, log, and then tab, and we just log out hello. To export it, we use module.exports set to hello. So we have to explicitly export it. So this function can then be accessed in another file by importing it. So we would need to use the require function, and then we can invoke it, which will properly call the imported function. So let's cover the advantages of using modules. The first is clarity. Each module has a clear purpose and scope, reducing complexity and enhancing readability. The second advantage is reusability. Modules can be reused across different parts of an application or even in different projects. The third advantage is maintainability. Changes in a module are localized, impacting fewer parts of an application and thus reducing the risk of bugs. In conclusion, avoiding global variables and embracing modularity is crucial in JavaScript development, especially in larger applications or when working in a team environment. By using modules, developers can ensure their code is organized, maintainable, and less prone to unexpected behaviors caused by namespace pollution. What challenges can arise from using the global scope in JavaScript, especially in larger applications? Using the global scope in JavaScript can lead to several challenges in larger applications, including namespace pollution, where too many global variables and functions make it hard to manage code, and accidental overriding, where different parts of the application unintentionally use the same global names, causing conflicts and bugs that are difficult to track down. This can result in code that is harder to maintain and debug. How does modularity in JavaScript help in maintaining clean and manageable code bases? Modularity in JavaScript helps maintain clean and manageable code bases by encapsulating code into self-contained units, which we refer to as modules. Each module has its own scope, reducing the risk of name collisions and accidental overrides. This makes the code easier to understand, debug, and reuse, as changes in one module are less likely to impact other parts of the application. It also promotes better organization and clarity, leading to more maintainable and scalable applications. So let's go over creating and managing a module in Node.js. In this lesson, we'll go through the process of creating a simple logging module in Node.js. This module will encapsulate all the functionality related to logging messages and can be reused in different parts of your application or even in other applications. So setting up the logger module. So let's create the module file. So here in this directory, which I named loading a module, so right click, and I'll name this logger.js. So second, we will add the functionality. So we want to specify the functionality we want to encapsulate in this file, otherwise referred to as a module, const URL, and assign to http mylogger.io/log. Then we'll define a logging function. We'll name it log. The parameter it will accept will be a message. So in a real scenario, you might send an HTTP request here, but in our case, we're just going to log to the console, and we're going to log this message. Now this function, as well as this constant, is only accessible within this file or within this module, so we want to make the module contents public. So once again, since variables and functions in a Node.js module are private by default, you need to explicitly export any data or functions you want to make available to other parts of your application. So for exporting the functionality, we would use module.exports to make the log function and the constant, right, this URL, available outside the module. So we would do module.exports, and we can name this export log, and assign this to this log function. We also do module.exports.url and set this to URL. Alternatively, you could rename exports to provide a more intuitive interface to module consumers. So rather than naming this URL, we could rename this to be endpoint. So let's cover some best practices for exporting. The first best practice is selective exporting. In real-world applications, modules can contain numerous variables and functions. It's crucial to export only what is necessary to keep the module easy to use and understand. This practice helps maintain a clean public interface. The second best practice is the stability of the public interface. The public interface of a module should be stable and not expose too many implementation details. This approach ensures that changes inside the module do not affect other parts of your application that depend on it. So now let's use the logger module. I'll create a new file in this directory, and I'll just name this index.js. So here we need to import it, so I'll say const logger, but I'll name it. I'll use the require function, and I'll use a relative path to where the logger file or logger module is. And now we can call that. So I'll say logger.log. I'll pass in the argument. This is a message, right? So when we call logger.log, I go back to logger.js. It is calling this function, which we exported. And I'll also log out. So I'll say logger.endpoint, which is this constant that we defined, and we named it endpoint when we exported it. So let's bring up the integrated terminal, and I'll run node index.js, and we get our expected console log output. So in conclusion, by creating modules in Node.js, you encapsulate specific functionalities and expose a controlled interface to the rest of your application. This modularity enhances code reuse, simplifies maintenance, and keeps your application organized. When designing modules, it's essential to consider what should be private to maintain module integrity and what should be public to ensure usability. What are the benefits of encapsulating functionality into modules when developing Node.js applications? Encapsulating functionality into modules in Node.js helps to organize code, making it more manageable and reusable. It allows developers to isolate specific functions or data, reducing the risk of conflicts and making the codebase easier to maintain. Modules also enable better code reuse across different parts of an application or even in other projects, leading to a more modular and scalable development approach. How does careful management of a module's public interface contribute to the maintainability and stability of a Node.js application? Careful management of a module's public interface in Node.js ensures that only necessary functions and variables are exposed, keeping the internal implementation details hidden. This reduces the risk of unintended interference with other parts of the application and makes it easier to update or refactor the module without breaking dependent code. It contributes to the overall maintainability and stability of the application by providing a clear, controlled, and stable interface for other modules to interact with. So let's cover loading modules in Node.js with the require function. Node.js uses the require function to import modules, which is a fundamental aspect of managing dependencies and modularity of your application. This system differs from how scripts are loaded in your browser and is specific to the Node.js environment. So let's cover the basic usage of the require function. When you need to use functionality defined in another file or module, you use require to load it. So here are the steps of how it works. Step 1 is loading a module. So to load a module, you pass the relative path of the JavaScript file to the require function. Node.js resolves the path and loads the module. So for example, you would have const logger. This will be assigned to require, and then you pass in ./logger. So in this case, the logger file is in the same directory, or in other words, the same folder. Node.js automatically assumes .js as the file extension if it's not specified. Second is accessing exported members. The require function returns an object that represents the exported API of the module. This object contains all the members that are exported from the module. So if we were to do console.log and then logger, this would output that function. You can then use these members in your application, like how we did logger.log and passing in the message. Best practices for using require. The first best practice is using the const keyword for requiring modules. It's a best practice to use the const keyword, as this prevents accidental reassignment of the module variable within your code, which can lead to runtime errors. So if we were to import that with const logger, attempting to reassign a constant will result in an error, helping catch mistakes during development. So if we were to assign it, for example, to the number 1, this will throw an error if logger is declared with the const keyword. The second best practice is utilizing tooling for code quality. Tools like JS-Hint can be used to scan your JavaScript code for potential errors and bad practices. Running JS-Hint on your code can help identify issues like improper use of variables before they cause problems at runtime. So in your terminal, you would run JS-Hint and the name of your file. So in this case, app.js. This tool will report problems related to your usage of JavaScript, potentially saving you from bugs that are difficult to diagnose. Exporting a single function. Sometimes you want to export a single function from a module rather than an object. This can simplify the usage of the module where only one functionality is being provided. So if we have our logger function, we can do module.exports and assign that to the log function. So we're exporting just the function. And then when we utilize that in your application file, we import it with const log and utilize the require function, and then we can simply invoke it by just calling log and passing in the message as the argument. In conclusion, the require function in Node.js is essential for modular programming, allowing you to include and use JavaScript files and modules efficiently. By following best practices for module loading and leveraging code quality tools, you can ensure your Node.js applications are robust, maintainable, and error-free. What role does the require function play in managing dependencies and modularity within a Node.js application? The require function in Node.js is crucial for managing dependencies and modularity by allowing you to load and use code from other files or modules within your application. It enables you to break your application into smaller, reusable components, making your code more organized, maintainable, and scalable. By importing only the needed functionality, require helps keep your application structure clear and modular. How can following best practices when using the require function contribute to the maintainability and reliability of a Node.js codebase. Following best practices when using the require function in Node.js, such as using the const keyword for module imports and keeping modules small in focus, helps maintain a clear and consistent code structure. This reduces the risk of errors, makes your code easier to understand, and improves its reliability. It also prevents accidental reassignment of modules and ensures that changes in one part of the code don't unintentionally affect other parts, contributing to a more maintainable and robust codebase. So let's go over how Node.js processes modules. Node.js has a unique way of handling JavaScript code, which differs significantly from how scripts are executed in a browser environment. So let's discuss module wrapping in Node.js. When Node.js executes a module, it does not run the code directly as written. Instead, it wraps the module code inside a function. This approach is not immediately apparent to the developer, but it is fundamental to how Node.js operates. So here's what happens under the hood. First is function wrapping. Each module is wrapped in a function before it is executed. The function wrapper helps to isolate the module from the global scope, which means variables and functions defined in a module do not pollute the global scope. So just to show an example of what this might look like, we'll have, in parentheses, then we define function, exports, then require, module, and we'll discuss this more in detail in this lesson. Just want to demonstrate a visual example of what this will look like. Directory name, then the function block. So if your module code lives here, let me rename this, lives here. So if we were to do, say, const x assigned to hello, then we can log this out. So when we define these two statements, so const x assigned to a string and then logging it out, Node.js will implicitly wrap this module code inside a function. So second is the module wrapper. The function that wraps each module takes several important parameters, which we specified here. So the first is exports. This is used to export module functions and variables. The second is require, a function used to import the exports of another module. The third is module, which represents the current module. Next is the file name, so 2 underscores, and then file name. So this refers to the file name of the module, and then directory name. So third is exporting from modules. You can add properties to exports or module.exports to make them accessible to other modules. Like in our previous example when we did module.exports.log and assign this to the log function, or we can do exports.log assigned to log. However, replacing exports entirely won't affect module.exports because exports is just a reference to module.exports. Using built-in modules. Node.js comes with a variety of built-in modules that provide rich functionalities like file system manipulation, HTTP server creation, and handling system paths. These modules are essential tools for Node.js developers and are thoroughly documented in the Node.js API documentation. So an example of using a built-in module, if we were to do const path, and then we require the path. Let's comment this out. Now we can get the path object. So I'll say path object assigned to path.parse. Then pass in file name. And let's log this out. Path object. Bring up our integrated terminal. We'll run this file. And here it outputs this object showing my current file. So in conclusion, understanding how Node.js executes module code and utilizes function wrapping provides a clearer picture of the runtime environment. This process ensures that global variables and functions from one module do not interfere with another, fostering a more organized and secure coding environment. Furthermore, Node.js built-in modules are powerful tools that extend the functionality of Node applications, enabling developers to handle a wide range of system-level tasks efficiently. How does Node.js module wrapping mechanism contribute to isolating module scope and preventing global namespace pollution. Node.js's module wrapping mechanism isolates each module scope by wrapping the module code in a function. This prevents variables and functions defined in one module from leaking into the global scope, reducing the risk of naming conflicts and ensuring that each module operates independently. This mechanism helps maintain a clean and organized codebase where global namespace pollution is minimized, making the application more secure and easier to manage. What benefits do Node.js built-in modules provide for handling system-level tasks and application development? Node.js's built-in modules provide powerful tools for handling system-level tasks such as file manipulation, network communication, and managing paths. These modules save developers time by offering ready-to-use, optimized functionality that integrates seamlessly with the Node.js runtime. By using these built-in modules, developers can efficiently manage system resources, build robust applications, and avoid the need to reinvent common functionalities, leading to more secure, maintainable, and performant applications. So let's go over retrieving system information with the Node.js OS module. When developing applications that require system-level data, Node.js provides a built-in module called OS, which allows you to gather information about the underlying operating system. So let's cover using the OS module. Step 1 is to import the module. So at the very start of our file, we'll say const, we'll name it OS, require, and the name of it is OS for operating system. So step 2 is to retrieve memory information. So the OS module provides several methods to get system information, such as os.totalMemory and os.freeMemory, which returns the total and free memory of the system, respectively. So we can do that. Const, I'll say total memory, os.totalMem, and then free memory, os.freeMemory. Let's log this out. So I'll say log, and I'll use backticks, say total memory, and then total memory. And then I'll do shift option and down arrow to copy this. And I'll say free memory. And let's just copy and paste it here. So open up the integrated terminal. So that's Command J. So let's run this file with node. And then the name of the file. So here I get the expected output. So this provides insights that are not typically accessible from client-side JavaScript code, which runs in the browser. So in conclusion, the OS module is a powerful tool in Node.js for accessing operating system level information. This can be particularly useful for applications that need to monitor or manage system resources. Using Node.js, developers can write server-side code that interacts directly with the operating system, offering capabilities beyond what is possible in a browser environment. This makes Node.js a great choice for building more complex, system-sensitive backend applications. How can the Node.js OS module be utilized to gather essential system information for applications that require insights into the operating system's resources? The Node.js OS module can be utilized to gather essential system information by providing methods to access details like total and free memory, CPU architecture, network interfaces, and more. This information is crucial for the applications that need to monitor or optimize system resources, especially in server environments where understanding the underlying operating system can help in managing performance and resource allocation effectively. The OS module allows developers to write scripts that interact directly with the operating system, offering insights that go beyond typical client-side capabilities. What advantages does Node.js offer for building resource-sensitive backend applications that need to interact with the operating system directly? Node.js offers several advantages for building resource-sensitive backend applications that need to interact with the OS directly, it provides built-in modules like the OS module, which allows access to system-level information such as memory usage, CPU details, and network interfaces. This direct interaction with the OS enables better monitoring, management, and optimization of system resources. Additionally, Node.js's non-blocking I/O model makes it well-suited for handling multiple tasks efficiently, which is critical in resource-sensitive environments. So let's go over understanding the Node.js file system module. Node.js provides a powerful built-in module called FS for interacting with the file system. This module is essential for reading from and writing to files on the server. So first you would import the FS module. So at the top of your script, you can do const fs require, and the name of it is fs for file system. Now let's discuss the methods in the FS module. So the FS module includes a variety of methods to handle file operations, which comes in two primary forms, the first being synchronous, which is blocking, and asynchronous, which is non-blocking. So for the first form, which is the synchronous methods block the execution of further JavaScript until the file operation completes. They are straightforward to use, but can significantly slow down your application, especially under heavy load. So an example of this could be const files, and then fs.read directory sync. So the pass in the current directory. We could do console.log files. So this will log all files in the current directory. Let's run this in the integrated terminal. So it's node, then the name of this file. So here we see all the files in my current directory. I'll clear this out with Command and J. Now the second form is asynchronous methods. Asynchronous methods, on the other hand, perform operations in the background and accept a callback function that runs once the operation completes. This approach is non-blocking and allows Node.js to handle other tasks while waiting for the file operations to complete. So an example of reading directories asynchronously, below I can do pause, and I'll just say async files, just to give it a different name. So fs.read directory. First argument is the current directory, and then it takes in a callback function. So I'll specify that to be an arrow function. So arr, and then files. So within it, if there is an error, then I will simply console log it. So error, and then else console.log will say the result files. So this will log the files once it's read. So let's comment this out for now. And let's see the output when we do so asynchronously. So once again, we get the same result, outputting all the files in my current directory. So best practices for using FS methods. The first best practice is avoiding synchronous methods in production. While synchronous methods are easy to use and understand, they should generally be avoided in production, especially for I/O-heavy operations. A Node.js process runs on a single thread, and using synchronous methods can block this thread, leading to performance bottlenecks when handling multiple requests. The second best practice is to prefer asynchronous methods. Asynchronous methods allow your Node.js server to remain responsive by freeing up the main thread to handle other requests while waiting for file operations to complete. This approach is crucial for maintaining performance in applications that serve many clients simultaneously. Exploring the documentation. For a complete list of available methods and additional details, visit the official Node.js documentation for the FS module. This documentation provides comprehensive insights and examples for both synchronous and asynchronous methods. In conclusion, understanding and utilizing the FS module and Node.js is crucial for performing file operations effectively. By preferring asynchronous methods, you can ensure that your Node.js applications remain efficient and responsive under load, making full use of Node.js's non-blocking architecture. What are the benefits and drawbacks of using synchronous versus asynchronous methods when performing file operations in Node.js? Synchronous methods in Node.js are easy to implement and use, but they block the execution of further code until the operation completes, which can lead to performance issues, especially under heavy load. Asynchronous methods perform operations in the background without blocking the main thread, allowing the server to handle other tasks simultaneously. This makes them more suitable for production environments, ensuring better performance and responsiveness. The drawback is that they require handling callbacks or promises, which can add complexity to the code. Why is it important to prioritize asynchronous methods for file system operations in production environments when using Node.js? It is important to prioritize asynchronous methods for file system operations and Node.js production environments because they allow the server to remain responsive by freeing up the main thread to handle other tasks. Asynchronous operations prevent the application from being blocked by long-running tasks, which is crucial for maintaining high performance and efficiently serving multiple client requests simultaneously. This helps ensure the application can scale and handle high loads without performance bottlenecks. So let's go over understanding events in Node.js. Node.js is built around an event-driven architecture, primarily using an event loop mechanism, which makes it efficient for I/O-heavy operations. So the core concept of events, in Node.js, an event signifies something that has occurred within the application. For example, when a server receives a request at a port, it's an event. The Node.js runtime handles this event by generating a response. So let's go over using the EventEmitter class. EventEmitter is a core class in Node.js used for handling events within your application. So here's how you can use it. Step 1 would be importing the EventEmitter. So first we need to import the EventEmitter from the events module. So name this EventEmitter, and I'll use Pascal naming convention, the require function, and then events. So step 2 is creating an instance. So EventEmitter is a class, and you must create an instance of this class to use it. So this instance will manage the events for your application. So we'll name our object emitter, use our new keyword to instantiate a new object. So step 3 is registering listeners. Listeners are functions that are called when a specific event is emitted. So use the on method to register a listener for an event. So we'll do emitter, then the method on. So we'll name the event. So this will be message log. Then we pass in a callback function. So I'll use the modern arrow function syntax. And we'll just log out to the console. And I'll say listener call. And save that. So step 4 is emitting events. The emit method is used to trigger an event. When this method is called, all registered listeners for the event are invoked. So we can do emitter.emit, and then we're using the same name of the event for this event to have occurred. So it's important to register listeners before emitting the event, as they will not be triggered retroactively. So let's bring up the integrated terminal, and we'll run this file. So here we see when we emitted this event, it called the event handler, which we passed in as the second argument here. So let's discuss event arguments. Events can also pass data to their listeners, and you can send multiple parameters to the listener function by passing them as additional arguments to emit. So here, we currently have an empty parameter list, but we can specify this to be arg, for example. So let's include that in our console log statement. Say arg. Now when we emit it, we can pass in an object. So I can say the ID is 1, and the URL is stevencodecraft.com. So now this second argument that we pass will be the argument that our event listener or event handler receives. So let's call this again. And here we see we successfully passed data to our event listener. So let's discuss the practical usage. EventEmitter is widely used in Node.js core modules like handling HTTP requests and web servers or reading files asynchronously. Developers can use this pattern to handle custom events in their applications, enhancing the modularity and separation of concerns. In conclusion, the EventEmitter class is a fundamental part of Node.js that helps manage events and listeners, facilitating the event-driven architecture that Node.js is known for. Proper use of this class can help you build robust and maintainable Node.js applications by organizing operations around the handling of various system and custom events. How does Node.js's event-driven architecture enhance the efficiency of handling I/O operations? Node.js's event-driven architecture enhances the efficiency of handling I/O operations by using an event loop to manage multiple tasks without blocking the main thread. When an I/O operation is initiated, Node.js can continue processing other tasks while waiting for the operation to complete. This non-blocking approach allows Node.js to handle many concurrent operations efficiently. Making it ideal for applications that require high performance and scalability in I/O-intensive environments. What role does the EventEmitter class play in managing events and listeners within Node.js applications? The EventEmitter class in Node.js plays a central role in managing events and listeners. It allows you to create and handle custom events within your application. By using EventEmitter, you can define events, register listeners that respond to those events, and emit the events when certain conditions are met. This helps organize your application around an event-driven architecture, enabling more modular, maintainable, and responsive code, especially in applications with asynchronous operations. So let's go over handling data with events in Node.js. When working with the Node.js EventEmitter class, it's common to send additional data about an event. This can help listeners perform their tasks more effectively by providing them with the necessary context. So let's cover emitting events with data. When triggering an event, you can pass data as arguments to the emit method. This data can be accessed by the event listeners. So first we will cover passing multiple arguments. While you can pass multiple arguments separately, it is generally more manageable to encapsulate them in an object, as we did in the previous lesson. So I'm going to make a copy of this, so Shift Option and down arrow. So in the previous example, we passed all the data encapsulated within an object, but we also can just pass them as an argument. So passing in the ID value and the URL. But this is less manageable as it has less context. So we prefer to use an object because the name of the property indicates what this value represents. So it's not just a magic number, right? It has more context. So by passing an object, you can include multiple pieces of data under a single event argument, which makes handling this data and listeners simpler and more organized. Let's clear this out. So now let's cover registering listeners to handle data. Listeners can be set up to receive event data. Here's how to define listeners that handle the data passed to them. So using a function to listen for events, you can define listeners using either traditional function syntax or ES6 arrow functions. Both methods allow you to access the event data passed from the emit call. So in the previous lesson, we used ES6 arrow functions. To copy this, we could also have used traditional function syntax. So remove that arrow, and this will work as well. So in both cases, the argument, right, so this parameter that we specified, also commonly called event args or simply E, represents the data object passed from the emit method. So I'll remove this and we'll stick with the more modern syntax. So let's go over a practical example, which is a custom logging event. So consider a scenario when you want to log custom messages. So you can set up a specific event for logging messages and emit data related to those messages. So we can comment this out since we don't need that right now. Emitter.on, and we'll name this event to be logging. We pass in an arrow function. This accepts parameter of data, and we'll log out. I'll say receive message, and we'll do comma data.message. So now we can emit a logging event with the message data. So emitter.emit. So the name of this event, which is logging, we'll pass in that data object, which has a property of message, and I'll just say hello. So I'll bring up the integrated terminal, Command J, and then the name of this file, we'll run it with Node, and I get the expected console output when we call emit for this event to occur. So here the logging event is configured to pass an object containing a message, and the listener logs this message when the event is emitted. So in conclusion, using EventEmitter in Node.js to handle events with additional data is a powerful pattern for developing modular and responsive applications. By encapsulating data in an object and passing it through events, your application can maintain clear and manageable communication between different parts of your system. This approach not only keeps your code organized, but also enhances its flexibility and scalability. How does passing data through events improve communication and modularity within a Node.js application? Passing data through events in a Node.js application improves communication and modularity by allowing different parts of the application to interact efficiently. It's able to do so without direct dependencies. It enables event listeners to receive relevant data when an event occurs, promoting a clear separation of concerns. This modular approach makes the code more organized, flexible, and easier to maintain as components can respond to events and handle data independently. What are the benefits of encapsulating event data in an object when using the Node.js EventEmitter class? Encapsulating event data in an object when using the Node.js EventEmitter class provides several benefits. It allows you to pass multiple related pieces of data as a single argument, making the event handling code more organized and easier to manage. This approach also enhances readability and scalability, as the object structure can easily be extended to include additional data without altering the function signatures or logic. It simplifies the communication between different parts of the application, ensuring a cleaner and more modular design. So let's go over integrating EventEmitter into custom classes. In real-world applications, it's uncommon to use EventEmitter directly. Instead, you typically extend EventEmitter in a custom class to encapsulate related functionalities along with event handling capabilities. Extending EventEmitter allows you to build self-contained components that can generate events and handle their own functionalities. This is particularly useful for creating modules that need to perform actions and then notify other parts of your application that those actions have completed. So we'll go through the process of creating a logger class that extends EventEmitter to handle logging operations and emit events. So step 1 is defining the logger class. We'll create a new directory, and I'll name this 15 custom class EventEmitter. So in this directory, I will create logger.js. Let's import EventEmitter, which will be the base class, and that is from events. So now we'll define our custom class, which is logger, and we want to extend the functionality because logger is in an event emitter. Extends EventEmitter, so it inherits all of its functionality. So now let's define our log method. The log takes in message as its parameter variable. I'll add a comment here and I'll say logic to log an HTTP request or any message. So then I'll do console.log of the message. Add another comment, so I'll say emitting an event when the log method is called. So I'll say this, so this current object. I'll call emit. Since logger is an event emitter, we inherited this emit method, or to call or invoke an event. This will call the event logged event, and we'll pass in the ID and the URL, which I'll say is stevencodecraft.com, just for example. Now, once again, this class is only available within this file or within this module, so we need to explicitly export it. So I'll say module.exports onto logger. So we're exporting this class. I'll create a new file here. I'll name it app.js, and we want to utilize this logger class we just defined. Let's import it. So logger require It's named Logger. I'll instantiate it. All right, so we're creating a new instance of that Logger class that we defined. I'll add a comment here and I'll say registering a listener for the message logged event. Right, so we need to define this event and listener before we call it. Right, so we named it message logged. So I'll say logger.on message logged. For the second argument, it takes the callback function. So we use the modern ES6 arrow function syntax. Log to the console, and we will log out listener received. It's an argument. And now let's actually call that log function. So I had a comment here. I'll say calling the log method, which will trigger the message logged event. Right, so we're calling this method that we defined here. So I'll say logger.log of, I'll just say hello world. Let's bring up the integrated terminal. Then I'll navigate to this directory that I created. It's 15 custom. And now I'll run node app.js. So here we see it logged out. We'll go to the implementation of this. It logged out the message, which was hello world. And then it logged out what we had in this event listener. So listener received, and then the data that we passed to it. So let's go over the benefits of this approach. The first benefit is encapsulation. The logger class encapsulates both the logging functionality and the event handling, making it modular and easier to manage. The second benefit is reusability. By abstracting the EventEmitter behavior into a class, you can reuse and extend this class wherever needed without rewriting the event handling logic. The third benefit is maintainability. Having a dedicated class for logging and event emission helps maintain and modify logging behavior independently from the rest of your application. Let's go over a common mistake. So a common mistake when starting with EventEmitter is to create multiple instances of the emitter when only one is needed, or to bind listeners to different instances than the emitter that emits the event. This is why encapsulating the event emitter within a class, as shown, ensures that the event listeners are correctly associated with the specific instances of the class that emits the events. In conclusion, by extending event emitter in custom classes like Logger, Node.js applications can handle complex functionalities while efficiently communicating events across different modules. This pattern enhances the modular architecture of the application, promoting clean and manageable code that adheres to modern software design principles. What are the advantages of integrating the EventEmitter class into custom classes when building modular components in Node.js? Integrating the EventEmitter class into custom classes in Node.js allows you to build modular components that can handle specific tasks and emit events related to those tasks. This approach encapsulates functionality and event management within a single class, making the code more organized, reusable, and easier to maintain. It ensures that event handling is tightly coupled with the relevant functionality, improving the overall architecture and communication between different parts of the application. How does extending EventEmitter in custom classes enhance the reusability and maintainability of Node.js applications? Extending EventEmitter in custom classes enhances reusability and maintainability by encapsulating both functionality and event management into a single, self-contained module. This allows the class to be easily reused across different parts of an application or in other projects without duplicating code. It also simplifies maintenance because the logic for emitting and handling events is centralized, making it easier to update or modify without affecting the rest of the application. So let's cover creating a web server with Node.js. Node.js provides the HTTP module, a powerful tool for developing networking applications, such as web servers that listen for HTTP requests on a specified port. let's cover the basic web server setup. So the first step is to import the HTTP module. The HTTP module includes the functionality necessary to create server instances. So we can do const HTTP require HTTP. So the second step is to create a server. Use the create server method to create a new server. This server can handle HTTP requests and responses. We do const server assign to HTTP create server. Step 3 is listening to events. The server object created by HTTP create server is an instance of EventEmitter. This means you can listen to events like connection for lower level network events. We could do server.on the event of connection, and we'll pass in our callback. So the parameter will be socket, and we're using our modern ES6 arrow function syntax, ended with a semicolon. And for now, we'll just log to the console, new connection, and save that. So step 4 is starting the server. We'll have the server listen on a port, such as 3001, to handle incoming requests. So we could do server.listen at 3001, and we'll log out to the console, listening on port 3001. So now let's run this in an integrated terminal. So here we see it's listing on port 3001. If we navigate to our web browser, so now if I navigate to localhost 3001, let's resize this. Back in VS Code, we see it says new connection, which is this console log statement here. Close this out, and Control C to stop this program. So handling HTTP requests more efficiently. While the above method works for simple demonstrations, handling HTTP requests based on different routes can be done more effectively. So step 5 would be refining the server to handle requests. Instead of listening to the connection event, you can directly handle HTTP requests by providing a callback to create server that deals with requests and responses. So here, where we called create server, we pass in the callback function, so the request and the response, using our arrow function syntax. So if the request URL is at the index, right, so just a /, we can do response.write hello world, and we will end the response. Otherwise, we can say if request URL is at API courses, we can say response.write json.stringify. We'll just say an array of 1, 2, and 3, and response.end. So let's run this again. Up arrow, run. So once again, it's listening on that port. We can navigate to it. I'll say localhost 3001. And here we see hello world as specified when we did response.write. Now if we navigate to this path, we'll add this to the end. And here we see this array that we specified here. So this setup directly responds to HTTP GET requests at the root with the /, as well as at API /courses, which sends a JSON response, in this case, an array. Let's close this with Control C, close it out. So using Express for complex applications. For more complex web applications, managing routes with the native HTTP module becomes cumbersome. This is where Express, a web application framework built on top of the HTTP module, comes in handy. So let's discuss the advantages of Express. The first being simplification of routing. Express provides a much cleaner and organized way to handle different HTTP routes with minimal effort. The second advantage is middleware support. Express allows you to use middleware to respond to HTTP requests, handle errors, and process data. And third is enhanced server capabilities. While Express uses the underlying HTTP module, it simplifies many tasks and adds powerful new features. Now to discuss what an example of this might look like, you need to utilize the Express npm module and create a package.json file. After you import Express, you can create an instance of it by calling Express. Then you can define the GET request for both the root path as well as the API/courses path. So in conclusion, starting with Node.js's HTTP module is great for learning the basics of network communications in JavaScript. However, for building more sophisticated applications, such as a framework like Express, can greatly simplify your code and enhance your server's functionality, making it easier to maintain and expand. What are the benefits of using the Node.js HTTP module to create a basic web server, and when might you consider using a framework like Express instead? Using the Node.js HTTP module to create a basic web server is beneficial for learning the fundamentals of network communication and handling HTTP requests directly. It offers full control over the server's behavior with minimal overhead. However, for more complex applications, a framework like Express is preferable because it simplifies routing, supports middleware, and adds powerful features, making the development process faster, more organized, and easier to maintain as the application grows. How does the event-driven nature of Node.js influence the design and functionality of a web server created with the HTTP module? The event-driven nature of Node.js influences the design and functionality of a web server by allowing it to handle multiple requests concurrently without blocking the main thread. This non-blocking I/O model ensures that the server can efficiently manage incoming connections and process requests as events, responding to them asynchronously. This design is particularly well suited for high-performance applications, where the server needs to remain responsive and scalable even under heavy load. So let's summarize what we covered for the Node module system. First, we covered an introduction to Node.js. This part of the course provides a foundational understanding of what Node.js is and the benefits of using it. Then we covered Node.js's architecture. We explained the internal architecture of Node.js, including its non-blocking, event-driven nature that allows for high performance across real-world applications. We did a deep dive into Node.js functionalities, where we covered how Node works. So we learned more about the underlying mechanisms that power Node.js, such as the event loop and asynchronous programming. We covered an introduction to the Node module system, where we discussed the modular structure of Node.js applications, emphasizing how modularity is achieved and managed. We covered working with Node.js modules, which includes global objects. So this covers built-in global objects in Node.js, which are accessible across all modules. We covered modules, and focused on the importance of modules in Node.js for organizing and maintaining code. We went through creating and loading modules, and we covered practical guidance on how to create your own modules and how to import existing ones. Module wrapper function. This section covered how Node.js wraps module code within a function to maintain module scope and privacy. Then we went through and covered specific Node.js modules, starting with the path module. So this introduces utilities for handling and transforming file paths, the OS module, which provides information about the computer's operating system, where the Node.js application is running, the file system module. So this demonstrated how to work with the file system for reading from and writing to files, and the events module. So we discussed the EventEmitter class and how to handle custom events and applications. We went through more advanced topics by covering event arguments, which detailed how to pass and handle data with events using the EventEmitter. Then we extended the EventEmitter, where we learned how we can enhance and customize the EventEmitter for more complex event handling scenarios. Lastly, we covered the HTTP module. So this outlined how to use Node.js to create web servers and handle HTTP requests effectively. In conclusion, this section covered the fundamentals of how to use Node.js and its module system for building scalable and efficient applications. By understanding and utilizing the core modules and architectural principles of Node.js, developers can create robust backend services and applications suited for a variety of real-world tasks. In Node.js development, managing third-party libraries and modules is facilitated by package managers. The two primary package managers used in the Node.js ecosystem are NPM, which stands for Node Package Manager, and Yarn. So first let's go over understanding NPM. NPM is not only a package manager, but also a registry that hosts a vast collection of free, open-source libraries. These libraries can be easily integrated into your Node.js projects to add new functionalities. Let's go over NPM basics. The registry. Visit npmjs.com to explore a wide range of packages available for various functionalities. These packages are open source and free to use. Installation. npm comes bundled with Node.js, so when you install Node.js, you automatically get npm installed on your system. To check the version of npm that you have installed on your system, from the command line you can run npm-v. So currently I have 10.8.2 installed on my system. Now to update npm, and to ensure that you have the latest features and security patches, you can update npm to a specific version globally using the following command. So here I'm using a Mac, so I'll use the command sudo npm install, then the flag -g, npm at latest. I'll enter in my password, and this will update it so I use the latest version. Now we use npm to install open source packages. To add a package to your project, you would use the command npm install and then the name of the package. So let's discuss global versus local installation. By default, npm installs packages locally within your project. However, some tools need to be available globally to be run from anywhere on your system. So you would do that with npm install, then use the flag -g, and then the package name. Introduction to Yarn. Yarn is another popular package manager that could be used as an alternative to npm. It was created by Facebook and is known for its speed, reliability, and improved network performance. Installing Yarn. Unlike npm, Yarn is not bundled with Node.js and must be installed separately. You can install Yarn globally using npm. So the command to install it is npm install -g, and then the package name, which is Yarn. Using Yarn. Let's cover how you can add a package with Yarn. Similar to npm, you can add packages to your project with the command yarn add and then the name of the package. Why use Yarn? Yarn caches every package it downloads, so it never needs to download the same package again. It also parallelizes operations to maximize resource utilization and thus install packages faster. Publishing your own package. If you've developed a functionality that could benefit others, you can publish your own packages to npm, making it available to the global Node.js community. So first you would prepare your package, so ensure that your package is well documented, has a clear README file, and includes all necessary metadata in your package.json file. Step 2 is publishing, so you would run the commands npm login. After you log in with your credentials, then you would run the command npm publish. In conclusion, npm and Yarn are essential tools for any Node.js developer. They simplify the process of integrating third-party libraries into your projects, manage dependencies effectively, and helps you contribute back to the community by publishing your own packages. Whether you choose npm or Yarn depends on your specific needs and preferences, as both provide robust features to streamline development workflows. What are the key differences between npm and Yarn in terms of speed, reliability, and package management features? The key differences between npm and Yarn are speed, reliability, and package management. So when covering speed, Yarn generally installs packages faster than npm because it parallelizes operations and caches packages locally, reducing the need for repeated downloads. For reliability, Yarn ensures consistency by using a lock file, which is named yarn.lock, to keep track of exact package versions, which helps avoid version mismatches. So when considering package management, Yarn offers better offline support and more efficient dependency resolution, while npm is more integrated with the Node.js ecosystem and its package registry. How do package managers like npm and Yarn contribute to efficient dependency management and Node.js projects? Package managers like npm and Yarn contribute to efficient dependency management and Node.js projects by automating the process of installing, updating, and organizing third-party libraries. They manage versioning to ensure compatibility, handle dependency trees to prevent conflicts, and streamline workflows through commands for adding, removing, and updating packages. Both tools also maintain log files to ensure consistent environments across different development setups, making it easier to collaborate and maintain project stability. So let's cover setting up a Node.js project with npm. When starting a new Node.js project, One of the first steps is to set up a package.json file. This file contains metadata about your project and manages the project's dependencies. So let's go over creating a new project directory. I'll open up the integrated terminal. Let's expand this. And we'll create a new directory. So mkdir. And I'll name the directory npm-demo. We'll change into that new directory. Now we will initialize our package.json file. So before adding any node packages to your project, you need to create a package.json file. This file will track your project's dependencies and store other important project information. We'll create this file by using the command npm init. So npm initialize. So this command will prompt you to enter several pieces of information such as the project's name, the version, description, the entry point, such as an index.js file, the test command, repository, keywords, author, and license. So these details help define and document your project. So I'll just say enter. So the project name will be npm demo. The version is 1.0. The description, I'll say lesson on node package manager. Entry point, index.js file. Test command, I'll just say enter. Author, I'll say Steven Garcia. License, and I'll say yes. So now, if we list out, we see it has created our package.json file. So let's view this. I expand here. In npm demo. This is the package.json file that it created for us. Now let's cover automating package.json creation. If you prefer to skip the manual input and use default values for your package.json, you can use the -- yes flag. So previously we just did npm init, but instead you can do npm init -- yes. So this command automatically fills in default values for all the fields in the package.json file, speeding up the setup process. So let's cover the importance of the package.json file. The first is project metadata. The package.json file holds key information about your project, which can be useful for package management and during deployment. So let's discuss dependency management. It lists all the packages your project depends on, allowing npm to automatically install and manage these packages for you. Script shortcuts. You can define scripts in package.json that you can run with npm. This is useful for tasks like starting the server, running tests, or custom build processes. Best practices. One best practice is regular updates. Keep your package.json file updated as you add or remove dependencies, update scripts, or change project metadata. Version control. Include package.json in your version control system, such as Git version control, to ensure that team members and deployment environments use the correct project settings and dependencies. In conclusion, the package.json file is a fundamental component of any Node.js project, serving as the blueprint for managing the project settings and dependencies. By starting your project with the creation of this file, you ensure that all dependencies are correctly tracked and that your project metadata is well documented from the beginning. This initial setup is crucial for maintaining a healthy, manageable codebase as your project grows. Why is the package.json file crucial for managing dependencies and project metadata in a Node.js project? The package.json file is crucial in a Node.js project because it serves as the central hub for managing project dependencies, scripts, and metadata. It tracks all the libraries your project relies on, ensuring consistent installation across different environments. Additionally, it stores important project information such as the version, author, and licensing details, and provides scripts for common tasks, making the project easier to manage, share, and deploy. This file is essential for maintaining an organized and efficient codebase. How does initializing a Node.js project with npm init contribute to better organization and maintainability of the project's codebase? Initializing a Node.js project with npm init contributes to better organization and maintainability by creating a package.json file that centralizes project metadata and dependency management. This file keeps track of all libraries and modules the project depends on, ensuring consistent setups across different environments. It also allows you to define scripts for common tasks, making your workflow more efficient and the project easier to manage as it grows. This structured approach prompts a well-organized and maintainable codebase from the start. Adding a third-party library to your Node.js application. Integrating third-party libraries into your Node.js project can enhance functionality without the need to write additional code. Libraries, such as underscore, provide a range of utilities for common programming tasks. So step 1 is choosing a library. So begin by choosing a library that suits your needs. For instance, underscore is a popular JavaScript library that offers helpful functional programming utilities. You can search for underscore or other libraries on npmjs.com, which also provides installation instructions and documentation for each package. So step 2 is installing the library. To add a library like underscore to your project, use the npm install command. This command downloads the library from the npm registry and adds it to your project. So let's open up the integrated terminal with Command J. We can run npm install underscore. Alternatively, you can use the shortcut npm I underscore. When you install a package using npm, two important things happen. The first is an update to your package.json file. So here, when we install underscore, it is added within the Dependencies object. This entry ensures that anyone else working with your project repository can install the same dependencies. And the second is library storage. The library files are downloaded and stored in the Node Modules directory within your project. So here we see us created a Node Modules directory, which contains our dependencies. So step 3 is using the library in your application. So after installation, you can require and use the library in your application files. So let's create a new file in our npm demo directory, and we'll name it index.js, as that is the entry point of our application. Let's close the sidebar. Now we can utilize the underscore library. So I'll say require an underscore. So by convention, we use the underscore when using this library. Now we can say const is even underscore and then the method sum. So I'll pass in an array 1, 2, 3, 4, and 5. And for the second argument, I'll pass in a callback, so a number. If the number is divisible by 2, then we'll log out. Let me rename this to be is even. Then I'll log out is even. So this method .sum checks if at least one of the elements is even. Let's run this. So I'll say node index.js. And here I see the output of true. So in conclusion, adding third-party libraries like underscore to your Node.js projects streamlines development by allowing you to utilize pre-built functionalities. This practice not only saves time, but also enhances the capabilities of your application. Always ensure to use well-maintained and trusted libraries, manage your dependencies through package.json, keep your projects organized and maintainable. What are the key considerations when selecting and integrating third-party libraries into a Node.js project? When selecting and integrating third-party libraries into a Node.js project, key considerations include ensuring the library is well-maintained and widely used, which indicates reliability and community support. Check for compatibility with your project's Node.js version and evaluate the library's documentation and features to ensure it meets your specific needs. Also consider the potential impact on your project's performance and security. Properly manage these dependencies in your package.json file to maintain an organized and maintainable codebase. How does managing dependencies through npm enhance the organization and maintainability of a Node.js application? Managing dependencies through npm enhances the organization and maintainability of a Node.js application by automatically tracking all required libraries in the package.json file. This ensures that all dependencies are documented and can be easily installed or updated by other developers or in different environments. npm also handles versioning, preventing conflicts and ensuring consistent environments across different setups. This structured approach helps keep the project organized and simplifies dependency management, making the application easier to maintain over time. Using third-party libraries like Underscore can significantly streamline complex operations in Node.js applications. So in our index.js file, we imported our Underscore library. So it's common to use the underscore symbol as the variable name for this particular library. So the require function follows these steps to locate the underscore module. It first checks if underscore is a core Node.js module. Failing that, it looks for underscore as a relative or absolute path in the project. Lastly, it searches within the node modules directory. So the underscore library provides a wide range of utility functions that are highly useful for working with collections, arrays, and objects. For example, to check if an array contains a specific item, you can use the contains function. So here, I can comment this out. So command and /. So I can say const does contain underscore dot contains. So for the first argument, I'll pass an array containing 1, 2, and 3. And for the second argument, I'll pass the value 2. And let's log out the result. Does contain. So we'll do up arrow and run. And here we see the value true. Let's say if I were to change this to be the value 4, then we would see that it does not contain the value of 4. To better understand all available functions and their uses in the underscore library, visit the documentation. So when viewing this particular library on npm.js, here when it says homepage, you can view the documentation for the library that you installed. So this can provide insights into additional methods and their potential applications. In conclusion, using libraries like underscore in Node.js projects helps to reduce the amount of code you need to write while increasing functionality and readability. It is essential for developers to familiarize themselves with importing modules and understanding the path resolution mechanisms of Node.js to effectively manage and utilize various libraries. This practice ensures your applications are both efficient and scalable. What are the benefits of using third-party libraries like underscore in Node.js projects, and how can they enhance the efficiency of your code? Using third-party libraries like underscore in Node.js projects provides ready-made utility functions that simplify complex tasks, reducing the amount of code you need to write. This enhances code efficiency, readability, and maintainability. By leveraging well-tested functions from libraries, you can focus more on building unique features rather than reinventing common functionalities, leading to faster development and more robust applications. How does understanding Node.js's module resolution process help in effectively managing and integrating external libraries into a project? Understanding Node.js's module resolution process helps in effectively managing and integrating external libraries, ensuring that you know how Node.js locates and loads modules. This knowledge allows you to correctly structure your project, avoid conflicts, and troubleshoot issues related to module paths. It also ensures that the right version of dependencies are used, which is crucial for maintaining a stable and predictable development environment. This leads to smoother integration of external libraries and more reliable application behavior. When developing applications with Node.js, managing external libraries and dependencies is commonly handled using npm, which stands for Node Package Manager. So here's how you can install a package like Axios, which is widely used for making HTTP requests to APIs. So we'll open up our integrated terminal. Let's clear this out. We'll use npm and then I for install, and then the name of the package, which is Axios. So this command fetches the package from the npm registry and installs it into your project. You can view our package.json file. And here we see Axios is now included in the dependencies object. If we view our node modules, we also see that Axios has been installed here. So you'll notice that it contains not only Axios, but also several other directories. These are dependencies that Axios requires to function properly. So we can close this directory and navigate back to our index.js file. So let's discuss dependency management. So when considering the file structure, in the past, npm used a nested structure where each package would have its own node modules directory containing its dependencies. This often led to duplication and a deeply nested directory structure, which would cause path length issues, especially on Windows. So for the current approach, now npm installs all dependencies in a flat structure in the root node modules directory of your project. This change helps avoid redundancy and the complications of deeply nested dependencies. Handling version conflicts. If different packages require different versions of the same dependency, npm will nest the conflicting version locally within the requiring packages directory to avoid version clashes at the root level. So let's discuss the benefits of the current approach. The first being simplification. The flat structure simplifies dependency management by reducing redundancy and the potential for version conflicts across your project. The second benefit is efficiency. It minimizes disk space usage and improves installation speed since npm no longer needs to install multiple instances of the same package across different locations. The third benefit is compatibility. It reduces issues related to file path limits on certain operating systems, which is particularly beneficial for Windows users. So let's go over a practical example with the Axios library. So now that we installed it, we can start using it in our Node.js application to make HTTP requests. So here's a simple example to include Axios in our project. So we can do const Axios, use our require function. The name of it is Axios. Let me close the sidebar. So we can do axios.get for making a HTTP GET request. And we'll make a request to an open source URL. So HTTPS JSON placeholder dot typecode.com /todos/1. Then we'll do .then because it returns a promise, which we will cover in the next section. So response, then we want to log this out, response.data. We'll also include or chain catch for handling if any error occurs. So we will log out the error, console.error, error.message. And we'll end that with a semicolon. Also, we need to add another parenthesis here to get rid of those errors. So let's run this with node index.js. And here we see the data that we retrieved from this backend endpoint. So this object contains a user ID, an ID, a title, and a property of whether it is completed or not for this to-do item. So in conclusion, installing and managing node packages with npm is a straightforward process that enhances the functionality of your applications. Understanding how npm handles dependencies allows you to better organize and optimize your projects. By using tools like Axios, developers can easily make HTTP requests in their applications, making the development process more efficient. What are the advantages of npm's flat dependency structure in modern Node.js projects, particularly in terms of efficiency and compatibility? npm's flat dependency structure improves efficiency by reducing redundancy, as it avoids multiple copies of the same package being installed in different locations. This structure also minimizes disk space usage and speeds up installation times. In terms of compatibility, it reduces the likelihood of path length issues, especially on Windows, and simplifies dependency management by making the directory structure less complex and easier to navigate. This approach leads to a more streamlined and manageable project setup. How does understanding npm's dependency management process benefit developers when integrating external packages like Axios into a Node.js application? Understanding npm's dependency management process benefits developers by ensuring that they can effectively handle and resolve potential conflicts between different versions of packages required by their Node.js application. It helps maintain a clean and organized project structure, preventing issues like redundant installations or version mismatches. This knowledge is crucial when integrating external packages like Axios, as it ensures smooth installation, compatibility, and optimal performance of the application, leading to a more reliable and maintainable codebase. So So first let's discuss the role of Node Modules. So its role is the storage of dependencies. So let's go over managing Node Modules in Node.js projects. When working with Node.js, the Node Modules directory can become quite large because it contains all the packages you've installed using npm along with their dependencies. Here's how to efficiently handle this directory, especially in collaborative environments. So Node Modules holds all the packages that your application needs to run, which are installed based on the list of dependencies found in your package.json file. So why exclude Node Modules from version control? So when working with applications, we use Git version control in order to manage our project as well as collaborate with other developers. Now we want to exclude the Node Modules directory when working with version control. The first reason being is size considerations. This folder can become quite large and grow to hundreds of megabytes or more due to the nested dependencies typical in Node.js projects. Including it in version control would significantly increase the size of your repository and slow down operations like cloning and pulling changes. The second reason is reproducibility. So every dependency and its exact version is already specified in our package.json file. So here if I view that. So this means that Node Modules can be recreated on any machine by running npm install. So there's no need to include it in version control. So let's discuss the steps to exclude Node Modules. So we want to exclude the Node Modules when using Git version control, and this is essential for keeping our repository clean and lightweight. So I'll open up the integrated terminal with CommonJS. So in this course, I won't cover Git version control in depth. I'll just provide a quick explanation of how you can exclude Node Modules. So we can initialize Git in our current project. So I'll say git init. So this initializes a new Git repository, so we can now use version control to manage our project. We can do git status, and we can view all the files in our project. Now we want to create a .gitignore file. So this file tells Git which files or directories to ignore in your projects. So I'll create that here. I'll say touch.gitignore. So let me close this with Command J, and we'll view this file which is created. So this is a hidden file, and that's why I prefix it with a period. So we want to add the following line, and this will specify that the Node Modules directory should not be tracked by Git. So I'll say Node Modules, and then / indicating the directory. So we save this. So now, when we run git status to see what files are in our project, here it doesn't include the Node Modules directory. So we can now add and commit our changes. So we will add our changes to the staging area. So we'll say git add and then period, meaning all files. Let's do git status again. And here we see our project files are now staged and ready to be committed. So we can do git commit -message, and I'll name it initial commit. So now these files are being tracked, and I can collaborate with other developers who also have access to this project and are using Git version control. So let's discuss restoring Node Modules. If you clone the project or need to restore dependencies, simply run npm install in your command line. So this command looks at your package.json file and installs all the necessary packages from the npm registry. So in conclusion, excluding Node Modules from version control is a best practice in Node.js development. It keeps your project repository manageable, speeds up operations like cloning, and ensures that all developers are working with the same dependencies as defined in package.json. So this approach fosters a clean, more efficient development environment. Why is it important to exclude the Node Modules directory from version control, and how does it benefit the management of a Node.js project? It is important to exclude the Node Modules directory from version control because it significantly reduces the size of the repository, making operations like cloning and pulling changes faster. The Node Modules can be recreated at any time by running npm install, which installs all necessary dependencies based on the package.json file. This approach ensures that everyone on the project works with these same dependencies while keeping the repository clean and efficient to manage. What are the best practices for managing dependencies and restoring them in a Node.js project, particularly in a collaborative environment? Best practices for managing dependencies in a Node.js project include using a package.json file to track all dependencies and their versions. This ensures consistency across different environments. In collaborative environments, it's crucial to exclude the Node modules directory from version control to keep the repository lightweight and avoid unnecessary duplication. To restore dependencies, use the npm install command, which installs everything listed in package.json, ensuring all team members work with the same setup, reducing the risk of conflicts or errors. So let's cover understanding semantic versioning in Node.js. Semantic versioning is a standard for versioning software which is widely adopted in the development community, including Node.js packages. It helps developers understand the potential impact of updating a package. So let's discuss the components of semantic versioning. A typical version number format includes 3 components, the first being the major version, the minor version, and a patch version. So for the major version, this indicates significant changes that make API changes which are not backwards compatible. Upgrading to a different major version could break existing functionalities. So for the minor version, this adds new features in a backwards compatible manner. It does not break or change existing functionality, but adds to it. And for the patch number, this includes bug fixes and minor changes that do not affect the software's functionality or API. So it's also backwards compatible. So for example, for the Axios package that we installed, 1 is the major version, 7 is the minor version, and 5 is the patch version. Let's discuss the caret and the tilde in versioning. So here we see the semantic versioning number is prefix with a caret. So when you see a caret in front of a version number in package.json, it means npm can install updates that do not modify the leftmost non-zero digit in the semantic versioning string. So here for this particular example, when considering Axios, since it is prefixed with a caret, it can install any version as long as the major version does not update, even if the minor or patch version is higher than specified in our package.json file. Now you may also see a tilde symbol. So a tilde allows updates that only change the most right-hand digit that is not 0 in the semantic versioning string, assuming that the most right-hand digit is the patch version. So for example, if the version was 1.13.6, npm can update to 1.13.x, where x is any patch number greater than 6. This means you get bug fixes and minor changes that are unlikely to break your project. So we can discuss installing packages with npm. So when someone clones a repository and runs npm install, npm installs the dependencies based on the rules set in the package.json file using the caret symbol or tilde operator. This allows for a controlled upgrade path that balances stability with getting timely patches and features, specifying exact versions. In some cases, especially when ensuring absolute consistency across environments or dealing with very sensitive dependencies, you might want to pin dependencies to an exact version. To do this, you can specify the version without any prefix. So this configuration guarantees that no version larger than the semantic version number specified will be installed, avoiding any issues due to minor updates or patches. In conclusion, understanding how semantic versioning works with npm helps manage dependencies more effectively, ensuring that applications remain stable while still receiving necessary updates and bug fixes. It allows developers to control the risks associated with automatically updating packages and ensures that all team members and production environments run the same versions of each package. How does semantic versioning help developers manage dependencies and ensure stability in Node.js projects? Semantic versioning helps developers manage dependencies by clearly indicating the impact of updates through version numbers. It uses 3 components, a major, minor, and patch, to signal the type of changes made. Major versions indicate breaking changes, minor versions add new features without breaking existing functionality, and patch versions include backward compatible bug fixes. This system ensures that developers can update packages safely, maintaining stability, while still receiving important updates and fixes, reducing the risk of unexpected issues in your project. What are the implications of using the caret symbol or tilde operator in versioning when managing package updates in Node.js? Using the caret in versioning allows updates to minor and patch versions while keeping the major version stable, ensuring backwards compatibility. The tilde operator restricts updates to only patch versions, keeping both major and minor versions fixed. These operators help manage package updates by allowing controlled upgrades. The caret symbol offers more flexibility by permitting minor updates, while the tilde operator provides stricter control, reducing the risk of breaking changes. This helps maintain stability while still applying necessary updates. So let's discuss checking installed versions of a Node.js package. So when managing a Node.js project, it's essential to keep track of the versions of packages installed to ensure compatibility and stability. So here's how you can determine the versions of the packages you have installed. So, viewing installed versions, the first thing you could do is manual checking. Sometimes you may want to manually check the version of a specific package installed in your project. This can be done by looking at the package.json file within each package's directory and node modules. So if I were to expand node modules and view Axios, and then package.json, I see that the exact version installed is 1.7.5. So if I close this, navigate back to our package.json. So the second way that you can check your installed version is using npm commands. So this is a more efficient way to view all installed packages and their versions by using the npm list command. So this displays the tree of packages installed in your project. Running this command in your project directory will show you a tree structure of all packages, including their dependent packages. So let's open up the integrated terminal and we'll run npm list. So this is a small project, so we see our 2 npm packages that we have installed. However, this output can be extensive because it includes all nested dependencies, in the case when we are considering a large production application. So the third way that we can check the version that we have installed is by running npm list and then depth set to 0. So if you're only interested in the top level packages, so those directly specified in your project's package.json, you can simplify the output using the depth set to 0 option. So this command restricts the output to the first level of the dependency tree, showing only the packages that you have directly installed in your project. So why this matters? The first reason why this matters is compatibility. Knowing the exact versions of the packages you have installed helps manage compatibility between different parts of your application and its dependencies. The second reason is debugging. When troubleshooting issues in your application, knowing the exact versions can help determine if a specific version of a package might be causing the problem. The third reason is updates and upgrades. Regularly checking installed package versions can help you decide when to upgrade to a newer version and take advantage of new features or important bug fixes. In conclusion, effectively managing package versions in a Node.js project is crucial for maintaining the stability and reliability of your applications. Using tools like npm list helps streamline this process by providing a clear overview of what is installed, thus enabling better version control and dependency management. By routinely checking and upgrading your dependencies, you can ensure your application remains secure, efficient, and up to date. Why is it important to regularly check the versions of installed Node.js packages in a project? Regularly checking the versions of installed Node.js packages is important to ensure compatibility and stability in your project. It helps you identify potential issues caused by outdated or conflicting dependencies and allows you to take advantage of security patches, bug fixes, and new features. Keeping track of package versions also aids in debugging, as knowing the exact versions can help pinpoint problems related to specific updates or changes in the package ecosystem. This practice contributes to maintaining a reliable and secure application. How can using npm commands help streamline the process of managing and verifying package versions in a Node.js project? Using npm commands streamlines managing and verifying package versions by providing quick and detailed insights into the installed dependencies. Commands like npm list display all installed packages and their versions, while options like the depth set to 0 focus on top-level dependencies, making it easier to track and manage them. This approach helps ensure your project remains stable and up to date by allowing you to easily monitor and update packages as needed, all from the command line. When working with NPM packages, it is often necessary to understand their dependencies, versions, and other metadata to ensure they fit well within your project. So let's go over viewing package metadata on npmjs.com. So here on the NPM official website, search for a package you're interested in, such as Axios. So in this input field, I'll look up Axios. We'll click on the official package. So on the package page, you will see comprehensive details including the latest version, the licensing, the GitHub repository, the number of weekly downloads, and the package dependencies. So using npm commands to view package information. For a more direct and detailed exploration of a package metadata, you can use npm commands. So open up the integrated terminal with Command J. Move this up. So to see a summary of metadata for a package directly in your command line, you can use the npm view command. So I'll do npm view and then the name of the package. So in this case, it's Axios. So this command, let's move this up. So this command outputs information such as the latest version, a description of the package, the main entry point, the repository, keywords, the author, the license. Now let's go over viewing dependencies. If you're specifically interested in what dependencies a package has, you can directly view that information by typing in npm view, the name of the package, so Axios, and then dependencies. So this will list the dependencies required by Axios, showing you what packages it relies on to function. So checking available versions. To view all versions of a package that have been published to npm, you can use npm view, the name of the package, and then versions. So this is particularly useful if you need to upgrade or downgrade to a specific version. It lists every version available, helping you make informed decisions based on the features or fixes included in each. So a practical usage of package information. The first practical usage is for making upgrades. Knowing the version and dependencies can help you decide whether to upgrade a package. You can assess the changes between versions and determine if the upgrade addresses any issues you face or offers new features you need. Compatibility checks. Viewing dependencies ensures that the package is compatible with other components of your application, especially if there are specific versions of dependencies that your application requires. Debugging and issue resolution. Detailed metadata can assist in debugging issues related to package configurations or interactions between multiple packages. In conclusion, understanding how to retrieve and utilize metadata about npm packages is essential for effective package management in Node.js projects. Whether it's through browsing npmjs.com for a high-level overview or diving deep with npm view commands for specific details, these tools provide critical insights that help maintain the health and functionality of your application. Why is it important to regularly check the dependencies and versions of npm packages in a Node.js project, and how can this practice impact the stability and compatibility of the application? Regularly checking the dependencies and versions of npm packages in a Node.js project is crucial for maintaining stability and compatibility. It ensures that all packages work well together, preventing conflicts that could arise from incompatible versions. This practice also helps identify when updates or security patches are needed, reducing the risk of bugs or vulnerabilities. By staying on top of package versions, developers can keep the application reliable and ensure it runs smoothly across different environments. When developing applications, you might occasionally need to install a version of a package that isn't the latest due to compatibility issues, specific features, or other dependencies in your project. This can be accomplished easily using npm commands. Specifying package versions. To install a specific version of a package, append the version number to the package name using the @ symbol. For example, to install a version 1.7.3 of Axios, you would do npm install Axios, then the @ symbol 1.7.3. So this command tells npm to fetch and install the exact version of Axios from the npm registry. So verifying installation. After installing the package, it's a good practice to verify that the correct versions have been installed. You can use the npm list and then the flag --depth set to 0 command to check the versions of the top level packages installed in your project. So we could do npm list --depth and set that to 0. So this command provides a list of all packages directly installed in your project, ignoring their dependencies, and specifies their version numbers. It allows you to quickly verify that the correct versions are installed. So why specify versions? The first reason is compatibility. Certain projects or dependencies might require specific versions to maintain compatibility. Breaking changes in newer versions could disrupt the functionality of your application. The second reason is bug fixes. Some versions might include bug fixes not present in newer versions, or new versions might introduce bugs that were not present in previous versions. And the third reason is for features. Older versions might have features that have been deprecated in the latest release but are still necessary for your project. In conclusion, understanding how to specify and install particular versions of packages with npm is crucial for precise dependency management in software development. This practice helps ensure that your application remains stable and behaves as expected, regardless of changes and updates in the package ecosystem. By specifying package versions, you maintain control over your development environment and reduce the risk of unexpected issues. Why might a developer need to install a specific version of an npm package, and how does this practice contribute to project stability? A developer might need to install a specific version of an npm package to ensure compatibility with other dependencies, maintain access to certain features, or avoid bugs introduced in newer versions. By specifying and controlling the exact version, the developer can stabilize the project, ensuring that updates or changes in the package ecosystem don't unexpectedly break the application or alter its behavior. This practice helps maintain a consistent and reliable development environment across different setups. What are the benefits of verifying installed npm package versions after installation, and how does it ensure consistency in a Node.js project? Verifying installed npm package versions after installation ensures that the correct versions are in place, which is crucial for maintaining consistency across different development environments. This practice helps prevent unexpected issues caused by version mismatches, ensures compatibility with other dependencies, and supports stable project behavior. By confirming that the specified versions are installed, you can confidently manage dependencies and avoid problems that might arise from automatic updates or version conflicts. So let's go over managing outdated npm packages. Maintaining the dependencies of your application ensures you benefit from the latest bug fixes, performance improvements, and security patches. Here's how to identify and update outdated packages in your Node.js project. I'll open up the integrated terminal, so Command J, and I'm currently in the npm demo directory that we created. So this contains our package.json file. To check which packages are outdated in your project, you can use the npm outdated command. This will display all dependencies with newer versions available, showing the current version you're using, the latest version available, and the desired version. The desired version is the highest version permitted by your versioning rules in your package.json file. So currently for our project, here if I view the dependencies we have installed, we have Axios and we have underscore. Both of these are currently the latest versions, so when I run npm outdated, nothing will show up since these are the latest possible versions. To demonstrate that, I'll do npm outdated. So currently there is no result because I have the latest versions. Navigate outside of this directory, and so if I run npm outdated, this will show the outdated packages that I have installed globally on my system. So here this demonstrates the current version I have installed, the desired version, and the latest version. So let's go over updating packages. To update all packages to the newest versions that do not include breaking changes, so this typically includes minor updates and patches, you can run the following command. So I'll run npm update. So this command updates the packages within the semantic versioning constraints specified in your package.json file. It will not update packages to a new major version that could contain breaking changes. So let's go over handling major updates. Sometimes you may need or want to update packages to their latest major versions, which might include breaking changes. To handle this, you can use a tool called npm check updates. So let's install that globally. So I'll use the sudo command npm install -g, then npm check updates. I'll enter my password. So now we can run npm check updates to see which packages have new major versions available. So I can run npm check updates. You can then use the tool to update your package.json to the latest major versions. So you would do npm check updates and then the flag -u or the shortcut ncu-u. So to reinstall dependencies, after updating package.json with npm check updates, the packages themselves are not automatically updated in your node modules directory. You need to reinstall them to sync your directory with the updated package.json. So you can run npm install. Let's go over best practices. The first best practice is testing. Always thoroughly test your application after updating dependencies, especially when major versions are involved, to ensure no breaking changes disrupt your application. The second best practice is version control. Commit changes to your package.json and package.lock.json file after updates. This ensures that your team or deployment environments use the same versions. So in conclusion, regularly updating the npm packages in your Node.js projects is crucial for maintaining the security, efficiency, and reliability of your applications. Tools like npm check updates helps manage the lifecycle of your dependencies, allowing you to take advantage of the latest improvements while carefully managing the risk of breaking changes. What are the best practices for safely updating npm packages, particularly when handling major version changes? Best practices for safely updating npm packages include, first, to review updates, so use tools like npm outdated or npm check updates to identify and review available updates. The second is to test thoroughly. After updating, especially when upgrading to a major version, thoroughly test your application to catch any breaking changes. Third is to use version control. Always commit changes to package.json and package.lock.json to ensure consistency across environments. And fourth, update incrementally. Where possible, update packages incrementally rather than all at once to isolate issues more easily. These steps help maintain stability and minimize the risk of disruptions. Managing dependencies in Node.js projects. In Node.js development, it's important to differentiate between dependencies required for the application to function in production and those needed only during the development process. So let's go over understanding dependencies. First, let's consider production dependencies. These are the packages your application needs to function correctly in the production environment, such as frameworks like Express, or a database library like Mongoose, or any other libraries necessary for the runtime execution of your app. So the second type of dependency is development dependencies. Development dependencies are tools and libraries used only during the development process, such as compilers like Babel, testing frameworks like Mocha, or static analysis tools like JSHint. These are not needed in production and should not be bundled with your production build. So let's go over installing development dependencies. To install a package as a development dependency, use the savedev flag. This tells npm to save the package under DevDependencies in your package.json file. This distinction is crucial for keeping production environments lightweight by excluding unnecessary packages. So we can run the command npm install JSHint savedev. So here I'm running it in the directory that contains the package.json file, and I see another property has been added named DevDependencies, which includes the package that I just specified. So let's go over the benefits of correctly categorizing dependencies. The first is optimize production builds. By segregating development dependencies, you can ensure that your production environment only installs what is necessary, reducing deployment size and potentially improving application performance. The second benefit is clear project organization. Keeping a clear distinction between dependencies and DevDependencies in your package.json file helps maintain organization and clarity. This makes it easier for other developers to understand the project setup. Managing node modules. Both production and development packages are stored in the node modules directory when installed. The distinction in package.json helps npm understand which packages to install in different environments, and you would use the environment variable, node_env, and set it to development or to production. So let's discuss deploying to production. When deploying your application, you can ensure that only production dependencies are installed by setting the environment variable, node_environment, to production and running npm install. npm will skip developer dependencies in this case. So in conclusion, properly managing production and development dependencies is vital for efficient development workflows and optimized production deployments. By categorizing your packages appropriately in package.json, you can maintain a lean and efficient application setup that ensures only necessary packages are included in production environments. This practice not only optimizes performance, but also enhances security by minimizing the attack surface of your application. Why is it important to differentiate between production and development dependencies in a Node.js project? Differentiating between production and development dependencies in a Node.js project is crucial because it ensures that only the essential packages needed for the application to run are included in the production environment. This reduces the deployment size, improves performance, and minimizes security risks by excluding unnecessary tools used only during development, such as testing frameworks or build tools. Proper categorization also helps maintain a clean, organized project structure, making it easier to manage and understand. How does proper management of dependencies impact the efficiency and security of a Node.js application in production? Proper management of dependencies in a Node.js application impacts efficiency by ensuring that only necessary packages are included in the production environment, reducing the application size and improving performance. It also enhances security by minimizing the attack surface, as fewer packages mean fewer potential vulnerabilities. By installing only production dependencies, you avoid including unnecessary tools that could introduce risk, leading to a leaner, more secure, and optimized application in production. So let's go over uninstalling a package. Over time, you may find that certain npm packages are no longer needed in your application. Removing these packages helps keep your project lean and prevents unnecessary bloat in your node modules directory. To remove an installed package, you can use the npm uninstall command followed by the package name. This command removes the package from your node modules directory and updates the dependency list in your package.json file. So if I wanted to remove the JSHint package that we installed in the previous lesson, I can do npm uninstall and then the name of the package. So in this case, JSHint. I could also use the shorthand, which is npm and then un, then the name of the package. So here I see my package.json file has been updated. So let's discuss the effects of uninstalling. When you uninstall a package, npm automatically updates your package.json file, removing the package from the list of dependencies or DevDependencies, depending on where it was listed. So updating node modules. The corresponding package directory and its contents are removed from the node modules folder. This cleanup helps reduce the overall project size and declutters your development environment. So let's discuss best practices. The first is to verify dependencies. Before uninstalling a package, make sure it is not required by any other part of your application. You can check where and how a package is used in your project to avoid removing a package that is still in use. The second best practice is to commit changes. After uninstalling a package and verifying that your application still functions as expected, commit the changes to your version control system. This keeps your repository up to date and allows other developers to be aware of the changes in dependencies. The third best practice is regular maintenance. Periodically check your package.json file and your project dependencies to identify and remove packages that are no longer necessary. This practice keeps your project clean and minimizes potential security risks associated with outdated or unused packages. In conclusion, regularly updating and cleaning up your project's dependencies are crucial steps in maintaining a healthy codebase. Uninstalling unused packages reduces the complexity of your project, decreases load times, and lessens the risk of conflicts or security vulnerabilities. By keeping your package.json and node modules directory streamlined, you ensure that your project remains efficient and manageable. Why is it important to regularly remove unused npm packages from a Node.js project? And how does this practice contribute to project maintenance? Regularly removing unused npm packages from a Node.js project is important because it helps keep the project lean and efficient. It reduces the size of the node modules directory, improving load times, and minimizing potential security risks from outdated or unnecessary packages. This practice also simplifies project maintenance by reducing clutter, preventing dependency conflicts, and ensuring that only essential packages are included in the application. Keeping the codebase clean and manageable enhances the overall health and stability of the project. What steps should developers take before and after uninstalling npm packages to ensure their Node.js project remains functional and up to date? Before uninstalling npm packages, developers should verify that the package is not in use by checking where and how it is utilized in the project. After uninstalling, they should thoroughly test the application to ensure it still functions correctly without the removed package. It's also important to update the version control system by updating the changes to package.json and package.lock.json. This process ensures that the project remains functional, clean, and up to date. So let's go over working with global packages. In Node.js development, some packages are not tied to a specific project, but are rather tools or utilities used across multiple projects. These are typically installed globally on your system. So let's go over installing global packages. First, let's discuss the purpose of global installation. Global packages are typically command line tools or utilities that you want to run from anywhere on your system, not just within a specific project. For instance, this could include package managers like npm itself, or project scaffolding tools like Angular CLI, which is a framework for building web applications. These two packages, for example, are commonly installed globally. To install a package globally, you would use the -g or -g, or the -- global flag with the npm install command. This tells npm to place the package in a special system-wide location that Node.js can access from any directory. So for example, if you were installing the Angular web framework, you would run the command npm install, then the flag -g, and then the name of the package, which is @angular/CLI. This installs the Angular CLI globally, which you can then use to create new Angular projects from anywhere on your system. So step 3 is updating npm itself. npm can also be updated globally using the same flag. This is useful to ensure that you have the latest features and security updates. So to do this, you would run the command sudo npm install -g npm. Now a note for permissions, on macOS and Linux, you might need to use the sudo command to install global packages. This depends on your system's permission settings. However, setting up npm to run without sudo can avoid permission issues and is recommended for security reasons. Managing global packages. To manage and update your global packages, you can check which ones are outdated by running npm outdated and then the flag -g. This command lists all globally installed packages that have newer versions available. Upgrading global packages. If you find outdated global packages, you can update them by reinstalling with the npm install -g command, specifying the package you wish to update. Let's discuss best practices for global packages. The first is to minimize global installations. Install packages globally only when necessary. Overuse of global installations can lead to version conflicts between projects and complicate dependency management. The second best practice is regular updates. Keep your global packages updated to leverage new features and security enhancements. The third best practice is to document globally installed tools. For team projects, document the tools required globally so all developers set up their environments consistently. In conclusion, global npm packages are essential tools for development, offering functionalities that extend across multiple projects. Properly managing these packages ensures that your development environment is both effective and secure. By regularly updating and maintaining the global packages, you can avoid potential conflicts and keep your system optimized for all your development needs. What are the benefits and potential risks of installing npm packages globally instead of locally in a Node.js development environment. So the benefits of global installation is that global npm packages are accessible from any directory on your system, making them ideal for command line tools or utilities used across multiple projects, such as project scaffolding tools or linters. So for the potential risks, overusing global installations can lead to version conflicts between projects, as different projects may require different versions of the same tool. It can also complicate dependency management and make it harder to maintain consistent environments across different machines or for different team members. How can developers effectively manage and maintain global npm packages to ensure a consistent and secure development environment? Developers can effectively manage and maintain global npm packages by following these 3 steps. The first is to minimize global installation, so only install packages globally when necessary to avoid version conflicts and simplify dependency management. Step 2 is regular updates. Frequently check for outdated global packages using the npm outdated and -g flag and update them to ensure security and access to the latest features. And step 3 is documenting requirements. Clearly document any global tools needed for a project, ensuring that all team members can set up consistent and compatible environments. These practices help maintain a stable and secure development environment. So let's go over publishing a package. Creating and publishing your own npm package can be a rewarding process, allowing you to share your work with the wider Node.js community. So to do this, step 1 is to set up your package. So we'll open up the integrated terminal, and I will make a new directory, and I'll just call this new library. We'll change into this new directory. So step 2 is to initialize the package. We'll use npm init to create a package.json file with the default values. So we will pass the --yes flag, which auto-accepts the default options. So we can run npm init --yes. So this creates the package.json file. So we see our new directory here. Opening up the integrated terminal again with Command J. Let's scroll down. So step 3 is to create the main file. So we'll create an index.js file where we will write the code for our package. So from the command line, I can do touch index.js to create that new file. So we see that added here. Now we will add some functionality. So I can say module.exports.add, and I'll assign this to a function which takes 2 parameters and returns the result of adding them. So a plus b, and this with a semicolon. So now you need to create or use an npm account. So for the account setup, if you don't already have an npm account, you will need to create one. This can be done from the npm website or directly from the command line. So you can run npm add user. If you already have an account, then simply log in with npm login, and you will be prompted to enter your username, password, and email address. So step 3 is to publish your package. So to prepare for publishing, ensure that your package.json file includes a unique name for your package. npm requires that package names be unique to the registry. So now you're ready to publish the package. Once you are ready and have verified that all information is correct, you can publish your package to npm using the command npm publish. So this command uploads your package to the npm registry, making it available for others to install. So now you want to verify installation, and you want to test it. So to ensure that your package can be installed from another project, create a new directory elsewhere on your system, and install it. So for example, you can do make directory, and then name that directory, and change into it. Then you can run npm install, and then that package that you created. So test the functionality in this new project environment to confirm everything works as expected. So after publishing, you want to be sure to perform updates and maintenance. So after publishing, you might need to update your package with improvements or bug fixes. So make changes in your local project, increment the version number in your package.json file, following the semantic versioning rules, and run npm publish again. So now let's discuss metadata and visibility. npm automatically adds metadata to your published package. This includes information like the publication date, version history, and dependencies. This metadata is crucial for users of your package to understand its history and stability. In conclusion, publishing a package on npm is a straightforward process, but requires careful setup and attention to detail to ensure that the package is functional and useful to others. By following these steps, you can contribute your own modules to the NPM ecosystem and potentially help thousands of developers worldwide. What are the key steps involved in creating, publishing, and maintaining an NPM package for the Node.js community? The key steps to create, publish, and maintain an NPM package involve first, setting up, so create a directory, initialize it with npm init, and write your package's code. Step 2 is publishing, so create or log into an npm account, ensure your package name is unique, and publish it using npm publish. Step 3 is verifying, so test the package by installing it in a different project to ensure it works as expected. And step 4 is maintaining. Update your package as needed, increment the version number, and republish it to keep it current and useful for others. Why is it important to verify and test your NPM package after publishing? And how can this impact its usability by other developers? Verifying and testing your NPM package after publishing is crucial to ensure it works as intended in different environments. This step helps identify and fix any issues that might arise, ensuring that the package is reliable and user-friendly for other developers. If a package is not properly tested, it can lead to errors and frustrations for users, reducing its adoption and usability. Thorough testing enhances the package's credibility and usefulness within the developer community. So let's go over updating a published package. When you've made changes to your NPM package, such as adding new features or fixing bugs, you must update the package's version before republishing it. This ensures that users can keep track of changes and upgrade their installations appropriately. So step 1 is to make changes to your package. So here we can modify the code. So in your package directory, you can make any necessary changes. So for example, if you wanted to add a multiplication function to your package, so I can say module.exports.multiply, set that to a function, which takes 2 parameters, and returns a times b. So step 2 is to update the package version in your package.json file. So here the current version is 1.0.0, and before we can publish it, we need to update its version. So npm uses semantic versioning, which includes major, minor, and patch updates. So once again, the major version makes incompatible API changes. The minor version adds functionality in a backwards compatible manner, and the patch version makes backwards compatible bug fixes. So from the command line, we can run npm version major for breaking changes, npm version minor for new features that are backwards compatible, npm version patch for backwards compatible bug fixes. So in this case, we can run npm version and then minor. And here we see our version has been updated in our package.json file to be 1.1.0. This command updates the version number in your package.json and creates a new commit if your package directory is a Git repository. So step 3 is to publish the updated package. So after updating the version, you are now ready to publish the updated package. So you can run npm publish. If you try to publish without updating the version, npm will return an error because the package version must be unique. Following the version update, the publish command should succeed. Additional considerations. Before publishing an update, thoroughly test your package to ensure that new changes do not introduce bugs or break existing functionality. Documentation. Update your README Markdown file or any documentation to reflect changes made in the new version, especially if you've added new features or made significant modifications. In conclusion, updating a published NPM package requires careful attention to version management and compatibility. By following semantic versioning rules, you can communicate the nature of changes in your package updates to users effectively. Always ensure that your updates are well tested and documented, which helps maintain and enhance the package's utility and credibility in the community. Why is semantic versioning important when updating an NPM package, and how does it help communicate changes to users? Semantic versioning is important when updating an NPM package because it clearly communicates the type of changes made, helping users understand the impact on their projects. By using version numbers to indicate major breaking changes, minor new features, or patch bug fixes, developers can manage expectations and allow users to update dependencies safely. This practice ensures that users can confidently upgrade to newer versions without unexpectedly breaking their applications. Which best practices should developers follow when updating and republishing an NPM package to ensure its reliability and usability? When updating and republishing an NPM package, developers should follow these best practices. The first is to use semantic versioning. Clearly communicate the type of changes, which could be major, minor, or patch, to users. Then do thorough testing. Ensure all new changes are well tested to prevent introducing bugs or breaking existing functionality. Third, update documentation. Revise README Markdown files and other documentation to reflect the latest changes and new features. Then commit those changes and tag if necessary. If using version control, commit the changes and tag the new version before publishing. These practices help maintain the package's reliability and usability. Synchronous versus asynchronous code. So let's set up a new project. We'll open up the integrated terminal with Command-J or Control-J if you're on Windows. We'll run the command, make directory, and we'll name it async demo. Let's change directory into that new folder we created. Now we want to initialize a new Node.js project. We can do that with npm init. Then we'll pass in the flag --yes to accept the defaults. So this created our package.json file. We can clear this out. Now we want to create a new file. We could do this from the command line, and we will run touch index.js. So now, if we expand this directory and click into our index.js file, first we will write synchronous code. So we can add the following console statements. We can do log and then tab for that keyboard shortcut, and we'll log out the string before. So now we'll do shift option and down arrow to copy this line, and then we'll do after. So this code is a simple example of synchronous or blocking programming. So here the program awaits for the first console log statement to execute and to complete before moving on to the second one. We can just output this, node index.js, and we get our expected console log output. So introducing asynchronous programming. In contrast, asynchronous programming allows the program to move on to other tasks before the previous ones have completed. So we will modify our file. Here we will use the setTimeout method. setTimeout. So for the parameter, we will pass in a callback function. So we're using the modern ES6 syntax, our arrow functions. So within this code block, we can, I'll say a comment, simulate a call to the database. So let's say we can call to a database that contains information on our grocery list. We can do log, and we'll say reading a grocery item from a database. So for setTimeout, the first argument that we pass in is the callback function. It also accepts a second argument, which is the time to wait before executing this code. This is represented in milliseconds. So we'll say 2000, represent 2 seconds. And let's execute this program. So let's open up the integrated terminal with Command-J. Up arrow, and we'll run it again. So here we see before, then after. For our setTimeout, it waits 2 seconds, and then it logs out this console log statement. So this is an example of asynchronous programming. So this demonstrates that setTimeout schedules the task to be performed later without blocking the execution of subsequent code. Understanding asynchronous programming. Asynchronous programming is not the same as concurrent or multi-threaded programming. In Node.js, asynchronous code runs on a single thread. It's crucial because operations involving disk or network access in Node.js are handled asynchronously, allowing the program to remain responsive. Asynchronous programming helps ensure that your application can handle multiple operations efficiently, without getting stuck waiting for one task to complete before starting another. How does asynchronous programming improve the efficiency and responsiveness of a Node.js application, especially in handling I/O operations? Asynchronous programming improves the efficiency and responsiveness of a Node.js application by allowing the program to continue executing other tasks while waiting for I/O operations, such as a database call or file access to complete. This non-blocking approach ensures that the application remains responsive and can handle multiple operations simultaneously, rather than being held up by slow operations. As a result, the application can serve more users and manage more tasks without delays or bottlenecks, leading to better performance overall. What are the key differences between synchronous and asynchronous programming in the context of Node.js? And why is it important for developers to understand these differences? Synchronous programming in Node.js executes tasks one after the other, blocking the execution of subsequent code until the current task is finished. Asynchronous programming, on the other hand, allows the program to initiate tasks, like I/O operations, and move on to other tasks without waiting for the previous ones to complete. Understanding these differences is crucial because asynchronous programming helps prevent bottlenecks, making applications more efficient and responsive by not allowing a single slow operation to halt the entire program. So let's discuss patterns for dealing with asynchronous code. Let's first go over an example of incorrect synchronous code. So we'll build upon the previous code snippet that we did in our previous lesson. So we have our console log statement outputting before, and then we call setTimeout. So let's abstract this and let's put this into a function. So we use the function declaration syntax, and we'll name it getGroceryItem, and it takes in an ID, our curly braces. And let's move this, so we'll copy this, and we can paste it in the block. So rather than just console logging, we will return a JavaScript object which contains an ID and a name. So we'll say apples is the name of the grocery item, end it with a semicolon. So now let's call this function. I can say const grocery item, say get grocery item, and we'll pass in the value of 1 as the ID. Let me just add a comment here so we know what to expect. So we cannot get a grocery item like this, as we will see. Then let's do console log. We will output the grocery item. So note that when we do this, this will have the value of undefined. The reason is because when we call getGroceryItem, the item isn't returned immediately. Because we call setTimeout, there's a 2-second delay before we get this grocery item object. Let's open up the integrated terminal, up arrow, and we will execute this file. So here we get before, undefined, then we get this output, after, and then this console log statement within the setTimeout. So this function, getGroceryItem, is intended to simulate fetching an item from a database. However, due to the setTimeout function, it does not return the grocery item immediately. Instead, it schedules the operation to occur after 2 seconds. So the console log and then the grocery item executes before the grocery item data is available, resulting in undefined. The key reason this does not work as intended is because setTimeout is asynchronous. The function does not wait for 2 seconds to return the grocery item data, rather it returns immediately and the code continues executing. So let's correct this approach. When dealing with asynchronous operations like database calls, the result is not immediately available. Here are 3 common patterns to handle asynchronous code in JavaScript. The first being callbacks, the second being promises, and the third being async await. So first let's discuss using callbacks. So we will fix our code to utilize that pattern. So we have our console log statement. Actually, let's comment this out and we will start again from scratch. So here, we can do console.log, output the string before. Then we can implement getGroceryItem. This takes in an ID, and it will accept a second parameter, which is a callback function. We can call setTimeout, and this also accepts callback function with a 2-second delay. So within it, let's output, I'll say, reading a grocery item from a database. And we'll say callback. Then we'll pass in the object, right? The grocery item object, the ID, and then the name, which we will say is Apple. and that with a semicolon. So we want to utilize the getGroceryItem function. In its implementation, it is using the asynchronous method of setTimeout. So we can call getGroceryItem, pass in 1 as the ID, and then for the callback, we specify an ES6 arrow function. Right, so we're using the modern syntax, GroceryItem, arrow, and then the curly braces. And here we will define our implementation. And here we will just output the grocery item that is returned. Right, so this object is passed into the callback. And so this object will be the grocery item that we are outputting to the console. And then one more log, which is the string after. So now we will execute this, up arrow. So we can run this. So we get before and after. Then it waits 2 seconds. And then we see reading a grocery item from a database, and then our expected grocery item object. If I scroll up, previously when we had our synchronous code, we were outputting the grocery item and getting the value of undefined. So this is a pattern known as callbacks. So I'll just add a comment here and I'll say callbacks. And for now, I will comment it out and paste it. So now we will update this and it will use promises. So we have our console log statement saying before, and then we have the getGroceryItem function. So rather than calling setTimeout as this, we can utilize a promise object. So a promise is an object that holds the eventual result of an asynchronous operation. So we can use the return keyword, and I'll say new promise. This accepts 2 parameters. So resolve in the case when it works successfully, and reject in the case when there was an error. So this is an arrow function, right? So a callback. We will explore each of these concepts in more depth throughout this section. Just wanted to introduce it to you all at once. So we moved up the setTimeout to be within the callback function. Now we can remove callback. And rather than saying callback, we say resolve, because it successfully returns a grocery item. So now we have to change how we're utilizing this. So we only need to pass in the ID, but we have special methods in order to access the data within the promise. So we use a special method, which is then, which is executed in the case when the promise successfully resolves. So we'll take in the item, and we will console log it. And we also need a method .catch. Let's end this with a parenthesis. In the case when there is an error. So if there is an error, in the case when it is rejected, then this code will run. So I'll say console.error, and then the error. And that with semicolon. So now, open up our integrated terminal. We'll run this, so we see before, after. And once again, this waits for 2 seconds. Then it returns a promise. So we can access the data within that promise with the .then method. And then we output it to the console. All right, so we'll explore this more in detail in future lessons. For now, let's just add a comment. I'll say promise. Let's copy this, and we'll build upon it for our next example. We'll comment it out for now. Now we will cover async await. So async await are special keywords that allow us to execute this code with cleaner syntax. So here we are using the .then and .catch methods and chaining them in order to access the data that is returned from our promise. So we'll keep our getGroceryItem function to be the same, but we can have different syntax to make this cleaner to read. So I can use a special keyword known as async, which means that this function contains an asynchronous operation. So I'll name the function display grocery item. So we will say grocery item. Then we'll use another keyword, await, and then we will specify our function, which has the asynchronous operation. So in this case, the setTimeout function. Then we can simply log it out. Grocery item. So rather than using this syntax and chaining the .then and .catch methods, we can just call display grocery item and pass in the ID of 1. Open up our integrated terminal, run it again. So we see, once again, before and after. And once this asynchronous operation completes after 2 seconds, then we successfully log it to the console. So let's do a quick summary. First, we covered callbacks. So these are functions passed as arguments to be executed once an asynchronous operation is complete. We covered promises, which are objects representing the eventual completion or failure of an asynchronous operation. And lastly, we covered async await. So this is syntactic sugar over promises, making asynchronous code look synchronous. Understanding these patterns is crucial for handling asynchronous operations, such as database calls in JavaScript. What are the main methods for handling asynchronous operations in JavaScript, and why is it important to understand them? The main methods for handling asynchronous operations in JavaScript are callbacks, promises, and async await. Callbacks involve passing a function to be executed after an asynchronous operation completes. Promises represent the eventual completion or failure of an asynchronous task and provides methods like .then and .catch for handling results. Async await is built on promises, allowing asynchronous code to be written in a more readable, synchronous-like style. Understanding these methods is crucial for managing tasks like database calls, ensuring efficient and correct code execution. How does the asynchronous nature of JavaScript impact the execution order of code, and what are the strategies to manage this effectively? The asynchronous nature of JavaScript means that code doesn't always execute in the order it's written. Some tasks, like I/O operations, run in the background while the rest of the code continues. This can lead to unexpected results if not managed properly. To handle this, developers use strategies like callbacks, promises, and async await to control the flow of asynchronous operations, ensuring that tasks complete in the desired order and their results are handled correctly. So let's discuss callbacks in more detail. First, if we look over our example of the incorrect synchronous code, where we call a function getGroceryItem, which is utilizing setTimeout with a 2-second delay. When we output it, we get the value undefined because the value is not immediately available. So this code mimics trying to get a grocery item from a database, but it doesn't work as intended because the function getGroceryItem uses setTimeout, making it asynchronous. So the console log statement executes before the grocery list data is available, resulting in undefined. A callback is a function that is passed as an argument to another function, to be executed once an asynchronous operation is complete. So let's go over using callbacks correctly. So we have our updated version of the code, which utilizes callbacks. So we have our callback parameter, and then we invoke it within the asynchronous operation. So let's discuss accessing nested asynchronous data. So to handle multiple asynchronous operations, such as fetching a user's grocery list and then fetching the grocery item data, you can nest callbacks. So here, when we call getGroceryItem, we're currently just outputting it. So let's say we're calling getGroceryList. This takes in an ID, and then a parameter, which is a callback function. This is an asynchronous operation, so we'll mimic that with the setTimeout function. Pass in our arrow function, which has a 2-second delay. I'll add a comment and I'll say simulate a call to the database log, and I'll say fetching grocery lists from the database, and then we'll utilize our callback and we'll pass in the argument, which is a JavaScript object representing the grocery list. So it's a property of items, which takes in an array. So we'll say apple, bananas, and we'll say bread. So we can end that with a semicolon. Let's update our getGroceryItem. So I can say, I'll say fetching grocery item from, I'll say the grocery list. Just to better describe what we're trying to implement here. So I'll say callback, and we'll say the array is apples, bananas, and bread. So now we want to utilize getGroceryList So rather than calling getGroceryItem, we'll say getGroceryList. This accepts an ID, so we'll say 1. And then our callback function, so it'll be a grocery list. We'll pass in an arrow function. So I'll log, and I'll output grocery list, comma, grocery list. So now I will simulate getting the grocery list items, and I'll say get grocery list items, grocery list ID, and then a callback function containing the items. And we can output that with items, and then outputting that to the console. And we'll end it with a semicolon. So this is an example of nested callbacks, meaning that you have one asynchronous operation, and once that completes and we have the data that we need, then we make another asynchronous call utilizing that data. So let's comment this out, save it, and then in our integrated terminal, up arrow, and then run. So we get before and then after. Then we get fetching the grocery list, and then the data that we received. And then we call our nested callback function here. So fetching a grocery item, and we get the items. So this demonstrates utilizing nested callback functions. So in summary, callbacks are functions passed as arguments to be executed once an asynchronous operation is complete. Properly handling asynchronous code is crucial when dealing with operations like database access, which may take some time to complete. Why is it important to handle asynchronous operations properly in JavaScript, particularly when dealing with tasks like database access? Handling asynchronous operations properly in JavaScript is crucial because it ensures that tasks like database access, which may take time to complete, do not block the execution of other code. This allows your application to remain responsive, efficiently processing multiple tasks without waiting for each one to finish sequentially. Proper management of asynchronous operations, such as using callbacks, promises, or async await, prevents issues like incomplete data retrieval or unexpected behavior, ensuring that the application functions correctly and smoothly. What challenges can arise when using callbacks to manage multiple asynchronous operations, and how can these be effectively addressed? When using callbacks to manage multiple asynchronous operations, challenges like Callback Hell can arise, where nested callbacks make the code difficult to read and maintain. This complexity increases the risk of errors and makes debugging harder. To address these issues, developers can use techniques such as modularizing callback functions, or better yet, use promises or async await syntax, which allows for more readable and maintainable code by flattening the structure and handling errors more effectively. So let's further discuss nested callback structure. In our previous example, we used callbacks to handle asynchronous operations. So we will expand upon this and we will add another asynchronous operation. So we can add that with, I'll name it check item availability. This will accept one parameter, which is the grocery item, and this utilizes the asynchronous method of setTimeout, pass in our callback, and I'll say checking availability. Then we can say return true, just for simplicity. So if we want to utilize it, we need to do so within the getGroceryItem callback, because we are dependent on that data. So this takes in, you can say items at the 0th index, so the first item. Let's clean this up a bit. So you can clear this. And just so we can more easily see our nested callbacks, we'll remove the outer console log statements. So here we see we have getGroceryList, which is an asynchronous operation. Once that completes, then we call getGroceryItem, which is also asynchronous, and then the asynchronous method checkItemAvailability. So this is simulating making calls to a backend database or a backend API. So in this scenario, each callback depends on the completion of the previous one, resulting in a nested structure. This pattern is often referred to as Callback Hell or the Christmas tree problem because of its shape and complexity. So let's compare this to synchronous code. So just as a demonstration of what this would look like if all functions were synchronous, right? So it would have the log statement, same before, and then getting the list with get grocery list takes in the ID of the grocery list, and then we get the items of the grocery list following get grocery list items, say list ID. Then we'll check the availability of an item, check item availability, and we'll say the first item in the list. Then we'll output, so log and tab after. So this is an example of how clean and easy to read our code would be if it were synchronous. However, we know that these functions are asynchronous, so the data isn't available immediately. There is a delay before we can receive that. All right, let me just add in the 2-second delay to our callback function, which I forgot to do. So, however, synchronous code blocks the execution of other operations until the current one finishes, which is not ideal for I/O-bound tasks like database queries. So let's discuss the term of callback hell. We scroll back up. So using callbacks for asynchronous code can become difficult to manage and read. Here we see our nested structure. So let's discuss a simple solution. To avoid callback hell, we can use promises and async await syntax. So let's discuss using promises. Promises provide a cleaner way to handle asynchronous operations. So here's an example. For now, we will comment how we are utilizing our asynchronous functions. And rather than calling setTimeout, rather we will return a promise. Right? Once again, a promise is an object that holds the eventual result of an asynchronous operation. So we'll say return new promise, and within it, it accepts a callback. So we'll say resolve. For now, we will close that, and we can move this up. We can move it up with Option up arrow. Close this. So rather than saying callback, we can remove that parameter. It's no longer needed. And rather we call resolve, because it resolved or completed successfully. We updated this one to use promises. Let's update the other functions. Return new promise. This also accepts callback function with resolve. So this here. Once again, Option up arrow. And within here, let's do command and then the right bracket. Better format this code. And we'll do the same here. So it looks cleaner. So once again, we remove this callback. It's no longer needed. And we call resolve. It successfully returns the grocery items. Now we have our last one. We have check availability. So once again, return new promise. Takes in callback function with resolve. Then Option up arrow to move it up. In this case, it just returns the value true. So in this case, we can just say resolve. We'll just say the value true. So now we want to utilize this. So for now, we can delete this example we had of synchronous code and just to demonstrate what we would like the syntax to look like. Let's make some space here. And now we will utilize these functions that are utilizing promises. So we can call get grocery list, takes in the value 1, then get the list, and we call get grocery items, takes in the list ID. Then we can chain .then, right? So the result of get grocery list item or get grocery item. So get the items, and we'll say check item availability, items at 0. And we'll just say .then, and we'll say availability, console.log, availability, and then this value. We'll also include our method, or chain our method for catch, in case there's any error, console.log. Actually, we'll do console.error, and then the error. So this is an example of utilizing promises So we use the .then method and .catch methods. So rather than having the nested structure, we just chain our .then methods. We can execute this, so up arrow and run, before and after, and there are 2-second delays as the asynchronous operations complete. So everything worked as expected, and we have cleaner syntax. So let's discuss using async await. So the async await syntax, built on top of promises, further simplifies the code. So currently, let's say in get grocery list, we are returning a promise. Let's say if we're using the async await keywords, so we can mark it as async, and when we mark it as async, we can now utilize the await function within it. So rather than calling get grocery list and then chaining all these methods, we'll create a new method, and we can name it display availability. We will mark it as async. So once we mark it, then we will utilize the await keyword within it. We will wrap it in a try catch. Console.error. And now we want to utilize these asynchronous operations. So because these are asynchronous and they're returning a promise, we can use the await keyword. So we'll say list, await, get grocery list, pass in the ID. Then, once this data is available, then we can call await get grocery item with the list ID. Right, so once this returns, right, we await this result. Then we check the availability. Await, check item availability, items at 0. And then say console.log availability, and then this result. So rather than utilizing this syntax, comment this out, and we'll just call display availability. So this function, which utilizes the async await keywords, is the equivalent of this function call with the chained methods. But our code here, which utilizes async await, looks more similar to synchronous code, so it's easier to read. So let's run this. So we see before and after, 2-second delay, and we get our expected result with cleaner syntax. So this is the modern way to do it, with async await. So in summary, callbacks can lead to nested structures that are difficult to manage. Promises and async await provide cleaner, more readable ways to handle asynchronous code. What are the benefits of using promises and async await over callbacks in managing asynchronous operations in JavaScript? Using promises and async await in JavaScript offers several benefits over callbacks. The first being readability. Promises and async await result in cleaner, more linear code that is easier to read and maintain, avoiding the nested structure of callbacks, otherwise known as Callback Hell. The second benefit is error handling. Promises provide better error handling through the .catch method and try-catch blocks with the async await keywords, making it easier to manage asynchronous errors. The third benefit is control flow. Promises and async await allow for more intuitive control flow, helping developers manage asynchronous operations more effectively. How does the use of promises and async await help prevent issues like callback hell in JavaScript programming? The use of promises and async await in JavaScript helps prevent callback hell by making asynchronous code more linear and easier to follow. Promises allow chaining of asynchronous operations with the .then method instead of deeply nested callbacks, while async await further simplifies the syntax, making the code look and behave more like synchronous code. This reduces complexity, improves readability, and makes error handling more straightforward, resulting in cleaner and more maintainable code. So now let's discuss name functions. So we use name functions to simplify callbacks. When dealing with nested callbacks, you can replace anonymous functions with name functions to flatten and simplify the structure of your code. This approach makes your code more readable and easier to manage. So here's how you can refactor nested callbacks using name functions. So implement this from scratch just to ensure that everything makes sense, and it's good to get more practice. So once again, we have our log statement, say before, and then shift option down arrow, after. Now we'll implement our functions again. Get grocery list, takes in an ID, and a callback. So that's the 2 parameter variables it accepts. Then set timeout, which is an asynchronous operation. The argument takes in is a callback function. And here we are, simulating a call to the database. We can log that out. So I'll log out fetching grocery list from the database. Once again, this calls the callback and invokes it. Pass in the object, which is an ID, and a name, which is say that's weekly groceries, and that with a semicolon. And there is a 2-second delay. So now, to help us save some time, we can just copy this and paste it, and we'll rename it to be get grocery items. So for our console log, we'll say fetching grocery items. So for our callback, this accepts an array, and we'll just say milk, bread, and eggs as the data that we pass in. Once again, we can copy this and paste it, and we'll name this to be check item availability. So we'll update our console log statement, which will be checking item availability. So for our callback, we'll pass in a JavaScript object, which will contain the item and the availability. So I'll say available, set to true. So now we implemented 3 asynchronous operations, each which have a 2-second delay. Now in order to actually utilize this, we want to have name functions. So let's implement some functions here. And I'll call this handle grocery items. This takes in a list. And I'll call get grocery items, the list ID, and handle item availability. So now implement takes in the items, and within it, this calls check item availability. So I'll say the first item, and then I'll pass in callback, so display availability. So now we need to implement that name function. This takes in the availability. This outputs to the console availability. Pasting that here. So now I can call get grocery list. The ID will be 1. And then for the callback, I'll say handle grocery items. So that will call this function, which will call get grocery items. And then for the callback is handle item availability. Then this calls check item availability. And then after, within it, the display availability is called, logging to the console. We can execute this. Before and after, then we get our 2-second delays and our expected console outputs. So here we see item is not defined. Let's see here in checking item availability. Yeah, so for ID, it's supposed to be item. Run it again. Now we get our expected output. We just need to change the name of that parameter. So explanation, Let's first discuss name functions. By defining name functions, let's scroll up. By defining name functions like handle grocery items, handle item availability, and display availability, you can avoid deep nesting and improve the readability of your code. Let's discuss passing references. Note that we are passing references to these functions. So this includes handle grocery items, handle item availability, and display availability, instead of calling them directly. So what are the advantages? The first is readability. The code is easier to read and understand. The second advantage is reusability. Name functions can be reused elsewhere in the code if needed. Limitations. While using name functions helps, it's not the most efficient way to handle asynchronous code. For a better approach, consider using promises. So using promises. Promises provide a cleaner, more manageable way to handle asynchronous operations compared to nested callbacks. So here's how you can convert the above example to use promises. So here, for each of these functions that we implemented, we want to call return new promise. This object takes in the callback, so resolve. And we just move this up, option up arrow. And then instead of callback, we just call resolve. We can remove the callback parameter. We just repeat this, so return new promise, takes in and resolve. Move that up, option up arrow, save that. And one last time. Oh yeah, we have to remove the callback parameter and then call resolve. Then last time, we get return new promise, takes in, resolve, and we move this up and save that. And we call resolve here. Now in order to utilize that, we will no longer be calling or invoking it like that. Rather, we will call get grocery list, passing in the ID of 1. And then we have our methods .then and .catch. So we chain these methods, list. So I know we did cover this before, but repetition is very good, especially if this is the first time that you are going over promises. So .then, items, and we'll call check item availability, which is the first item in the list. Then, say availability, console.log, availability, and then this parameter variable. And then we end it with .catch. So we'll pass in the error that one occurs, console.error, and then the error. End it with a semicolon. So now we execute this code, which is utilizing promises as opposed to callback functions. So we have before and after, and then 2-second delays for our expected console output. Now we get cleaner syntax without having to pass all of these references to all these functions we created. So using promises makes the code more straightforward and easier to handle, especially as the complexity of asynchronous operations increases. How can refactoring nested callbacks into name functions improve the readability and maintainability of asynchronous code in JavaScript? Refactoring nested callbacks into name functions improves the readability and maintainability of asynchronous code by reducing complexity and avoiding deeply nested structures, known as Callback Hell. Name functions makes the code more organized, easier to follow, and allows for better reuse of code. This approach simplifies debugging and understanding the flow of asynchronous operations, making it easier to manage and maintain the codebase as the application grows in complexity. What are the limitations of using name functions for handling asynchronous operations, and how do promises provide a more efficient solution? The limitations of using name functions for handling asynchronous operations include increased complexity when dealing with multiple asynchronous tasks and a tendency to create deeply nested structures. While name functions improve readability, they don't fully resolve the issue of callback hell. Promises provide a more efficient solution by allowing for a more linear and manageable flow of asynchronous tasks through chaining, which improves readability and simplifies error handling, leading to cleaner and more maintainable code. So let's discuss promises. JavaScript promises are a powerful tool for managing asynchronous operations. A promise is an object that represents the eventual result of an asynchronous operation. It can be in one of three states. The first being pending. So this is the initial state when the promise is still waiting for the asynchronous operation to complete. The second state is fulfilled. The operation completed successfully and the promise has a value. And the third possible state is rejected. So the operation failed and the promise has an error. So creating a promise. To create a promise, you can use the promise constructor, which takes a function with two parameters, resolve and reject, and these parameters are functions used to indicate the completion of the asynchronous operation, either successfully, which would be the case when it resolves, or unsuccessfully, in the case when it rejects. So to demonstrate this, say const p, and then new promise. This takes in a callback, so resolve and reject. It's our arrow function syntax. Then we can start an asynchronous operation, such as accessing a database or calling a web service. So if the operation is successful, then we call resolve with the result. If the operation fails, then we call reject with an error. So in the first case, we'll say resolve to demonstrate an example of a successful operation. So the output, value of p, and we run this. We get the promise with the value of 1, better yet, dot then, so we'll say result, console.log, the result, and we'll just chain these methods actually. So dot catch, error, console.error, passing in that error object. So we'll run this again, and we get the value of 1, which is the value that was passed in when we resolved this promise. Likewise, if we were to call reject, we'll pass in an error, so I can say new error, and I'll say error message. In the case of a failed operation, we execute this, and we get our expected error message. So let's discuss consuming a promise. So once you have a promise, you can use the .then and .catch methods, as we did, to handle the result or the error. Let's go over an example of handling errors. So we'll update this example to simulate an asynchronous operation that failed. So we can call setTimeout, pass in, callback, and we'll say it has a 2-second delay. Let's move this up, so option and up arrow. So now, when we do this, let's update this to be console.log, and we will log out the message of the error. Right, so in this case, it would be error message. So now, when we run this in our integrated terminal, so Command J, up arrow and run, there's a 2-second delay, and then we get the error message. So in summary, a promise starts in the pending state. It transitions to fulfilled if the asynchronous operation completes successfully. It transitions to rejected if the operation fails. We use the .then method to handle the successful result, and we use the catch method to handle errors. Finally, let's discuss best practices. Whenever you have an asynchronous function that takes a callback, consider modifying it to return a promise for better readability and maintainability. This approach helps avoid callback hell and makes the code easier to follow. How do promises improve the management of asynchronous operations in JavaScript, particularly compared to traditional callback methods? Promises improve the management of asynchronous operations in JavaScript by providing a more structured and readable way to handle tasks compared to traditional callbacks. They allow you to chain operations like .then for success and .catch for errors, handling callback hell, and making the code easier to follow. Promises also offer better error handling and simplify the process of managing multiple asynchronous operations, leading to cleaner and more maintainable code. Why is it beneficial to modify asynchronous operations that use callbacks to return promises instead, and how does this practice enhance code readability and maintainability? Modifying asynchronous functions to return promises instead of using callbacks is beneficial because it simplifies the code structure, making it more readable and easier to maintain. Promises allow for chaining operations and handling errors more cleanly with .then and .catch methods, reducing the complexity associated with nested callbacks, known as Callback Hell. This approach leads to more organized and modular code, which is easier to debug and scale as your application grows. So let's discuss resolving Callback Hell by using promises. So in this code that we wrote in a previous lesson, this demonstrates nested callbacks, also known as Callback Hell, which can make your code difficult to read and maintain. So here in this case, we have 3 asynchronous methods, and they depend on each other. So these run one after another. Now you can imagine if we had to perform other asynchronous operations, then we would continue to have to indent and continue to nest these callbacks. So this video is just a reminder that we want to utilize promises when working with asynchronous code. We do this to improve the readability and maintainability of our code base. So in this case, instead of utilizing callbacks, we are returning a promise, right? Once again, a promise is an object that holds the eventual result of an asynchronous operation. And then we can utilize the built-in methods, so .then and .catch, to chain these methods and work with the asynchronous data. This approach makes the code more linear and easier to read, eliminating the deep nesting associated with Callback Hell. So in summary, promises, these are objects representing the eventual completion or failure of an asynchronous operation. Now, these promises can be in different states. So promises can be in one of 3 states. So it could be pending, fulfilled, or rejected. So methods that promises have include the .then method to handle resolve values and .catch to handle errors. And lastly, converting callback-based functions to return promises can significantly improve code readability and maintainability. How do promises help in resolving the challenges of Callback Hell in asynchronous JavaScript programming? Promises help resolve the challenges of Callback Hell in asynchronous JavaScript programming by allowing you to chain asynchronous operations in a more linear and readable manner. Instead of deeply nesting callbacks, promises use .then and .catch methods to handle success and errors, respectively. This flattens the code structure, making it easier to understand, maintain, and debug. By converting callback-based functions to return promises, developers can write cleaner, more manageable code while avoiding the complexity and pitfalls of nested callbacks. What are the key benefits of converting callback-based functions to return promises, particularly in terms of code readability and maintainability? Converting callback-based functions to return promises offers key benefits in terms of code readability and maintainability. Promises allow for chaining operations using .then and .catch, which results in a flatter, more linear code structure, making it easier to read and understand. This approach eliminates the deeply nested, hard-to-manage code typical of callbacks known as Callback Hell. Additionally, promises provide a consistent way to handle errors, further enhancing the maintainability of the codebase. So let's go over creating subtle promises. Sometimes you might need to create a promise that is already resolved. This can be particularly useful for unit testing, where you need to simulate a successful asynchronous operation, such as a web service call. To create a resolve promise, you can use the promise.resolve method, which returns a promise that is already resolved. So we can create a new file here. From the command line, I'll say touch promise API.js. So we can go into this new file that we created, and then we can call const p assigned to promise.resolve. We'll pass in an object, so in this case, it will have a property of ID, the value of 1, and then to access this value, we use the .then method, and we pass in a callback, so we'll get the result, and we'll just output that. Right, outputting the result, open up the integrated terminal with Command J or Control J, and then we will run node promise API.js, and here we get the expected resolve value. So this code snippet creates a resolve promise with an object containing an ID of 1 and logs the result to the console. Now let's go over creating rejected promises. Similarly, you might need to create a promise that is already rejected. For instance, to simulate a failed asynchronous operation in a unit test. You can use the promise.reject method to create a rejected promise. So we can close this out, so Command J, and we'll update this to instead use reject, and then for the argument, we pass in a new error object. So new error, and then the message will be reason for rejection, and 3 dots. So now, there's p.then, we can call .catch. In this case, we can do error, console.log, and I can say error.message. So because we are expecting an error, or the rejection rather, we'll just include the .catch method, right? So remove the .then method. So let's run this. And we're expecting the error message, reason for rejection. Say for rejection. So this creates a rejected promise with an error message, and we log the error to the console. So in summary, resolve promises use the promise.resolve and then pass in the value to create a promise that is already resolved. And for rejected promises, use promise.reject and pass in an error object to create a promise that is already rejected. These methods are useful for simulating different scenarios in unit tests or when you need immediate resolution or rejection of promises. These methods are useful for simulating different scenarios in unit tests or when you need immediate resolution or rejection of promises. How can creating resolved and rejected promises with methods like promise.resolve and promise.reject be useful in testing and simulating asynchronous operations? Creating resolved and rejected promises with methods like promise.resolve and promise.reject is useful in testing and simulating asynchronous operations because they allow developers to immediately generate success or failure outcomes without needing to perform actual asynchronous tasks. This capability is particularly valuable in unit testing, where you may want to test how your code handles resolved or rejected promises, such as simulating successful API responses or error conditions, ensuring your code behaves correctly in different scenarios. So let's discuss running multiple asynchronous operations in parallel. Sometimes you need to run several asynchronous operations simultaneously and perform an action once all of them have completed. For example, you might call different APIs like Facebook and Twitter, or X, and once both calls finish, you return the result to the client. Let's go over an example of this. So we'll have a simulation. I'll say simulation for calling Facebook API. So I'll say const, and I'll say P1 for the first promise, new promise. So we know this takes in a callback, takes resolve as the first parameter, and within it we'll have set timeout as our asynchronous operation. This also takes a callback, and we'll say the delay is 2 seconds, right? So 2000 milliseconds. Then we will log. I'll say async operation, 3 dots, and then resolve with the value of 1. And then we'll have a simulation for calling the Twitter or X API. So we can actually just copy this because it'll be the same syntax. Just need to change it to be P2 to represent the second promise. I'll say async operation 2. And I'll say async operation 1 just so we can differentiate these console log statements. So now I'll say running both asynchronous operations. Let's scroll up so we can see it better. I can say promise.all, and then I'll pass in an array containing both of these promises, so P1 and P2. Now I'll call .then, takes in the result, and I will console log the result. And I'll also do .catch. Wait, let me remove the semicolon. So this takes in an error, console.log, and I'll say error.message. Now we can end that with the semicolon. So this code kicks off two asynchronous operations and uses promise.all to wait until both promises are resolved. The then method is called with the results when both operations complete. So let's execute this. So Command J or Control J, and then node index.js. So once both of them are completed, then we see async operation 1, async operations 2, and then you see the two values that they return, that they resolve to. We update this to be 2. We'll run it again. So once again, we get the expected output. So now let's discuss handling promise rejections. If one of the promises fail, then promise.all will reject and the catch method will handle the error. So if any one of them reject, then the .catch method will be executed. So you can say, for example, rather than this being resolve, we'll specify the second parameter of reject, and we will invoke that. So this operation failed. We can run that. So here we see the error with the value of undefined. So rather than passing 1, let's pass in a new error, and I'll say async operation 1 failed, right, for a descriptive error message, rather than just the value 1. Now we got our expected error message. So in this example, if P1, right, the first promise, right, the simulation for calling the Facebook API, if that fails, then the entire promise.all will reject, and the error will be logged. So now let's discuss using promise.race. If you need to proceed as soon as possible as one of the promises is fulfilled or rejected, you can use promise.race. So rather than promise.all, we can do promise.race. And in this case, with promise.race, the first promise to resolve or reject will determine the outcome. If it resolves first, the then method will be called with the result of the first fulfilled promise. If it rejects first, the catch method will handle the error. So we can see an example of this. Let's run it again. So in this case, the P1 rejected before the second operation. Likewise, let's say if I do comment this out, and if I say resolve with the value of 1. So once again, promise.race will resolve or reject based on the first outcome. So here we see for the result was the value of 1, as the async operation 1 completed first. So in summary, with promise.all, this waits for all promises to resolve. If any promise rejects, the entire promise is rejected. With promise.race, this resolves or rejects as soon as one promise resolves or rejects. These methods help manage multiple asynchronous operations effectively, ensuring that your code is cleaner and more maintainable. What are the advantages of using promise.all and promise.race for handling multiple asynchronous operations in JavaScript? Promise.all allows you to run multiple asynchronous operations in parallel and waits for all of them to complete before proceeding. It's useful when you need all tasks to finish successfully before taking the next step. If any promise fails, the entire operation fails. So with promise.race, it resolves or rejects as soon as one of the promises completes, making it useful when you want to proceed based on whichever task finishes first. This approach can help optimize performance when only the quickest result is needed. How can managing multiple asynchronous operations with promises enhance the efficiency and readability of JavaScript applications? Managing multiple asynchronous operations with promises enhances the efficiency and reliability of JavaScript applications by allowing tasks to run concurrently, reducing wait times. With promise.all, this ensures that all tasks complete successfully before proceeding, making the application reliable when multiple results are needed. With promise.race, this allows the application to respond faster by acting on the first completed task, improving performance in scenarios where the quickest result is prioritized. These tools help structure and control complex asynchronous workflows, leading to cleaner, more maintainable code. So let's go over simplifying our asynchronous code with the async await keywords. JavaScript's async and await features provide a more readable and straightforward way to write asynchronous code resembling synchronous code. So here's an example using promises that we did in a previous lesson. So here we see we have 3 functions which use an asynchronous operation. So each of them are using setTimeout, and each of them return a promise. So to utilize these and to get access to the result of the synchronous operation, we use the .then methods in order to access the data, and we chain the methods. Now we can also implement this using the async await keywords. So rather than doing it like this, I can implement a function, and I'll use the async keyword. We can name this display item availability. So we can say const list. Now we use the await keyword to await the result of the asynchronous operation. So we call get grocery list. We'll pass in the ID of 1. Then we'll get the items. Say await get grocery items. We'll say list.name. See? Yep. So the name of the list. Then we'll get the availability. The await keyword, check item availability. So the first item in the list. And then we'll output availability. And then we output the result of that. So now, let's comment this out for now. And we'll just invoke this method. So now if we were to execute this file, need to change it to the correct directory. That would be 9. I can run. So here I get the output of after, then fetching grocery list from the database, fetching the grocery items, and then the availability of the item. So an explanation of this code, we use the await keyword. So this keyword allows you to wait for a promise to resolve and get its result. You could use it only inside functions marked with the async keyword. So let's discuss async. This keyword is used to declare that a function is asynchronous. It ensures that the function returns a promise. When using await, the JavaScript engine pauses the execution of the function until the promise settles. This makes the asynchronous code look like synchronous code, which is easier to read and understand. So handling errors with async await, in the promise-based approach, the .catch method is used to handle errors. And with async await, you use a try-catch block. So once again, we update this. So I'll say try. Let's highlight all this, and we'll do option up arrow to move it up. Then we can say catch error, and then we can log this error out. So that would be error, do colon, error.message. Better format this, and then we save it. So in summary, async and await provides a cleaner way to write asynchronous code that looks like synchronous code. For error handling, we use try and catch blocks to handle errors when using async and await. Using async and await can make your asynchronous JavaScript code much more readable and easier to maintain. This syntactic sugar over promises simplifies the code structure significantly. How do the async and await keywords simplify the process of writing and understanding asynchronous code in JavaScript? The async and await keywords simplify writing asynchronous code in JavaScript by making it look and behave like synchronous code. Async marks the function as asynchronous, automatically returning a promise, while await pauses the function's execution until the promise resolves. This eliminates the need for complex promise chains and nesting, resulting in more readable, maintainable, and easier to understand code, especially when dealing with multiple asynchronous operations. What are the benefits of using async and await for error handling in asynchronous JavaScript code compared to traditional promise-based methods? Using async and await for error handling in JavaScript provides a more straightforward and readable approach compared to traditional promise-based methods. With async and await, you can handle errors using try and catch blocks, which are familiar with synchronous code. making it easier to understand and manage. This approach avoids the need for chaining catch methods, resulting in cleaner code that is easier to debug and maintain, especially in complex asynchronous workflows. So let's summarize what we covered in this section. So this section was about synchronous versus asynchronous code. Understanding the difference between synchronous and asynchronous code is fundamental in JavaScript. Synchronous code executes sequentially, blocking further execution until the current task is completed. In contrast, asynchronous code allows other operations to continue while waiting for an asynchronous task to complete, improving performance and responsiveness. Let's go over the patterns for dealing with asynchronous code. JavaScript offers several patterns to manage asynchronous operations, the first being callbacks. These are functions passed as arguments to other functions to be invoked once an asynchronous operation is complete. The second pattern is promises. These are objects representing the eventual completion or failure of an asynchronous operation, providing a cleaner way to handle asynchronous logic. The third pattern is Async and Await. This is syntax that makes asynchronous code appear synchronous, enhancing readability. Let's go over callbacks. Callbacks were the original method for handling asynchronous code in JavaScript. They involve passing a function to another function to be executed after an operation completes. So let's talk about the concept of Callback Hell. These are nested callbacks, which can lead to Callback Hell, which is a situation where code becomes deeply nested and difficult to manage. This pattern complicates both reading and maintaining the code. Named functions. To mitigate Callback Hell, named functions can be used to flatten the structure. Instead of nesting asynchronous functions, you define separate name functions and pass them as callbacks. Promises. Promises provide a more manageable alternative to callbacks. A promise represents an operation that hasn't completed yet, but is expected in the future. Promises have three states: pending, fulfilled, and rejected. Replacing callbacks with promises. Promises help avoid the complexity of nested callbacks. By returning promises from functions, you can chain asynchronous operations more straightforward using the .then method for resolve promises and .catch for errors. Consuming promises. Consuming promises involves using the .then method to handle resolve values and .catch to handle errors. This approach results in a more readable and maintainable codebase. Creating settled promises. JavaScript provides promise.resolve and promise.reject methods to create promises that are already settled, either fulfilled or rejected. This is particularly useful in testing scenarios. Running promises in parallel. Using promise.all, multiple promises can be executed in parallel, and you can perform an action when all of them are resolved. If any promise is rejected, the entire promise.all is rejected. Async and Await. Async and Await keywords provide a way to write asynchronous code that looks synchronous. Functions declared with async return a promise, and await pauses the execution of the function until the promise is resolved or rejected, making the code easier to read and maintain. Error handling is done using try and catch blocks. By understanding and applying these patterns, you can effectively manage asynchronous operations in JavaScript, leading to more efficient and maintainable code.